Hello, good morning. Good morning. Welcome to GTech 2013. Focus on mobile and media. So welcome. So I'm Tony Vellum. I'll be your host the next 2 days up here. So feel free, you can check me out anywhere as I'm walking around, ask questions. And so I'll be taking you through some of the fit and finish here in the beginning about what we need to do and how we're all going to participate. So with that, I would like to start out with a thank you to our sponsor. Some of the unsung heroes are often the people that actually write the checks. So here, if you see Awesome hanging around, he's pretty awesome because he actually has helped us fund this. So thank you, Awesome. So this conference is being streamed live. So welcome to all the participants all around the world. We hope you're enjoying your coffee shops, couches, beds. For everybody here, just a reminder, this is being recorded. Your pictures may show up anywhere at any time, and I believe everybody here signed a form on your way in. If you did not, please do that. We would love to be able to use pictures from here, so just a reminder. Okay, so agenda. I'm going to go through the agenda pretty fast so we can get into our talks. If you would like to tweet or G+ about your experience here, please do. One note is this area, I think it's fine to take pictures. The doors out the side, please do not go out of those. Please do not take pictures through the portal. And if you see anything that you're not supposed to see, please instantly forget it and don't take a picture. Everything else is fair game. You have to wear your badges at all times. You should have 2 badges. One is your visitor badge here, and then you have an official building badge. Tomorrow, to speed things up, please keep your day 1 badge. That way we don't have to recheck your ID and everything on the way in. So you'll have to grab a second day badge here. We're hosting tours, so at this point, probably all the tickets are gone for today. I'm not sure about tomorrow, but you can certainly check in the lobby during the break times to get a tour of the office here. It is a super cool office, and I'll tell you some details about it in a minute. Each talk, we will be doing a set of questions. So we have a Dory set up. Here's the link to jump on the Dory. You can vote up or vote down questions. Feel free to add new questions. We will also try to take some live questions as time allows. Here's the link here. So go ahead and you can grab this and sort of jump in and take a look at the moderator. Attendees, we're going to, at lunchtime, we're going to do some roundtable discussions. These are all of you. Many of you have asked to host a topic or a topic table or have discussion. We have very intentionally offered to bring in all the smartest people we know. That would be all of you. So please join into the topic tables. Generally, these are sort of participatory. If you jump at a table, it's not interesting to you. It's certainly fine to get up and go to another table. So nobody will be upset. It's just everybody is trying to optimize for things that they're interested in. Lunch, I guess dinner is going to be on the 5th floor today, which is up in the Water Tower Cafe. It's a very cool cafe. It actually has a water tower that came from New York City here, so you can actually sit in a water tower if you've never done that. Anytime you are anywhere in the building, even going up and down the elevators, please make sure you have a Googler with you, somebody in one of these brightly colored shirts, or maybe you'll see like a Google badge on them. This is a workspace for Google, and so we just need to make sure that everybody has a host at all times. So a little bit about the New York City office here. So this office started in 2000. It actually started in a coffee shop, much like many of the offices for Google. So thanks to Starbucks for, I guess, having all these great places that we can all go work. This is the 2nd largest office internationally, and a shout out to my own office, which is Seattle Kirkland. I believe we're either the 3rd or the 4th. So this is a fantastic office. It encompasses the whole Port Authority building here. One thing I wanted to mention to all of you, if you hear a giant bang sometime today, I highlighted this on the slide. There is a elevator that can fit an 18-wheeler literally in this building. So this building was designed to drive trucks around it. So now we just run scooters all around this building, but there are trucks. Right behind me is actually the elevator for the 18-wheeler. Every now and then you'll hear the bang. I just didn't want you to be surprised if you hear this. And sometimes it can even vibrate the floor. So just heads up, it's probably nothing if you hear the bang coming from this direction. So we do take up an entire city block here. In fact, we actually have two parts. We have this office. We also have a section across over towards the Chelsea Market area. You know, as you go looking around, you go out, you can go into the Chelsea Market. The whole bottom part is actually still a market. That's a fun place to go visit. There are lots of different products here in this office, everything from ads to Google Drive to maps and finance. Google Cloud is here. So really engineers that are working on the products that you know and love are all here in this building. We also have marketing and sales and engagement and support, and so it really takes a big team to deliver fantastic products. A little bit about the New York City culture here. We have many different themed cafeterias. I guess we serve like somewhere around a million plus meals a year here in this office. Just gives you an idea of the scope. We have these great scooters that we can run up and down the hall. Sorry, you probably, unless you go on the tour, you won't be able to do this. But if you're on the tour, you can grab one. We tried this last night. I duly impressed my friend. I took my luggage and my bag and everything. I dropped it on a scooter and we raced across the building, I think in about 45 seconds. So the scooters really get us around this building fast. We have game rooms and break rooms all over the place. You'll see this on the tour, which is great. We are definitely a very diverse company. We support all diversity in all of its glory. And so we have lots of internal groups to sort of communicate and share our thoughts with everybody, which is fantastic. I love this a lot about Google. So a little bit about what we've done in the greater New York area. So one of the things we do at Google is we try to be great corporate citizens and great citizens of the areas in which we are. And in this area here, just late last year, we lit up literally the Chelsea neighborhood. I think it's like 6 city blocks that we give free Wi-Fi. So if you're enjoying the free Wi-Fi when you're out and about, that's from Google here. So it should say Google Wi-Fi or something like that. So hopefully everybody has access. Internal to the office here, Google Guest. But we've done this, and it was really important to us to do this around here, to give the access that just wasn't quite ubiquitous. In terms of other interesting things about Google, I think I lost like 60 cholesterol points or something when I joined Google. Previous companies didn't take my health as seriously as Google. So when I'm walking around the office, I have lots of healthy choices of things to eat. I still have a lot more work to do on that front. Some fun facts about New York. This is a fantastic city. If you have not had a chance to explore, hopefully you've book time, whether you've lived here your whole life, whether you just came in last night, and I heard some people flew in this morning. This is definitely a great area. New York is rich in history. It has many different markets. This is the Chelsea neighborhood. This was where a lot of the sort of import-export into the city happened for a long time. That's why this building was called the Port Authority building. It was attached to the port. Some of the fun facts you'll find around the city, the Empire State Building. It's an amazing building. What's interesting about this is the most expensive elevator ride I've ever had in my life. I did not know an elevator could cost that much, and it was only like 60 seconds. But if you get to the top, and you're brave enough to walk to the edge, it's a very interesting experience. Both the Empire State Building and the Rockefeller Center both have these spectacular views from the top of the building, and you can see all around the whole city. It's fantastic. Empire State Building was the world's tallest building for 40 years. And then everybody started to figure out that if you put an antenna on your building, you could get the tallest building. So I don't know if that's sort of cheating or not. A little known fact, the Oreo cookie was actually invented here in New York City. And it was actually invented right across the street in the Chelsea Market. And the ode to the Oreo cookie is a small plaque that says the Oreo cookie was invented here. So if you do get a chance to walk across the street today or tomorrow, you can go find out where the Oreo cookie was invented. Invented here in 1912, and I guess they had a bunch of cream and a bunch of biscuits, and they were trying to figure out what to do with them, so they mashed them together and came with this iconic cookie that pretty much I think everybody around the world knows. So with that, I'm going to hand this off to Ari Samash, who's going to kick us off with the keynote. Immediately after the keynote, we're going to go into the next talk, One of the things I'm going to do is between each talk after the speakers finish, I'm going to come on stage. As time allows, we'll take the questions from the moderator that you saw there, the link earlier, and I will sort of host the questions. As we run out of time, we'll just sort of move on, but the speakers, I believe, are all very excited to talk to all of you, so you can grab them at lunch, you can grab them at breaks. They'll generally be around. Most of them will be around, for the 2 days. Some will only be around for the day that they're here. So if you do want to grab them, make sure you try to grab them on the same day that they speak. With that, I'd like to kick it off and hand it off to Ari. So, Ari, thank you.
Thanks very much, Tony, for the introduction. So we are 4 minutes ahead of schedule. I am going to do my best to fix that. I want to welcome all of you guys to New York, to Google New York. I am from the New York office here. I'm part of the test engineering organization, specifically with ads. But before I get started, I really want to give a shout out to our folks from Boston. Any of you from Boston? Our prayers and thoughts are with you guys as you go through this, as the city, and me personally, as the city that went through 9/11, we completely understand the pain that everybody is going through and has to endure. We're right there with you. Our thoughts are with you. So I'd like to start by telling you guys a story. I hope you'll bear with me. There's quite a few stories in my presentation. My story starts in the mid-1990s, right? Just to give you guys some context about the mid-1990s, here's what they looked like. Music was distributed on discs. You literally had to carry a pile of discs around. Wi-Fi didn't exist, right? So if you wanted to connect to the internet, you had to find a cable. If you were lucky, you found one of those blue ones, because that might actually give you reasonable connectivity. If you were unlucky, you had one of those beasts over there called a modem that connected you to the internet. You actually had to dial up to the internet. You had to wait 45 seconds before you had connectivity. If you were even luckier, you had a cell phone. You might actually have to get straps and strap it onto your back, because that's what that thing looked like. You had to carry it around, right? And that's what a laptop looked like. They had tiny little screens, and they had these bricks. I guess they still have bricks today, but they had tiny little screens. If you were lucky, it might actually be in color. Google at the time was just a figment of imagination and a couple of grad students. And here's actually what they looked like way back when. For me, I was a software developer. I've been a software developer my entire career. When I graduated from school, software development was quite simple. You spend a couple of months collecting requirements from your customer. You write them down in books this big. Then you spend a couple of more months banging out software, right? Then you take all that software, you take the requirements, you give it to some other group, and that group then spends a few months validating whether the software that you built matches the requirements that were written, many months ago. The fact that something might have actually changed in those few months is completely irrelevant, right? You got the requirements, you built some software, and if it matches, it matches. Doesn't match, doesn't match. So we had a customer, financial services, that wanted to build a web-based application, pretty advanced at the time, right? In order to take some data that they had. Now, this particular company invested about 100 years building up their intellectual property. Much of it sat on 3x5 index cards. So the project was to take data off of 3x5 index cards, stick it onto a database, and then distribute it to the world over the web. They were, I don't want to say risk averse, because they were building an application that was meant to be deployed on the web, but they didn't understand what sort of application they wanted to build. We went up to them and asked them, okay, what do you want us to build? We're happy to build it for you. Tell us your requirements. They turned around and said, we don't really know. So we had a project manager at the time who said, maybe we should try this thing called rapid iterations to try to help the customer understand. We asked him, what do you mean by that? What are rapid iterations, right? He said, well, let's build the application. Let's do a build and deploy to some sort of QA or user acceptance environment on a weekly basis. We'll show it to the customer on a weekly basis. The customer will tell us whether they think it's reasonable or not reasonable, and then we'll make adjustments along the way. This literally blew our minds, right? What are you talking about? How is it that we're going to possibly start writing software without volumes of documentation? How are we going to do quality assurance? How are we going to know that we're doing the right thing? And the guy said, don't worry about it. Let's just try it. We'll see what happens. All of us thought this was a pretty neat idea. So we decided to go for it, right? We decided that Thursday night would be build night. Nobody leaves the office until the build is done on Thursday night. Friday morning, the QA group comes in, validates it. Monday, we show it to the customer. Customer tells us we're on the right track or not. Repeat. Sounded pretty easy, right? So we started. We banged some code out for a week. We get there on Thursday afternoon. 4 or 5 o'clock, we said, OK, let's just start doing a build. Let's see what happens. To make a long story short, we were there until Friday morning trying to get the environment working. Right? It's a long night. Took us a couple of hours just to get the code to compile. Right? It's the first time we actually built the thing. Then it took us a couple more hours to get it working in the environment. Right? The environment that we wanted to deploy into didn't match the environment that we were developing against. All sorts of crazy stuff. Right? So finally, Friday, we sleep. Monday, we show it to the customer. Customer is happy. All the application did was log in, log out. How much could we actually get done in a week? Customer was able to log in. Customer was able to log out. Thumbs up. We're all good to go. Right? Monday morning, we as an engineering group got together and said, look, if we're going to go through this every single week, we're never going to get done. Right? Actually, the main motivation is that we all wanted to go out on Thursday nights. Like, we had lives, and this thing was getting in the way of our lives. Right? So we wanted to go out Thursday night. What are we going to do to make sure that this week is not going to be a disaster? We thought, OK, maybe we do a trial run on Wednesday. We did a trial run on Wednesday. We didn't go out on Wednesday night. We were there until midnight getting the thing to run. But Thursday night, we had a good time. Wasn't so bad. We only had to clean up the mess that we made on Thursday rather than cleaning up a week's worth of mess. So you can see where this is going, right? All of you guys understand what software development looks like today. Rapid iterations, continuous builds, all that good stuff, right? But at the time, it really felt like we were pioneers in a brand new industry, right? We ended up, and you guys see the end story behind all of this, right? We ended up launching the product. Amazingly, the product is still there today. Hopefully, all the code that I wrote is long gone, 4 or 5 times over. That's what it's going to take to weed the thing out. But the product is still there today. The customer is extremely happy. But as importantly, by the end of the project, we ended up with an extremely high development velocity. From a test perspective, because we ended up automating the tests, we ended up automating the builds, we ended up automating the environment creation that was necessary to deploy our code. We ended up with an extremely high development velocity. At the end, the only quality we had to worry about was for the features that we developed in that particular cycle, because all of our regression made sure that we didn't break anything in the past, right? And we also ended up with a whole bunch of artifacts, right? Lots of small tests, a collection of medium-sized tests, a handful of manual large tests that we had to run, because browser automation and certainly environment virtualization didn't exist at the time to enable us to automate browsers. But we learned a couple of things. First of all, making testing easy so that we as developers could do it was really, really, really important, right? Because then we could build a feature, write a test for it, and be done. We didn't have to wait for somebody to come along at a later time to test it for us. Also, what we learned is if you hold us developers accountable for the pain associated with building, deploying, and testing, we would do the right thing from the beginning rather than waiting for somebody else to come and clean up our mess, right? Fortunately, all the stuff that we built for this were skunkworks shell scripts and stuff like that. All of the artifacts are long gone, right? The artifacts that we built were unique for that particular environment. There was only really one kind of browser available at the time, really one kind of operating system that this was deployed onto. So the artifacts that we built weren't really useful in the long term. They were useful for that particular project. But the thought process that went into my mind, something clicked, right? Just like it clicked with many of you guys. This is the right way to develop software, right? So we really felt like we were pioneers at the time. And it's a feeling that I think I share with many of you guys that are here in the audience, right? And many of you guys that are watching this presentation. We were at the cusp, all of us, right? We're at the cusp of something that was pretty cool. The industry changed. A whole new discipline within computer science evolved, something that we within Google call test engineering. And it proliferated. It really proliferated over the last 15 years. I wasn't the only one. Excuse me. I wasn't the only one. Many of you guys went through the same exact evolution at the same time. Luckily for me and for all of us, many of you also built artifacts that could be reused by other projects, right? Think of all the technologies that exist today that we have available to us to make all of this stuff work, right? Continuous build engine, unit test frameworks, all sorts of desktop and browser automation technologies, virtualization, which enables us to build really cheap environments and have those environments you can bring up an instantiated environment, you can instantiate an environment, you can hydrate it with data, you can run some tests against it, then you can destroy that environment at a relatively low cost, right? Think about all the different processes that are available to us today. Best practices, agile, right? Dog fooding, something that we do extensively within Google. We have the opportunity today to take an application, deploy it to production, and make that new version available to a small subset of our audience, maybe trusted users, maybe 1%, maybe only users that are internal to your company that can tolerate issues, right? Within Google, we call that dog fooding. And so we open up our application, at least new features of the application, to a subset of our audience before we turn around and expose it to the external world. That way, if there are issues, we know about them, and we expose them only to a limited audience. There are also all sorts of knowledge and information sharing. All of you guys are here at this conference to learn, right? The conferences exist about this particular topic. That's great. This is not the only conference. There's lots of them. Lots of mechanisms for information sharing today, right? Books, videos, all sorts of other things, right? Industry. Many companies, like Google, many of your companies, have dedicated organizations that focus on test engineering and also focus on moving that industry forward, right? But probably something that I'm most proud of, and we're going to hear from some of these folks today, there's also an entire realm within academia that's focused on test engineering today. So not only are we as industry, as members of the industry focusing on this particular topic, there's now a fountain of information, a fountain of research, a fountain of students, right, that are coming out of universities having worked on test engineering full time. And we've invited several members of the academia to come and talk at GTAC this year to help us understand the kind of research, the kind of groundbreaking research that's happening in universities and other institutions like that, that enable the next generation, the next wave of information, the next wave of test engineering to happen. So just like I felt like a pioneer many, many years ago, oh so last century, right? We've evolved. Many of you guys have felt the same exact thing, right? Many of you guys were at the forefront of this particular industry. We've evolved as an industry. I thank myself that all the tools that I created for that particular project are long gone, right? If we had to deal with only the tools that we built for that particular project, we'd never be here today. So I want to thank the many of you that also participated in this particular industry to take the knowledge, to take the learnings, and build the tools. We've really evolved, right? We've gone from pioneers to a well-defined industry that we're all proud to be members of today. So GTAC is a little bit about sharing as well, right? What I'd like to do is share about how Google goes about doing test engineering, right? We're also going to hear, there's several talks, including the one immediately after mine, where you guys get the opportunity to share about what test engineering looks like about your particular companies. I'd love to hear that, but I'll go first. I'll share what Google is doing about test engineering, some of the best practices that we have in place today, and some of the challenges that we face today that I'd love to see solved. First, a little bit of background about what Google looks like as a company. Google Speed, Google Scale. We have roughly 15,000 engineers in roughly 40 different offices around the world. At any given time, it's about 5,000 projects under active development. We have a single monolithic source code tree with all sorts of mixed language, mixed code, mixed stuff. 100 million lines of code, roughly 50% of which, roughly half of it, changes on a monthly basis. So it's very active, right? We spend a lot of time actually curating the source code. We do a lot of deletes within Google. We don't let things rot. Development happens at one branch, right? There's head, and there's head. That's it. That's all we got. All submissions are done at head. All releases are done at head. All builds are done at head. All tests are run at head. Everything runs at head. As a result, one of the benefits is that we don't have to support 1,000 different versions of libraries for different applications. Everything runs at head. And I'll talk about the consequences of that in a little while. All the builds are done from source, right? We actually do not pull in any binary artifacts into our binaries. Every single build, straight to the source, right? So even a small build, actually in my first day at Google, or first week at Google, I built a simple web server that just responded to a request. I built the thing. I was expecting the thing to have a couple of .o files, a couple of .class files done, right? Next thing I know, there's 100,000 files that go into building this thing, right? So even the smallest build, as a result of me building that web server, I just want to give a little bit of context to that. I picked up advanced monitoring. I picked up advanced instrumentation. I picked up advanced metrics. A lot of infrastructure that went into that little web server just to respond to a simple request, right? But that means that even the smallest builds can have roughly 100,000 artifacts associated with them. It's pretty complicated. On a given day, we have about 5,500 submissions to the source code repository. Roughly averaged out, that's roughly 20 per second. If we were doing average development across the 24-hour period, but we're not. So at peak, which roughly corresponds to about 3 minutes before people go home, we have 60+ submits per second, per minute, roughly 1 per second. That translates to about 100 million test cases run per day. So that's what Google looks like. So I'd like to spend a couple of minutes talking about what test engineering at Google looks like. There's really 2 parts to that. There are the tools and the people. But first, a little bit of context. Google's focus is really about engineering productivity as a whole. The test engineering group, or the discipline, is part of this greater discipline. So as part of engineering productivity, we focus on 3 things. Developer infrastructure, which is really about building tools that every single developer within Google uses. It's about test engineering, which primarily focuses on test automation, but also is involved in lots of different areas, and I'll show you examples along the way. And also release engineering, which focuses on building tools and optimized processes, repeatable processes for getting information out the door. But our mission is pretty simple. We want to develop it, build it, test it, release it, and measure it better, faster, stronger. Throw in all your favorite superlatives there. So first, let me start with the build system itself, right? The longer, the better. That's kind of a bad thing if you look at things from a developer productivity. We want to avoid this scenario. So Google's build system is really optimized for a whole bunch of different things, but primarily performance, right? So what we do for performance is parallelize as much as we can all the builds. First thing we do when somebody does a build is analyze all the dependencies, what can run in parallel. Then we send those requests off to our cloud, which has got thousands and thousands and thousands of machines just standing by waiting to receive orders to build information. Massive performance, right? We can get to roughly 60 files. We average about 57 actions every second on a 24-hour basis through our cloud. We also optimize for correctness. Make clean is a bug, right? You should never have to make clean. If you have to make clean, there's a bug in the build system. There's something that's not defined. There's something that's not declared. There's something that's incorrect, right? Our build system imposes that correctness on everything that we do. Incrementality also fits in, right? We want to do the least amount of work. That has 2 consequences. First, we want to figure out the least amount of work that needs to be done for that particular developer. That's pretty well understood, and all the build systems around the industry do that. But we also want to make sure that across Google as an enterprise, we do the least amount of work. That means if my colleagues over in the other side of the world, let's say Mountain View, have done a build at a particular revision, and I then do a build of that same revision and the same file, same target here in New York, I should not have to repeat my the compilation. They built it, I should be able to reuse it. So our cloud actually caches the output of all the builds, and I benefit from somebody else's build of the same target at that same revision. We also want to simplify use by developers, so our build system is multifunctional. I can build a file, I can run that particular target, I can test that target, I can run source code coverage for that particular target, and then I can do a dependency analysis on that particular target, all using the same commands just by changing arguments, the same basic command, right? I don't have to go and do crazy things. And the same applies for multi-language. I, as a builder, don't have to know whether it's a Java target, a Python target, a shell target, a C++ target, a JavaScript target. I just, if I want to just run the tests against it, I run that target and run tests against it. Pretty simple, pretty powerful. There's lots of talks, and I've provided these URLs that go into a lot more detail about our build system. Feel free to go check them out. Some performance numbers about our build system. This talks about incrementality. About 90% of our builds run less than 20 seconds. It's only when you get in the 90th percentile and higher do our builds take a lot longer than that because the caching doesn't kick in. You're building something from scratch that nobody else built. Our cache, anywhere from 89% to 98% effective depending on what you want to do. There are actually 2 levels of caches, one on my local workstation. So if I run 2 builds in a row, my second build leverages the first build. I don't have to go back to the cloud to download all that information. But let's say the first time around I run my build, 89% of the time I will be leveraging off of somebody else's build. The great part, and I'll talk about this at the continuous build engine, our continuous build engine is sitting there building stuff at every single change, right? I, as an individual developer, can take advantage of the cache that's been primed by our continuous build system. Build performance over time has also decreased, even though the amount of code we've typically had to build has increased. This is a direct result of test engineering, or just straight up engineering, against the build system to make it more efficient, better analysis of dependencies, better analysis of parallelization, but also just plain old faster computers that we can run our builds against. We talk a little bit about test execution. Just like builds, tests also happen in extreme parallel. So if a particular test suite has 4 test cases, as this one does, this example does, we'll run all 4 of them in parallel. More so, we'll actually start the execution of tests as soon as the build for that particular test is done. Right? So if test 1, test 2, test 3, and test 4 need to be built, if test 4, the build for test 4 gets done first, the execution for test 4 will start first. If test 4 fails, we don't even bother waiting for the other 3 to report in. Test 4 fails, therefore the entire test suite fails, we report that right away, right? So the developer can start taking action. This might actually happen before test 1, test 2, and test 3 even finish building. Our continuous build system ties these 2 tools together. Widely adopted within Google, there's one continuous build system that accounts for the vast majority of all the builds that we have within Google. This is what its user interface looks like. There's 2 key components of this continuous build system that I'd like to talk about. First is the before and after submit test abilities, and the second one is about flaky tests and the consequences thereof. The first one is actually really key. Like I learned in my first project, if you make it really easy for developers to run tests and hold them accountable to that, they will run tests and check code that's actually correct into the repository. You don't have to find out about it after. So our continuous build system has what's known as a pre-submit. I can take some code that I'm sitting and editing on my workstation, hand it over to the continuous build environment and say, take this, merge it in with the last known green, and tell me whether I'm going to break the build or not. That's great, right? I don't have to set up my workstation in any special way to make test running possible. It's just a generic workstation, right? It's going to be running, my code and changes are going to be running in the same exact environment that the continuous build engine uses to determine whether tests are correct or not correct. So that's fantastic. We actually take that to an even more extreme level. As soon as code is submitted for a code review within Google, the code review process not only sends it to a human being, another human being, to go take a look at, but it also sends it to the continuous build system to evaluate. We don't wait for the developer to ask the continuous build system whether the code is OK. We just do it proactively. So roughly the same amount of time, likely maybe even faster. They'll hear from their peer in terms of a code review. Your code looks good. Your code is horrible. Throw it out, start from scratch, or anywhere in between. It also hear back from the continuous build system, your tests pass, your tests fail, anywhere in between, what tests fail, what the logs are, right? They'll get notification. They'll also get a great email, and this was a tool that was built by my colleagues over in Zurich. They'll get an email that says your incremental code that you just added only has 23% test coverage. For example, I picked 23% out of a hat, right? So we do incremental test coverage source code coverage right there dynamically on behalf of the user, right? In an attempt, and I'll be nice, in an attempt to notify the developer about what level of coverage their incremental code has, right? Okay, I'll stop being nice. It's really about shaming them into believing that they should be writing more tests for stuff that they're writing. But right, they get the stuff all proactively. It's right there. And the code reviewer also sees it. So here's an incentive for the developers, right off the bat, to do the right thing. Our continuous build system also handles fine-grained dependencies. That's one way of lowering compute costs for us, right? Like I said, 100 million tests a day. That's pretty expensive to run all of them. We only run the tests that are actually necessary. We know all the dependencies through the build system. We know what test is impacted by what particular change. We'll only run the tests that are appropriate for that particular change. Flaky tests. Endless pain for us, flaky tests. Flaky test is defined as a test that is non-deterministic. Given a fixed environment, particular revision of code, particular set of changes, you run the test numerous times, and the test gives you different results, right? There are lots of possibilities for what causes flaky tests, right? Environmental issues, code issues, test code issues itself, right, et cetera. Right? You can imagine if there's a routine that returns a random number and the unit test that tests it tries to check that the number is below a particular threshold. Well, maybe if it's testing a 50-50, it will pass half the time and fail half the time. So non-deterministic flaky tests are shown in this particular display by the scattering of reds. By the way, the solid line of red, that's a failure that was submitted by a particular user. That's the second to last row from the bottom. But the miscellaneous reds that you see there are all flaky tests. They're tests that are non-deterministic. Why is this a problem? Well, first of all, if a developer is making a change, right, and they submit their change into the pre-submit queue and the pre-submit queue fails, the developer does not know whether it was the change that they introduced or if it was a flaky test that caused that particular failure, right? Worst case, they go and they start trying to find out what's going on within their code that caused this particular problem. We would love to be 100% correct around tests passing and failing, because that would enable us to go to the next level of automation. If we detect a failure, we reject, we roll back the submit. That would be fantastic, right? But we can't do that because of flaky tests. So we do three things. Our build system keeps track of flaky information. And that particular tool was built by my colleagues over in London, right, to measure, understand, and present back to the developers the level of flakiness associated with a particular test, right? It's pretty easy to see the different patterns with flaky tests as opposed to real failures. So we do statistical analysis and try to come up with some particular numbers, right? We try to get the developers to fix them. So by letting them know their tests are flaky, by shaming them into letting them know that their tests are flaky, we get the developers to fix them. If we can't, we do the least popular thing. We just retry tests over and over and over again until we determine that the test is flaky or we determine that the test is OK. We look for a pass. As you can imagine, as I showed before, our submits into the source code repository are not uniform over a 24-hour period. So we take advantage of the overnight hours to do incremental source code computation for all of our projects. We also do extra analysis of flaky tests overnight. So that's our continuous build system. Some statistics about it. Number of submits per day. A CL within Google is called a change list. It corresponds to a particular change that was committed into our repository. Linear growth over time. That's fantastic. We hire more developers. More developers write more code. We have more submits over time. The good news is that those developers are not only writing code, they're writing tests. So the number of seconds that we need to use to compute code test runs for every single submit is also going up over time. That's fantastic, right? Developers are writing more tests. For any given change, we run more tests. We're happy to do that. But, I have kids that are going through geometry today, so I understand this. When you take a straight line, multiply it by a straight line, you end up with a quadratic. Quadratics are bad, right? There is no way, even with all the data centers that Google has, there is no way that we at Google can keep up with quadratic growth across all of our test cases, right? I remember we actually had a conversation. Our developer tools group had a conversation with our data center people. They went up to them and they said, we need more machines to run tests. The data center people, being data center people, were quite blunt. They said, you have a choice to make. You can run your tests. We have enough computers to run your tests. We'll have to shut down all the production applications. You guys okay with that? Tests or production? What do you guys want to do? Yeah. So that's where we are today. We are heavily applying engineering to solve a brute force problem. This is a theme that comes up over and over and over again, and I've seen this over the last 15 or 20 years. When you can apply brute force, the easiest thing to do is apply brute force. But brute force times out after a certain amount of time. You just can't scale, right? You have to start thinking about better ways of doing things. And that's what we're doing today. So maybe we don't run the tests at every single change. We run them periodically. And then we'll run all sorts of interesting culprit finding to try to figure out where in between the breakage was. There's actually a talk tomorrow about culprit finding within Google. So let me talk a little bit about the people that make this all happen within Google. There are two roles, SETs and TEs within the test engineering group at Google. We within test engineering do a handful of things. We create processes and plans that would help test a particular product. We think of best ways to maximize coverage. But we also are highly involved in building a lot of the tools that I talked about. In fact, many of the tools that I demonstrated were built by the test engineering folks here at Google. I'll show you guys some examples. And there's some links that you can go to read more about this. First one, probably making up roughly 50% of what we do, is really focus on flaky tests. Like I described earlier, the problems with flaky tests, right? They're a huge cost and they're a huge time sink. How do you eliminate flaky tests? You build hermetic environments that you can run your tests in. Hermetic environments are self-isolated environments, instantiated, tests are run against them, and then deleted. The more hermetic they are, the less external dependencies they are, the better. The cheaper it is to create that environment, the faster the test will run, right? So a lot of the engineering that we do is about building consistent, reproducible, hermetic environments so we can run multiple of those environments and run tests at the same time, right? For a typical application, we might be running 5, 10, 15, 20 instances of that application at any given time in parallel with different revisions of source code being tested against that application. That's pretty common, right? We need separate environments that don't interact with one another and don't interfere with all the testing that goes on there. So that's roughly 50% of the time what we do, and there's a link over there that has more information. Another one is metrics. If you can't measure it, you can't really understand it or control it, right? So we try to measure lots of interesting things. We're Google, we love data. We collect lots of interesting data and present it to developers as a way, again, to get the engineering groups to do the right thing. And when I talk about developers, I actually mean us, because we're developers as well. So we collect metrics for test engineering, in addition to collecting metrics on the developer engineers, or the product engineers, the developers on products. First one, and I'll kind of go around the slide, starting with the upper left-hand corner. This is positive reinforcement about incremental source code coverage. This was built by my colleagues in London. They had this idea that for every single submit, we measure the incremental source code coverage. And if it's good source code coverage, we give credit to the person who submitted it. So here it is. We have these lookout displays scattered all around the offices. If any of you guys are going on tours, look around. There's a whole handful of them around the fourth floor here. They're constantly being refreshed with update metrics. So that's an example of the kind of metric that we put up there. These lookout displays scroll through lots of different information. If a person does a great job with incremental source code coverage and they submit a change that's got high coverage, they get their picture up there. It's right there in the middle, nice and big with lots of green around it. The group that this was deployed into started a friendly competition of who can get the highest green, most number of greens, get their face up there as often as possible. Fantastic, loving it. This utility alone raised source code coverage for applications by a significant amount, right? Bottom left-hand corner is latency metrics. So we measure constant performance of application, make that information available, right? We don't wait until the application is in production to find out that significant performance problems are about to hit, right? We measure, we show it, we move on. We also show build status, and that's that green project X status. It passed today, last timestamp, whatnot. There are some groups who shall remain nameless that don't adhere to the, or don't respond to the positive reinforcement that's on the top left-hand corner. We had a problem with a particular group where non-high priority bugs, like the P3s and P4s, were piling up, and the group was just not motivated to go and fix them. So we brainstormed about this. We tried all the positive reinforcement, giving them kudos for fixing bugs, rewarding them, recognizing them, doing all the good things. Didn't make a difference. So we went the other way. Public shame. Humiliation. We put this utility together. We made it black on purpose. Black is ugly, right? With lots of red around it, accusatory. Put up the worst offender. We were sitting there in the morning. A bunch of us were sitting there. It was nice and quiet. We were sitting there typing away. The next thing we know, somebody comes in. And I'll give you the G-rated version, right? Because this is, GTAC is a family-friendly sort of conference. Why is my picture up there? Comes up to us. Why is my picture up there? It was a lot more colorful, right? But you have a lot of bugs. What do I do to get my picture out from there? Go fix your bugs. The entire day we hear furious typing, lots of banging, lots of other choice words. Picture disappears by late afternoon. Next thing we know, why is my picture up there from the second person who's up? You have a lot of bugs. Go fix them. Needless to say, a few weeks after that, problem solved. So in a summary, right, for test engineering, we really look for creative ways to introduce cultural change so things are done correctly right up front with our development groups. So the impact of test engineering, we're not engaged with every single product within Google. There's only about 900 of us or so against a population of 15,000 engineers. So we're not engaged with every single group. But the groups that we do engage with, first of all, are really happy to have test engineering support. Right? But we also have demonstrable impact. For example, Google+, 100 new features released in the first 90 days. Right? It's roughly, on average, more than a release a day. Search, we can go from an idea to production in 48 hours, less than 48 hours. And Chrome, the browser, 6 weeks, regular schedule. Get released faster. So that's the impact of test engineering. I also want to pause at this point. I know Tony addressed this, but really it's test engineering, the discipline of test engineering within Google, that sponsors this conference year in and year out. There's lots of volunteers from the test engineering discipline that helped put it together this year, and the test engineering discipline funds it year over year. So I want to say thank you to the various members that organized this conference and the various individuals and executives that formed test engineering, but also made this particular conference happen. So now it's your turn, right? Over the next couple of days, we're going to hear many of your presentations about what test engineering at your particular companies looks like. Maybe you call it something different. Love to hear the names. We'd love to hear your best practices. We'd love to hear your challenges, right? What can we learn from each other to improve all of our practices? So I have a question. Are we done? Are we done with test engineering? Right? Here we were 15, 20 years ago. We clearly had a lot of work to do. We were all pioneers in a brand new space. Are we done? We kind of have awesome tools. All this stuff works. We're able to develop software. So the question that I have, are we about coffee? Right? Do we need to hunker down and drink more coffee and continue engineering against test engineering? Or is it about beer? Do we pick up some beer now? Samuel Adams, again, a shout out to my friends over in Boston. Fantastic beer. Should we grab some beer and go celebrate? Be done. Are we done with this particular discipline? I think the answer is no. As much as I would love to get together and drink some beer, it's only about 10 o'clock in the morning. It's a little early. We're not in Ireland. Coffee is still good. But we have a lot of work to do because the world is changing underneath us. And that's really why many of us are here today. Let's take some statistics from YouTube. 72 hours of video are uploaded every single minute to YouTube. 4 billion hours of videos are watched every single month. It's while developers are sitting there watching videos while they're waiting for their build systems. Right? 2011, more than 1 trillion views, 140 views for every single person on the earth. That's even assuming that every single person on the earth has internet access. Right? Most interestingly, 70% of the traffic comes from outside the United States. That's on the media side. On the mobile side, 25% of traffic to YouTube comes from mobile devices. So I started thinking about this and said, is this really a problem? Right? That's great. It's great that YouTube has all these fantastic statistics showing the change. Is this a problem? So I looked at various different sources on the web. The source for this particular graph is up there. Mobile versus desktop traffic. Desktop is at 85%, mobile is at 15%. We all apply the 80-20 rule. I don't know, this looks to me like we're kind of done. We figured out the desktop. We figured out all of its issues with the desktop. We know how to mock out all of its inputs. We know how to mock out all of its output. We know how to analyze the output. We have image comparison. We have great tools for understanding if applications are working well. It looks like we're done, right? Then, Eric Schmidt, former CEO, current chairman of Google, and his buddy, Jared Cohen, wrote a book. It was actually just published today. I got my copy yesterday. Fortunately, I got a chance to read through some of it, called The New Digital Age, that talks about some of the changes that are underfoot. And I'd like to tell you a little bit about it. The first thing he says is that there's only about 2 billion people that are on the internet today. But he predicts that in the next few years, 5 billion more, the incremental, will come online. And he's seeing some early indicators that this is true. First, he visited Iraq in 2009. The first thing he noticed in this war-ravaged country, trash wasn't picked up. Reliable water was not evenly available across the country. The first thing that they got up and running, one of the highest priority items in Iraq, was getting a mobile network so they can exchange information from one another. One of the first things that they got up and running. I'd like to tell you about another story in Africa, right? Again, as he was traveling the world. In the Congo, fishermen, actually fisherwomen, used fish. They used to take their fish to the market. If they were lucky, they sold them. If they were unlucky, the fish went bad, they threw them out. Using mobile devices, they actually leave the fish in the river. They catch the fish, but they leave them in the river until they have a customer ready to pick them up. They receive notification on their mobile device. They take the fish out of the water. They give it straight to the customer. No loss in inventory. Maximize their opportunity. And this actually created a semi-economy there. If somebody has fish that another fisher person wants, they can now exchange it among themselves using mobile technology. Lots of interesting stories. So are we done? Again, is Eric right? So I started looking into more data, and this one is, again, the source is on the bottom. 74% of the developed world is already using the net. But only 26% of the developing world is using the net. And if you average it out relative to population, the average is 35%, much closer to the developing world graph, the developing world line, than the developed world, because there's a lot more people in the developing world that still have to get connected. Right? So let's revisit these graphs again, looking at them from different geographical perspectives. Let's take South Korea. Right? South Korea is highly advanced. Right? But the story there, desktop versus mobile, tells a very different story. Right? Much closer to 60-40 than it is worldwide. Let's take another step and look at India. The story in India is radically different. There's a lot more mobile stuff going on than there is desktop stuff, right? And this trend is only going to continue growing. So mobile is already here today. It's something that we have to address today. But there's lots of challenges with media and mobile, and I'll run through them, right? Platforms, tremendous amount of variability in platforms. Lots of hardware, lots of different operating systems. The operatings themselves may not be as stable as you would love them to be, right? And unlike on the web, where I, as an application developer, had complete control of the stack top to bottom in my production environment, that's no longer true on the mobile side, right? If I'm an app developer, I now have to deal with other applications that are on the device, my application, the operating system, all sorts of different combinations and permutations that are going on, right? The hardware is different. The platforms are different. Input, there's no longer just a keyboard and mouse, right? There's tremendous amount of variability in input these days across all the different devices. There are cameras, right? There are GPS receivers. There's touchscreen. There's gestures. There's physical buttons. There's voice recognition. You can tell the device what to do. On the output side, right, there's all sorts of devices, resolutions, languages, right? All sorts of issues around that. Also, the network is no longer consistent. The same application that's running on the web, at least you can assume that if the application is running, it can talk back home. It managed to get downloaded somehow. Offline is getting better and better every single day. But really, how many desktops are offline? Right? Mobile, that's no longer true. The same application that's running can experience, within minutes, lots of network, no network, medium network, network bandwidth, network latency, all sorts of variability on the network side that have to be dealt with in some sort of interesting way. On the media side, the variability in quality is as high. Codecs, will this media work on this particular device? Will it work well? Will it stream? Will it be real time? How do I understand video quality, right? If any of you have taken compressed videos and looked at them image by image, you'll see that the image are radically not good, right? But that's okay because our brain does a great job of taking a sequence of them and putting them together. Sound, our ears are not as forgiving. If there's a pop in the noise, right, instantly our brains will determine that this is bad, right? Software delivery mechanisms have changed. We now have to, again, go back to the world where we're downloading software, allowing the user to download software, right? And if we want to release a new version, we no longer can do it instantaneously and give access to all of our developers, right? We have to wait for the developer to download it. So again, we have to deal with multiple different versions at the same time. Worse, there is now an intermediary between our users and us, right? The app stores are there. Security, privacy. We have to go back to a world where malware and viruses and all these other things are at play. Also, device sharing, right, is at play. So these are all the challenges. And again, I feel like we're pioneers again, coming back to the same feeling that I had when I started my little adventure in the 1990s. I feel like we're about to begin on a brand new adventure, right? We're all pioneers in this brand new industry, having to solve roughly similar problems that we solved many, many, many moons ago. All of us collectively have to solve them, but in a brand new space. And if we think mobile and media are it today, right? The next generation of devices is upon us. We got one of these guys, right? We have to work. How do you test this? It's a whole new challenge, right? The number of inputs that are available to this particular device are enormous. Cars. How do you test cars? With all their inputs and outputs and all the decisions that they get to make, and all the other devices, right? So, I'd like to close by saying all of us are pioneers. All of us are in this adventure together, right? Let's put on our thinking caps. Let's share, let's collaborate. Coffee. Beer later, but coffee now. And figure out what the next wave of test engineering is going to look like for these new devices, both for the media and for the mobile devices today, and for the next generation devices tomorrow. Same sort of adventure that many of us have gone through starting on the desktop. Let's take all of our thinking for the desktop and apply it for all this new world. Thank you very much. I hope you enjoy this conference.
Wow, that was fantastic, Ari. Thank you for that. I learned some really important things in this talk. One is Ari is going around taking pictures of all their people sleeping at their desk. You'll see that, yeah. Okay, so watch out if you're sleeping. He may take your picture.
But not me. I never sleep at my desk.
And the other thing I noticed in this graph, in his graphs, is there's a quadratic decrease in productivity at Google right around January. Who would figure this? End of December, January. So hopefully all of you got some really good notes. You know, I joke around about these things, but there were a lot of great thoughts in here, and a lot about the challenges that are going to be there going forward, and all the problems that we need to solve. That's why all of you are here. If you're not spending time during the breaks talking to each other, you're not getting the most out of this opportunity. So we really want everybody here to be talking to everybody else. So please do that. Two quick things. We have transcribers that are over in this corner. Everybody's done a great job not standing between where I am and over there. Just be cognizant, please don't do that. Otherwise, they can't get the transcription correct. And we also have somebody signing over here, which is great, so thank you. So hopefully I just didn't have some bad word or something like that, but I think that's thank you. I grew up near Gallaudet College, so I picked up a few things. And with that, we're going to move on into our next speaker. So we have James Waldrop here from Twitter. He tells me that he is an avid kayaker. He likes to kayak at night, mostly because his kids are sleeping then, which I can very much appreciate. I get to walk the dog somewhere around midnight, so that's something we definitely share in common. And even though I'm not going to explain to you why, if you want to go out to moderator, you should put this question in there about why is his product labeled Lotto, because he loves this question. That's what I heard. So with that, James, come on up, and we're excited to hear about your talk, Testing Systems at Scale.
Thank you. Thanks, Tony. Let's see. Yes, the product. It's really an open source library. I try not to basically say too much about it, right? Except clearly at presentations like this. It's actually called Iago with an I. The font used for these presentations is sans serif, so please keep that in mind as you look at the name of it, because I constantly get questions about Lago, and people who are clearly using sans serif fonts are looking at this going, okay, that's an L. It's not an L, it's an I. Yeah, anyway. So I joined Twitter about 2 years ago, a little more. And when I joined Twitter, my first week we had an outage where the site was not available to users. And the experience for the users was this. This is not a great experience for your user if you care about actually keeping your service up. Although it's an amusing picture, we love to, people love to make fun of it. Clearly, if you're an engineer who works at Twitter, this is a very sad face image. You do not want to have this showing up and your mother calling you and saying, hey, your system's down. So how do we get rid of the fail whale? In the last couple of years, we've gone a long way towards getting rid of it, and I'm basically going to talk about how we do that at Twitter. And specifically the fail whale, if anybody really wants to know the meaning of it, fail whale is a 502 HTTP response code. If it takes more than 5 seconds to render your request or to respond to your request, then we will serve you a fail whale instead. And so that gives you an idea of exactly what's going on behind the scenes. When you see that, it's not a great story. So why the fail whale? I don't know if anybody, I'm sure there are quite a lot of Ruby advocates in the world and in this room. And a lot of the systems at Twitter famously were built on top of Ruby on Rails. I'm not going to say anything bad about Ruby. I will say, though, that when you have a monolithic architecture that has all been written in one big blob of code effectively, that it becomes very hard to effectively manage that code, both in terms of its performance and in terms of its ability to make changes to it. So the Ruby world has a lot of interesting ways to achieve performance these days at the scale that we care about. And unfortunately, we really couldn't do any of them because of our monolithic body of code that wasn't able to be iterated on in a reasonable way. So the answer to that, of course, was to decompose it. And so at this point, I think we have something on the order of about 120 services in production. So we've taken this monolithic body of code over the course of the last 2 years and turned it into a lot of little services which are written in many different languages, including many on the Java virtual machine, Java, Scala, Clojure, and then also some written in things like Python, C++, and still Ruby. But because we can, now that it's decomposed, we can make changes to it more quickly. Our engineering organization of, hey, I'm going to build this particular area of the product, and you're going to build this area over here, actually is able to work that way because they have their own service that they can deploy, and this guy over here has his own service that he can deploy. And so they can work relatively independently of each other. The problem with this, as anybody who's maybe gone through this, or if you think really fast, you might realize that there's an issue here, which is that as you move from this monolithic world to a service-oriented world, testing becomes a huge problem. Because in order to test any given piece of software at a reasonable, to find out if it can handle production load, you need to be able to stand up that whole environment. And in the case of Twitter, and in the case of, for instance, the previous talk, Google, that's probably close to, if not impossible. And so how do we test in this new world? How do you test systems at scale when any one service might depend on 20 downstream services, and they in turn depend on another 20 downstream services? And in told, if you want to stand up any front-end environment, you're probably going to have to stand up 80 of those 120 or whatever number of services we have in production. Oh, sorry. So I'm going to talk about the rest of this talk will be about synthetic artificial load. Clearly, I wanted to give a kind of a front page shout out to all the other ways that we have to test performance. But I will say that all of them are in production. And I don't know about people in this room, but personally, I feel like if I'm testing it in production and my users can experience pain, or I can take the system down, let's say, in production, then that's probably too late to be testing it. And I really want to test it before any of that can happen. But the techniques that we have to test in production, as far as performance goes, are canaries. Canary, if you're not familiar with the concept, you have a cluster of systems that are handling requests, maybe 1,000 of them. You deploy your new version of the software to one of them, and now it's taking 1% of the traffic, and you get to see, hey, is it getting better or worse as compared to the old system? Clearly, though, it's taking production traffic. There's dark traffic. This is a little safer. It is basically a system, and we use this heavily at Twitter, we have a front end called TFE, funny name, right? TFE will take traffic, and then if it's configured in such a way as to do this, it will send part of the traffic it'll send all of the traffic to the normal production systems, and it'll send a second request to a system that's not stood up yet, and whose response it's going to throw away. All right, but now users aren't affected unless, for instance, this has happened, sadly. The system that it's sending the traffic to doesn't respond in a reasonable amount of time, and TFE isn't necessarily configured correctly in order to handle that. Let's say, pretend that this might not have happened 6 months ago. And lo and behold, you have an outage caused by dark traffic. And then the final one is more interesting to people who are doing functional testing. Tap compare is the ability to do a dark traffic read or a dark traffic write, like I just described, but compare the results and make sure that the software you're about to stand up actually sends the same content as the software that you have in production today. And with that said, I'm not going to talk any more about testing in production. Well, I will, but only in a scary, really inappropriate way, but it's fun. So what did I do? I joined, like I said, 2 years ago, and I was in the performance engineering group at Salesforce. I came to Twitter specifically to try to solve this problem as far as performance goes, and I wrote a load generator. My load generator internally is called Parrot. It turns out, though, that there are any number of trademarks associated with Parrot, including, most unfortunately, the Parrot VM that Perl 6 will run on someday. And when we open sourced it, I couldn't call it Parrot, so it's called Iago. I actually had no idea that Iago was this bird that you see up here. I'm too old to have seen Aladdin. I crowdsourced the name. I said, I can't call it Parrot, guys. What should I call it? A bunch of people wrote back, and the one that got the most votes was Iago. I'm like, Shakespeare? I don't get it. But OK, sure. It got a lot of votes. And then I found out it was Aladdin. So yeah. So why did I need to write a load generator? There are a lot of load generators out there. I've used most of, I'm not going to say all of them, but I've used a lot of load generators in my lifetime. I've used JMeter, I've used LoadRunner, I've used AB, I've used Flood, I mean, I'm not going to go through the full list, but I've used a lot of them. So why did I feel like I needed to write a new load generator? First of all, a lot of code at Twitter is written in Scala. I wanted to learn Scala. I had written some toy projects in it. And so I was like, hey, wait, what's the best way to learn a language? You write some piece of code that you already know how to write in this new language. That'll be great. Sure, that's an awesome reason to invent a new load generator, right? Another reason is that, you know, you ever get this sort of thing, like if I'm not actually doing engineering, that the other engineers won't respect me. So it's like, if I just bring in JMeter or I bring in LoadRunner and I start running load against their system, I'm not going to get nearly as much credit or respect in the organization as if I wrote my own, right? So, yeah. Another reason, hey, all those other load generators, sorry guys, you suck. There's really no reason to use any of them. They're all bad, right? Clearly. I hope the answer is obvious. None of the above. But when it comes to load generators, I have done this 3 times before I got to Twitter, and then I did it a 4th, and I open sourced it, so hopefully I never have to do it again. But I really want load generation to be simple. And I have a lot of experience when it's not simple of what happens. And what happens is that you end up with very large performance engineering teams, and they're very hard to hire onto. It's a very specialized skill. And so you're sitting there constantly like trying to scramble and figure out, is it going to scale? Is it going to scale? And you don't have enough people to answer the question why, or what, if it will. And you don't have enough people to answer the question why won't it when it doesn't. So if you're an engineer, as I've been, and you want to answer this question, will my new service, new whatever feature, gizmo that I'm about to ship to production, is it going to scale? Can it handle 1 million QPS? How do you go out and do that? You sit down in front of your computer, you're an engineer, and guess what? You write a for loop, right? So a for loop, if anybody's not ever written one, I really hope that all of you have, sits there and you know, you write a for loop. Let's see, I think I have a piece of it. Yep, there we go. So that's a for loop. We're going to start up 100 threads, and we're going to make requests as fast as we can against whatever service it is that we have stood up. And you know, apologies, this was not code reviewed, so it may not be actually compiling, but it's, you know, my sort of theoretical abstract for loop. And any load generator that you're going to use had probably be able to be better than this. If it's not better than this, then the engineer is just going to sit down and they're going to do it themselves, because this takes 5 minutes to write, if that. So that is, if you're writing a load generator, or you're going to be, if you're in that business, you had better outperform the for loop. Unfortunately, though, at least if you're an engineer, the for loop is really appealing. If you're, say, JMeter, and all of your configuration is either via XML, if you want to do it that way, which most people don't, or it's a GUI that looks like it beamed in from the late 80s. If you're LoadRunner, it's a GUI that happens to be really unstable and can't do automated testing at all. Or if you're AB, it's something that's completely not configurable at all. And if I'm sorry to bash on JMeter, I'm sure a lot of people here have used it. It takes forever to actually write a load test in JMeter. And if you want to do anything interesting at all, you're going to be writing a plugin, and I have done that, and let me tell you, I do not wish it on anybody. It would be really nice if whatever this load generator was really easy to write new things in. It has to be extensible. For loop actually satisfies all of those constraints. But the for loop has a problem. It turns out that it's actually quite wrong as far as testing performance of your code. It will give you nice, warm, fuzzy answers of, I can handle 40,000 QPS. Woohoo, look at me and my product and my service. It scales really well. But it turns out that that has nothing to do with what's actually going to happen to it when you get into production. Why is that? So let me talk about some systems theory. Sorry to be academic for a second. Does anybody here know Little's Law? Raise your hand if you know Little's Law. Awesome. Nobody here knows Little's Law. I'm glad I put the slide in. So Little's Law is a really awesome mathematical result in queuing theory that says that if you have a service and requests are arriving at a particular rate, that the number of concurrent users or concurrent requests that that service will be able to handle can be found by saying what is the request rate and what is the latency, or what is the time it takes to service that particular request. And that might sound intuitive, and it is. If you think about it, like, hey, if I have 100 requests a second and it takes a second to satisfy that request, then I will have 100 requests concurrently, right? It's simple math. But it turns out that the math behind that is actually pretty hard to derive, and it's awesome that it's such a simple result. But really, it's just math, so why do we care? What does Little's Law have to do with a for loop? Well, if you are a performance engineer, you very much want to change one thing at a time about your system so that you can know for sure that the performance impact that you are experiencing is because of that change, right? Flaky tests were mentioned earlier. Flaky tests are the bane of performance engineers because you never get one answer. You always get a range of answers whenever you run these tests. And so it's really important that you be able to change something, try it again, change something, try it again, and get results that you can count on. But Little's Law actually makes that very hard to do that on a system which is specified in terms of concurrent users. So open versus closed systems. Basically, an open system, and again, I'm not talking about open source or any of the open, like APIs or anything like that. This is systems theory. An open system is a system where requests can arrive independent of your ability to service them. So in other words, an open system is what you get when you put your service on the internet, where your users, as much as you wish they would, do not care that you're slow right now or that there's a big spike or that Michael Jackson just died. They're going to send you requests, whether that's tweets or trying to read tweets, regardless of your ability to actually handle them. A closed system is much nicer to model. It's one where it's like, if you can imagine, probably the best example I can think of is a call center, right? Where you sit there on the phone with the poor person who's sitting in front of the computer. There are only 500 agents, so that's the concurrency right there, 500. And they sit there and say, I'm sorry, the system is slow right now. I'm waiting for your data to load. That's a closed system. It's awesome because you can just say, all right, I need to be able to send 500 threads. JMeter can model that quite well. But in the real world, we model things with requests per second. So in that concurrency is equal to latency times request rate, we need to model request rate, not concurrency. So one more thing. JMeter and almost every other load generator I've used, by default, will speak HTTP, which is fine if you have a web service. Clearly, Twitter is a web service, so why isn't that sufficient? Well, it turns out that when you build a big service-oriented architecture, you're probably not speaking HTTP on the back end. At Twitter, we're talking Thrift. Thrift is a wire format that is similar to protobuf, which many of you are probably familiar with if you're not familiar with Thrift. And you have to be able to talk Thrift if you're going to be able to test systems in isolation. Because you can't stand, like I said, you can't stand up the whole service of Twitter, all 120 of them, and then send some HTTP requests in order to make something happen way down, 10 systems deep, so that you can find out whether or not you can handle the load, right? So you need to really be able to test components, not test the whole system. Supporting Thrift is really, really tricky. It turns out that in Thrift, you actually you code gen your protocol, and you typically do that at compile time. So when you're building your system, you have bound it to a particular RPC by the act of building it. And that means then that all of your data objects are there at compile time. And if you're imagining a world like JMeter, then it means that my load generator is suddenly going to have to know not only your protocol, right, which is tricky in and of itself, but also going to have all of your code gen stuff, which means that if you think about it, there's 120 systems at Twitter, so that means that now my load generator code is dependent on all 120 Thrift interfaces that they expose, and I open sourced it, so now it's dependent on anything anybody can ever do, which is clearly impossible. So I had to change the mental model of how this works in order to satisfy that need to support Thrift. HTTP, you don't have any of those problems. HTTP is a very well-defined protocol, cookies, headers, posts, different kinds of requests, but very well specified. And nobody's going to, well, other than HTTP 2.0, nobody's going to invent a new kind of HTTP that you need to support in order to make your load generator work. But Thrift is a lot harder. So I had to flip the model in terms of the load generator. So in the JMeter and any other system you might use world, the dependency is on the system. Instead, I flipped that, and the dependency now goes from the system to the load generation library. And so when I got up here, I talked about the fact that Iago is a library. It's not a product per se. It is a load generating library. You depend on it just like you depend on any artifact. And what it gives you is enough stuff that allows you to write to an interface, which allows you to implement your particular load test. And I'll show you some examples here in a minute. And you write to that interface, and then you launch it, and it ships. With that dependency comes enough jar, blah, 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 comes along and then allows you to launch it. It comes with effectively an execution environment along with it. Secondly, so not only is Iago different in that it flips the dependency model on its head, it also uses Finagle. If anybody has used Finagle, then you're probably like, yay, cool, Finagle's awesome. I'm assuming that's not most of you. Finagle is a Scala library that we use heavily at Twitter. It's open sourced. We wrote it, and a lot of people are using it. And it allows us to do asynchronous RPCs over Thrift or HTTP, or really name your protocol. MySQL was recently added, and we have a Google Summer of Code. Shout out to the folks who organized that. Google Summer of Code project this year for adding Zookeeper support, for instance. Chances are that if it doesn't support what you need to do, it probably will be there or is easy to write. Finagle, because it's asynchronous, solves our open system versus closed system conundrum that I described earlier. In an asynchronous world where you have, it's based on Netty, so if which is in turn based on Java NIO. So if you have an async world like that, you can basically say, hey, I needed a request to arrive every millisecond. Let's say that my arrival rate is 1,000 RPS. So I needed a request to arrive roughly, if I had a uniform distribution, every millisecond. Okay, great. I'm going to send a request every millisecond. I'm not going to have a thread per request. I'm not going to care how slow or fast your system is. A request will be sent and will arrive every millisecond. If your system is down, then I'm going to get connection refused. If your system is up but slow, then there's going to be a socket held open for a certain amount of time. But the resource constraints on my test system are not going to interact with the resource constraints or the problems that you might have on your service. That kind of coupling is death to a performance test. If you get your system under test coupled with your load generator, then you've created a closed system and you're no longer modeling reality, at least modeling reality for most of us here. There may be, clearly I described a case where somebody could create a closed system, but for the most part I believe everybody here probably works at internet scale, and therefore you are all needing to model open systems, and so you need something where it's going to generate those requests regardless of how slow or fast the service is at this particular build. So that's all cool, but what's it mean? So I mentioned that I'm going to get to some code. I'm actually moving faster than I expected. Maybe I should slow down. So we'll have a lot of time to look at the code. But there are some implications about this model of, hey, here's a library, you depend on it, you write your load test using this library, and then you just launch it and it runs and it's all good. For me, the most important thing, I came from a team at my last company where there were, when I left, I think there were 15 performance engineers, and now I've heard that the team has, over the last 2 years and change, the team is now something like 50 performance engineers, and their job is to write performance tests, and that's what they do. And in order, as the engineering team grows there, they have to hire more performance engineers, right, in order to performance test all the stuff. I think that model is very hard to make successful, especially when I started at Twitter. The company was quite a bit smaller. I think there were roughly 200 engineers at Twitter when I started. I wasn't going to be able to go and performance test every single person's thing. They were all moving really fast, way faster than I could move just by myself. And I wasn't going to go out and hire another 19 performance engineers really quick and say, okay, great, now we can performance engineer. Now we're going to be able to test your stuff. And oh, by the way, today we're something like 900 engineers, which is the size of actually just Google's test team, but never mind. So now I would need 90 performance engineers, or whatever the ratio is, right? Let's say it's 5%, then I'd need 45 or so. And you can project out to infinity and realize that, in fact, this is probably not going to scale because there aren't that many performance engineers on the planet, right? And so it's really important to me that if you're an engineer and you're building a service, that you be able to write your own performance test. Not that you can go and learn JMeter, not that I force you to go and, God forbid, use LoadRunner, but that you actually can just write some code like you would write your for loop. And write your own performance tests. So that's a clear implication of this dependency model switch, is that you're no longer working in a world where most of the domain expertise is something that's unfamiliar to you. You're working in a world where it's your service. You probably already wrote a sample client when you wrote your service, and you just use that same code to generate the load test. It's very simple, similar to how the for loop is very simple. I have been at, like I said, I've been at Twitter for 2 years. I've written 2 load tests the entire time that I was at Twitter. I spent the first 6 months writing the load generator. I wrote a couple sample load tests that were actually never run. People looked at it and said, oh, this is easy. I'll just do this myself, and I never actually ran those. And there were 2 instances where I had to do a load test because they were testing some aspect of the system where there either, in one case, no team existed that was maintaining that system, and yet we were expecting it to get a large burst in traffic. And in another case, it was crossing so many organizational groups. This was the most recent example. I had to test for New Year's Eve. And so I wrote that test of what happens when 30,000 Japanese people all tweet at midnight. Exactly, right? It's the best distributed denial of service attack you've ever seen. And so those are the 2 load tests that I had to write. I'm going to show you one of them. I don't think I have time to show you both, but I'll show you the most complicated one so you get some sense of exactly how hairy can it get, and I'll talk about that in a second. There are some unintentional things that happened as a result of doing it in this way. It turns out, I mentioned that you have sample code already written. It turns out that you actually have to write a lot less code. When I write a JMeter plugin, there is a ton of boilerplate that I have to implement. In other systems, I have to write a whole bunch of stuff just to get it to do what I want. Iago, the code you're writing is the code you already have, so you probably are just copying and pasting it in the worst case, or pulling it in as a dependency in a better case. And so you just don't have to write as much code. It really takes people, literally, you might think I'm exaggerating, but it typically takes an engineer at Twitter who has never been exposed to the load generator before, and everybody now at this point, I believe, well, except the 50 or so we hire every month, will have been exposed to it. But it takes them about 30 minutes, typically, from I don't have anything, my manager just told me I should probably find out if this is going to scale, to all right, here, I've got a load test, and I've run it, and I found out that, in fact, it doesn't scale at all. Oh, shoot, I have to go back to the drawing board. Or, better case, it's awesome. It also has another really fascinating implication that I'm going to get to here in more detail in a second. But it means, with Finagle makes it really easy for you to think in terms of asynchronous operations. It has this concept of a future. Hopefully many of you are familiar with that from the Java world. The future signature in Scala is a little nicer and easier to work with than it is in Java. And it allows you to compose RPCs in a way that lets you say things like, first I need to authenticate this user, then I need to check and see what if they have the right access, then I need to run this request against this backend service, and I'm going to scatter gather, so I'm going to run this request out to 100 different services, and I'm going to compile the results, and I'm going to throw away the ones that didn't come back in a certain amount of time, and then I'm going to collate that into a response that I send to the user, and I can do all that in about 3 lines of code. So Finagle makes it really easy to compose really complicated RPCs. Using that in the load generator in turn means that you can write really complicated load tests really easily. And I didn't expect that at all because I had never been exposed to Finagle, and that was a really nice result. The thing that means is that, as you're going to see, it means that you can write very complicated functional test scenarios that normally, before I had a tool like this, the way that I would do performance testing and make sure that the service is behaving correctly at the same time, let me describe a scenario where this isn't done. Let's say that you have a load test and you're running it and your service is performing really well. And then later somebody has the bright idea to go and look and see what's actually happening. And what's happening is, hey, it's amazing. The performance is awesome. It's really, really good at serving a 404. Right? Or it's really, really good at serving a 500 because there's an exception, and it turns out that an HTTP 200 with a nice graphic like a fail whale might, to your load generator, look like success, but in fact, the right thing isn't happening at all. Well, how do you solve that problem? Well, of course, then your load generator needs to, hopefully pay attention to more than just the response code. But also, you might think that this is the way I solved it in my last gig. You run your load, and you're running a functional test beside it, right? And you're like, OK, under this amount of load, these scenarios still operate correctly. And so here I've got JMeter, let's say, running against the service, and I've got a Selenium test or a WebDriver test running simultaneously. And that's fine as far as it goes. But wouldn't it be nice if you could actually say 100,000 users can all do this at the same time, or they can do these 50 different things all at the same time? And it turns out honestly, I don't know of any way to do that other than this load generator Iago. So, right, I didn't have to load test 100 services, so I had a lot of time to dedicate to making Iago great. It's still not as great as it could be. We are in the process of syncing out a bunch of stuff to the open source repo, bug fixes and such. But I would really, if people are inspired by this talk, feel free to come and make contributions. Unintentionally, the idea of having a service which is really solid became the model for how we do all of what I call developer productivity, or probably a lot of you. It's not a realization I had alone, but we basically are focused. I manage a team now focused on developer productivity, and our build system works this way. The test frameworks that we support works this way. Our test infrastructure setup works this way. Our deployment tool works this way. And so it became a model for how things should work, is that give engineers great tools that are really easy to use, where the default is almost easier it's almost easier to use them than to not use them, and they will do the right thing. And so that's how we're doing things at Twitter, which hopefully is no surprise to anybody. All right, now we get into the meat. Hopefully you can all read that. I actually don't care if you can't read that too much, because it turns out that this is just an example of how to write an echo service in Finagle using Thrift. So you can imagine that you would have a service like this. It takes a method, or it has an RPC that says echo, and then it's going to reply back with what you wrote. That's just, I'm trying to be relatively open kimono here. There's no hidden dependencies, or, well, other than on Finagle and things like that, but there's no hidden code here. That's really how the service is written. I cut it off at the end because below that is all the Zookeeper discovery business, and I figured people don't care. Here's the client. I mentioned, I hope anybody who's writing a service has probably also written a client for it. If you haven't, then you should probably think about doing that, because you learn a lot of interesting things when you behave like your customer, whoever that is. But here is a client that is going to send the message hello. And when it gets the response back, it's going to print something out and say, all right, I got a hello back, right? And that's how you write that code using Finagle, talking to my echo service. And it's not a lot of code, right? There's a lot of noise in there about types, but other than that, it's pretty self-explanatory. And by the way, if anybody here doesn't know Scala and you're totally confused, my apologies. Here is a load test. I'm going to jump back and, all right, take a look at that for a second. Notice that it's calling client.echo, right? I'm going to go back. Client.echo, right? So if you see that, it's actually the same code. And in fact, it turns out it's less code. How is that possible? How could it be less code? Well, it turns out that Iago takes care of some of the boilerplate as far as connecting to a service goes. So this load test actually does a little more than the sample client. It actually, if it gets a hello back, then it sends another message and logs it, right? So that's a really simple example. I'm going to get into a more complicated example here in a second. It turns out that if I wanted to write a for loop that just sent echo requests asynchronously, as long as I knew enough about Java NIO or Netty or some other library like that, it would be really simple for me to do that without too much effort. Great, what have I gotten? How can I do better? So we have more complicated problems than that, it turns out, at Twitter, and hopefully most of you as well. So load testing direct messages. Direct messages are a feature in Twitter where you can send a private message from one user to another as long as there's a following relationship between them, with some exceptions that I'm not going to go into related to brands, where they'll allow you can direct message them without them following you. I didn't put any of this in the slides because I was worried that comms would come after me. So I will talk about this rather than I have to get slides approved. So nothing that I'm going to tell you is confidential per se, but at any rate, we had a TV show, one of these reality game shows similar to, say, American Idol. Where people are singing, they get up on stage, they sing, you vote, and then America picks the winner, right? They go home with hopefully a nice recording contract that doesn't take too much of their money. One of these such shows wanted to use Twitter to do the voting. And this show had a $5 million prize at the end. And they were going to do the voting every single live show over Twitter and include those votes along with everything else. But in order, voting online has to be private, at least without some major exceptions. And so they were going to use DMs. And at the time, and I'm not specifically not, in order to not get myself in trouble, I'm not talking about when this was, but at the time, we were getting roughly 400 DMs a second over our system. So 400 messages a second back and forth that were of this type. And when you figure out that most of the TV showing happens in the East Coast and Central together, which is most of the population of the United States, and that all of this voting would be happening at the same time because the polls open, as it were, at the end of the show, and so everybody immediately goes and they do their voting. So you get a flood of traffic. We figured out that we were going to have roughly on the order of 2,000 to 3,000 DMs per second. And as I said, the production traffic at the time was 400. And so it was clearly we were going to have a large increase over what we could handle. So we needed to be able to test that. This is a direct message. Again, I'm going to show some code, and actually I'm going to go a little quickly because I have about 4 minutes, but I'm not going to go super quickly. That's just a underlying type that would hold the direct message. Here's my processor. You might actually be able to figure out from the code what the TV show is. We're actually going to show a lot of this, like 5, I think, slides of code here. So don't get too attached to any one piece of it. This is happening up in the constructor. There is an eval, and then we pull in a config, and then there's a couple of URLs. This is using our API 1.0 endpoint instead of our API 1.1 endpoint. This code was written long enough ago that there wasn't a 1.1 endpoint. And by the way, none of it has been code reviewed, so please, my apologies. I know it's not the highest quality code. I wrote it in literally like a day. So there you go. Here's some stuff. It turns out that if you're going to have $5 million riding on the votes, that you had better get them right. You better not drop any votes on the floor. You better not have votes show up for people you didn't expect. And so the voting, like in my load test, when I talk about being able to test correctness and load at the same time, it turns out to be critical in this case. Because I need to be able to make sure that of those 3,000 DMs per second, or whatever the number is that I'm going to test at, that all of them show up for the right guy, right, or girl, or whoever it is, and that none of, like I said, that none of them get dropped on the floor or arrive out of order is fine in this case. So I need to track a bunch of stuff. It also turns out that I don't have a system, another system like Twitter that's not Twitter. Right? I don't have a copy of Twitter in my back pocket that I can just stand up and run a bunch of tests against because that would be expensive and it probably wouldn't fit. So I need to use Twitter in order to run this test, which means I run the risk of knocking over production, as it turns out. But anyway, that was a known risk. But it also turns out that I don't have millions of users in my back pocket, and I can't go create millions of users because it would throw off our analytics, and our growth team would get really excited, and I would have to break the news to them that that was just me. And so I don't have a million users in my back pocket, so I decided, you know what, it doesn't matter. I did a lot of talking to other engineers. This was pretty shortly after I arrived at Twitter. I didn't know much of the system at that point. So I talked to a lot of people, and they said, no, it probably doesn't matter. You can probably send all these DMs from one account. So I sent all the DMs from myself. Literally, I used my own account. But it turns out that we have rate limiting at Twitter. And so if I need to send 3,000 DMs a second, if any of you want to do this, you're going to get stopped almost immediately. All right? It turns out that my load generator is running in production, and so it has access to Memcache, which means it has access to the rate limit, right? It has access to my rate limit token, and I can go and reset it as part of my load test. So the load test is sitting there DMing, and meanwhile it's also talking to Memcache saying, that guy, no, we're going to zero out his rate limit again, all the time, over and over and over again, quite rapidly. And I mentioned that I want to make sure we don't drop these on the floor. Our customer was using our streaming API, which internally we call Hosebird. And so I wanted to make sure that I was getting the same data that they would be. So I make a connection to Hosebird. So there's my connection to Memcache, right? There's my connection to Hosebird. I elided the connect to Hosebird code because it's not that interesting. And then here's my load test. So I need to pick a particular host to hit. I need to decide what I'm going to send, so I have a vote randomizer function that I'm going to call. I need to set up the request. I'm going to make a URI out of that. I'm going to set the OAuth header with all the right correct authentication codes, and I'm going to make a Iago/parrot request with all of those parameters. And then I'm going to map that onto my request, call my service, which is that second line up there. And when the response comes back, I'm going to decode it and check to make sure that I haven't exceeded my DM limits, and if so, reset them. And then I'm going to look and see if I got a decent response back, meaning it's some HTTP response as opposed to an exception that I got on the wire. Then I'm going to read that DM, and I'm going to do some check for missing DMs at the end. Right? It's very simple logic. It turns out that this logic actually had a bug. It's kind of funny. I think. Anyway, you'll see. The way I wrote it originally was, all right, I'm going to send a message, and when you send a DM or anything on Twitter, you get back, when you create something, you get back an ID. So I'm going to get back the ID in the response, and I'm going to be waiting over here for the stream to give me a DM with that ID, right? And I found out that we were dropping tons and tons of DMs on the floor. This is horrible, right? It's not working at all. What's the problem? It turns out that Hosebird was delivering the DM before I actually got the response back. So our streaming API is fast enough that it will send the DM down before you even know what the ID was, right? And so I had to create DMs that have unique text in them just so that I could match them up, because I was going to get them on the streaming side before I got the response. It's an awesome bug. Yeah, that's all the code. That's it. That's how you test DMs. What do I want you to take away from this? So clearly, most of you, some of you, I don't know how many people from Google are here. Google clearly deals in more scale than we do, as does Facebook and a number of other sites. But in general, most of the world doesn't handle the amount of test load that we have at Twitter. Just to give you an example, when I went into this, one of the things that I wanted to be able to do was to be able to generate a lot of load. I had run into scalability problems with JMeter in systems like, where they have very simple request response patterns, meaning, give me a counter. Great, I got a counter back. You can be very fast at that. And 40,000 QPS was a lot for JMeter to handle. And I knew that Twitter handled more than that when I came to the company. So I wanted something that could scale really well. And I had in my head that, 100,000 RPS would be cool. That'd be awesome. And one day somebody needed that much, and we were able to do it, and it was no big deal. And then somebody else came along, and they wanted 500,000 QPS. And I was like, oh, wow, that's a large number. OK, let's see. I had to tune a couple things. And then we did that. And then I haven't touched the code, honestly, in like, I don't know, 6 months. And a month ago, I was idly sitting lunchtime conversation, and I hear behind me 2 million QPS we tested, and I turn around, I'm like, what? 2 million who, blah. What, really? And I was like, you didn't do that with our stuff, so how did you generate 2 million QPS? That's awesome. I want to know what did that. Turns out you can generate 2 million QPS. That is almost an afterthought versus everything else that you get to do with this. Pretty interesting as far as Twitter's problems go. It turns out that you probably all should want your engineers to be writing their own load tests instead of doing it yourself. And you should also clearly want your load tests to be accurate and model the real world. There you go. I have all of 1 minute for questions, and I'll be available for lunch.
Great, thank you, James. I got my takeaways again this time. One is I learned you were an optimist and not a pessimist. All your for loops had starts but no ends.
Yeah, thanks.
And I also learned I have to go learn Scala, and somehow somebody slipped in like a next generation Lisp somewhere in the world. So Scala is it. I also know Foursquare does Scala, so it's growing in popularity. We are going to take a break here in a minute. I think we have time for one question if we want to go to the mics. So if you have a question, go to the mic. Otherwise, we'll take one off the moderator. Then we're going to take a break. Then we're going to come back here exactly at 11:30. And we're going to go into the next set of presentations that will be done by Mozilla. And right before this question, two things. Some people have been asking if the slides will be posted. Yes, they will be posted. And so will the video and the content and all these questions and everything after the talks. So they will definitely be out there. And number two, there's a lot of people standing up in the back of the room, just some to stretch their legs, but there's also people that like a seat. So when you come back from the break, kind of squish into the middle as much as you can. So with that, we'll go to a question.
I like the top one.
All right, so here's the first question. It says, does Iago allow clients in languages other than Scala? In other words, can developers port their clients in other languages to write performance tests?
Yeah, so sorry, can you hear me? All right, so Scala is a JVM language, which means that those libraries are available to any other JVM language, which means that as long as you have code written for the JVM, and that can include things like Jython or JRuby for that matter. So really, anything that you write on the Java stack for, you can use Iago.
Great. Awesome.
Cool. Thanks.
All right, with that, let's go ahead and take our break, and we will be back at 11:30. So. Hello, hello, welcome back. True to word here, we're going to start. As a reminder, please do squish in as you can to make room for others. So if you can sort of move to the center to leave that space, that'll be great. If you are interested in the topic tables, we're going to be selecting the topic tables for lunch here in a few minutes. You can go to g.co/GTAC2013 and you can find a link to the moderator to go and figure out what topics you want to vote up or vote down or even suggest a new topic. So please go do that right now if you can. And up next here, we have David Burns and Malini from Mozilla here that are going to talk about how do you test a mobile OS. And a little fact about Malini here. She told me that her dog is named after a test subject in Portal. So you can always go ask her about this from that. So with that, I'll let them kick it off. Thank you.
Thank you. So can you all hear me okay? Yeah, awesome. So I'm Malini Das, and this is David Burns. And we work on automation frameworks over at Mozilla. And we're here today to give you a rundown of the recent challenges that Mozilla has been facing while automating a new mobile OS. So how do you test a mobile OS? That's the question that first came into our heads when we were tasked with supporting this new platform. And we knew that answering this question wasn't going to be as easy as just Googling for an answer or just winging it as we went along. There's a depth of problems that need solving, and solving them in a good and long-lasting way would save us lots of pain in the future. So today, David and I are going to talk to you about how we solve this complex problem and share with you the pain points and the victories we had along the way. So let's see here. Great. So what mobile OS am I talking about? As some of you might know, Mozilla has been working on something called Firefox OS. And this is an open, web-accessible device that's built on top of what we know best, which is the browser. So we're using Gecko, which is our web rendering engine, to drive the phone itself, allowing all the applications running on our phone to be written in CSS, JavaScript, and HTML5. So now you might be wondering, why would we want that in a phone? Well, we've seen a recent trend towards web technologies in the mobile environment. So around 60% of the apps right now in Google Play and the App Store have at least one part of the app that's a web view. So what this means is that on top of your operating system that needs to run your native applications, you also need to have a web rendering engine just to show this web view. And this trend towards web views isn't going to go away anytime soon. We're seeing a prevalence of frameworks like PhoneGap, which allow you to write an application once using web technologies and deploy to multiple mobile platforms instantaneously. So what's the problem here? The problem is that these operating systems are doing extra work. So not only are they running native applications, but they also need to run a web rendering engine just to show you parts of this application. So is there a way to remove this extra work? That's the goal of Firefox OS. What we want to do is unite the concerns of the OS and the browser so your phone is doing less work. And what we want to do is optimize it so well that we can run on low-end devices. So we get this benefit that by optimizing our browser, we get to optimize our phone. And by targeting low-end devices, we get to put this phone out to emerging markets and put it in the hands of people who may not have a smartphone before or may not have had access to the internet before. So what this means is we now have to make our browser a phone. And what is that, what do we need to do for that? That means that our browser has to do things like send SMSs and make phone calls. And on top of that, it has to act like a browser, so it has to render web pages. And that gave us, the automation and tools team, the task of figuring out how we can instrument and test all these new features in this platform. So what exactly should we test? Since Firefox OS is essentially a flavor of Firefox, but on the phone, we want to test all the same parts. So this means that we want to test things like rendering. Now, rendering essentially means how the web page looks like once it's loaded. And the way that we test it is that we let the web page load, and we compare the data with either a reference image or reference data to make sure that they match. If they don't match, then we're not giving new mobile users an experience of the mobile web that they deserve. We don't want to regress in any way in rendering. Another shared another shared concern that we have with browsers is that we want to make sure that we have a performant phone. So we need to check performance. If our phone takes too long to execute anything, then no one's going to want to use this phone. So this means that we need to test performance for simple things like loading an application, but we also want to do stress tests so that we can make sure that we don't provide a degraded experience over time, or that we can catch memory leaks and all that fun stuff. But now, on top of these concerns that we have with our browser, we have new concerns as we're a smartphone. We now have to worry about application unit and integration tests. So smartphones have a number of base applications like the calendar or the dialer. And you want to make sure that these applications work before you send out this phone to people. So to do that, you want to answer questions like, does my application work? Do the functional parts of this application work? Does this application work with the system app? Does it work while other applications are running in the background? Now, this is important for us so that we can test our own base applications. But we also want to give this test framework to third-party developers so that when they write their apps, they can have the confidence that it'll work in this new environment. So Firefox OS is not just going to run on any desktop. It's going to run on phones. So now we have to worry about testing the phone environment itself. This means things like gathering hardware metrics. So one of the hardware metrics that we want to gather is things like boot time. So how long it takes the phone from an off state to go into a usable state. I'm sure we all had phones at some point where you could press the button to turn it on, and it's just not responding. So you go and you make a coffee, and you come back, and you still see a boot screen. Like, that behavior is not acceptable for new users. It might be OK for early adopter types, but we're going to be giving this phone to people who may never have had a phone before, and we want to give them a good and optimized experience. So as we develop this phone, we want to make sure that we can gather data like boot time and make sure that we don't regress. Another important thing that we need to worry about now that we're running on a phone is hardware metrics as the phone is running. So things like battery life. Like back when we all had feature phones, you could turn our phone on, it would run for a week without having to recharge it. But now with our energy guzzling smartphones, we're lucky to get 2 days off a single charge. So we want to be able to make sure that as we progress with our phone and as we build it out, we maintain a good battery life and other hardware metrics like this. Now, one of our most important and interesting new test concerns is telephony. So the smartphone has to be able to do things like send a text message and check your network provider and make an actual phone call. And if you can't do this reliably, then it's nothing more than a frustrating portable computer. So we're going to have to figure out how we can actually solve for testing telephony. So now that we know what we want to test in general, how do we go about doing that? Do we have any tech lying around that can help us run tests for these concerns? Well, since Firefox OS is similar to Firefox, then we can use the test that we run against Firefox against it. We have many existing frameworks for Firefox, but none of them tackle all of the issues that we need to tackle here. We have things for rendering and performance, but we don't have things for telephony. We don't have a way of communicating to multiple instances at the same time because we never had to deal with cross-device communication. So what all this pointed out to was that we needed a new framework. And us being good engineers, we were wondering, wait, we shouldn't just let this be a Band-Aid solution. We have the opportunity to build a framework that can answer questions not only for now, but can build for the future so that any future framework that we build can leverage the work that we're doing now. So now that we figured out, OK, we need a new framework, what exactly should it solve? So this framework has to support our existing test frameworks. So Mozilla has hundreds of thousands of tests running against Firefox. And we want to be able to seamlessly run them against Firefox OS. It makes no sense to go off and make your own framework and then rewrite all the tests. Like, that's just madness and unnecessary work. So the ideal framework will be able to uplift all these frameworks into Firefox OS. The next requirement is that it should be the foundation for future frameworks. What this means is that to run any tests on the phone, we need to be able to communicate with that phone. So the test runner has to talk to the test device. And this is the core driving mechanism behind all of our frameworks. And any future framework will need to solve for this communication. So our framework should be able to provide this core pipework that's reusable across frameworks today and tomorrow. And the last requirement is that it should be reusable for any Gecko environment. So what that means is that whatever we create today should work on Firefox for Android, Firefox for desktop, and Firefox OS, and any Gecko product in the future. This will help us write one test framework once and then easily run them in any other environment later. So let's get to the gritty details of these requirements. So in order to uplift some of our existing frameworks, what do we need to do? Well, our existing frameworks currently rely on Firefox add-ons to run. They use add-ons so that they have access to the privileged to the privileged space of your test environment. So they execute code against the Chrome of the environment. And this is fine for desktop because it has the ability to run Firefox add-ons. But in the beginning days of Firefox OS, we didn't have the ability to run add-ons. We first started thinking about test solutions about 4 months after the project was announced. So we had very little to work with. We didn't know what direction the product will eventually go in. But all we knew is that we're going to be building this on top of Gecko. So while we didn't have the ability to easily uplift these frameworks using add-ons, that means that we have to somehow integrate our framework with Gecko itself. This was actually an opportunity because instead of running as an add-on, we now get to integrate directly into the engine and we would get a performance boost. So whatever we select as our framework, we have to make sure that we integrate the key parts for every framework so that they'll be uplifted easily without any problems. Another consideration that we need to take into account is that we're running on phones, and we don't want to assume that the phone will always be connected to a computer via USB. We want to stick them in data centers and somehow talk to them over the network. So whatever framework we have, we want it to be able to work in a networked environment so that we can remotely communicate with other devices. And the last but extremely important consideration is what can we actually open up on the phone? So we don't want to just test web views. We want to be able to test things like setting the battery and check if the web view has actually received this new information. We want to be able to get as much control on the device as possible from the get-go. So what can we actually control? So what this all boils down to is we need a reusable and easy way to control all different phones and to control multiple devices at the same time. And all of this should be done in an easy and reusable manner across frameworks. We want to drive the phone at all layers, and we want to have privileges across the device. So what that means is that I want to be able to change file permissions, but I also want to be able to do things like change app permissions. So the solution that we came up with is a framework that we called Marionette, which is essentially WebDriver meets Firefox OS. So why WebDriver? Well, the phone itself is a web device. So WebDriver was written so that you can manipulate user views from a user perspective, so you can test web pages in an easy and supported manner. The great thing about WebDriver is that it's the protocol behind Selenium. So by implementing WebDriver, we get to uplift our existing Selenium tests for free. And it's something that's already familiar to testers. On top of that, WebDriver is being proposed as the W3C standard for browser automation. So by implementing WebDriver, we essentially get to kill 2 birds with 1 stone because we can implement open web standards and also solve our testing needs. Another great thing about WebDriver is that it solves our remote access problem for free. It's already built in with the idea of local and remote ends, so you can communicate and create a session, a WebDriver session, with one device, and then also have another session with another device within the same test. So this will allow us to do things like cross-device telephony. And the other thing, other consideration is how will this help us with our uplifting frameworks problem? Well, WebDriver has this extremely helpful method called execute script. And what execute script does is that, yeah, you know what it does. It's totally hacky, but it's awesome because it works exactly what we need to do. What it does is that it lets you execute any arbitrary JavaScript that you want in the current application space. And that's exactly what Firefox add-ons were trying to do. We use them only to execute code on the device itself. But as I mentioned before, we needed to execute code in privileged space, that is the Chrome, and WebDriver only cares about content, so what the user sees. So what we ended up doing is we didn't end up making WebDriver itself, we ended up doing WebDriver++, so we added a few extra things to it. So we needed to access privileged space, so we added a new method called setContext. And what set context does is that it allows you to set the current executing context of your Selenium commands. So you can do things like, I'm going to set the context to content, I'm going to navigate to a web page, and I'm going to check what privileges this web page has. Then I'm going to set the context to Chrome, change the application permissions, and then go back into the content and check if my application has actually respected these permission changes. So this helps us write extremely robust tests, but it also helps us uplift these frameworks for free because now they can easily execute whatever JavaScript they want against the Chrome. Another key difference that our WebDriver implementation has is that the current WebDriver implementation doesn't have a full spec'd out area on gestures. And we're a phone, and we have a touchscreen, so that means that we want to automate user input, which is multi-finger gestures. So just to get our own work off the ground, we started working on the WebDriver specification for gestures. And what this means is that we added a bunch of gesture commands into our implementation. But the general way that we solved it is that we added the ability for you to create any gesture you want using chains of action primitives. So that is like I can chain one finger to do press, move, and release, but the other finger can just press and release. And then you can chain these things together to create any gesture you need. And the third difference that this implementation of WebDriver has to other ones in Firefox is that it's built directly into Gecko. And that gave us a huge performance boost because you're no longer running as some secondary concern, you're a primary concern. So to explain the gritty details of its implementation is David Burns. There you
go. So how does it all work? As Malini said, Marionette gets kicked off every time Gecko starts up. And so Gecko starts up every time the browser starts up. And we have this really nice server sitting there waiting for us to now accept commands and execute them. And because it's essentially just executing JavaScript, and like large portions of Firefox is written in JavaScript, we can now call pretty much anything. We can go all the way, as Malini said, from the browser Chrome, which is kind of where all the nice security areas are, down to the very insecure parts, which is a web page. And we can execute anything in between. So now we're essentially starting to drive a phone, an operating system with WebDriver, a standards-based automation API, just driving an operating system. It pretty much doesn't get any cooler than that. So I'm going to now split it out into kind of how we did things. We've done a number of things slightly different to the way the WebDriver project does things. And it's mainly because it's what fits better with us. So we essentially have a dummy client which just kind of sends arbitrary commands over to the device. The WebDriver project kind of does things with HTTP. Its protocol is kind of REST-ish. It's not proper REST, but it's close enough. And it delivers a nice JSON payload into a browser. Browser then knows what to do with it. And because we're doing things with a JSON packet, and we're doing raw sockets into the device, we only allow one connection. And the reason why we're doing it with pure TCP is because we're trying to utilize some of the other technologies that are going into Gecko at the moment, like the remote debugger. We're using a similar technology, but I'll get back to that. It's in the server part. So I'll kind of show you how, from a simple point of view, I'm just going to use the terminal. We can easily just kind of telnet into the device. I don't know if anyone can see that. No. Hello. OK. I'll leave it on the screen for a while. So we can easily telnet in. It shows that kind of a nice echo response from a telnet server. Can we have the computer? Sorry. There we are. So we get a nice echo response from a device. The echo is just coming from the phone, so it's so we can see what it's doing. But it means that we can go back to slides. So now we've got a nice mechanism into the phone. The server is kind of the really nice part. It's the nuts and bolts that kind of drives Marinette and kind of gives us all the ins into the device and into the browser to be able to control it. The mechanism we're using is what we've called the JavaScript transport layer. It's just kind of a raw TCP into the browser, but we now can send JSON payloads through it. And it's got a few little extra bits and pieces added to it, which aren't too important at the moment, but it gives us this mechanism. It's being used at the moment by the remote debugger, which is part of Firefox. So like if you have an Android device with Firefox for Android, you can kind of connect your phone to a host computer and then debug from Firefox straight onto the device. It's the same technology as that. We're just kind of now using it for automation. We've created our own actor because it's an actor relationship in it. And the actor then receives all the commands that are coming through. It kind of breaks down what's in the JSON payload and then kind of decides where it needs to go. Normally, it goes through to a listener, and a listener attaches itself to all the content that's happening on the page. So like if you have multiple frames, a listener gets attached to each frame so that when we switch from frame to frame, we just can carry on executing. So where are we using it? We're currently using it on devices, emulators. We've got a special build of Firefox for desktop called B2G Desktop. It's kind of got a number of all the instances, all the things that we need for B2G, minus hardware things. And we're using it on Firefox. It's now become, Marinette is now one of a tier 1 testing framework. So it kind of means that within Mozilla, if you push something into our repository and it breaks a Marinette test, it will be backed out and you kind of need to fix it. This is kind of how we view our test things. I know it's probably not going to be too viewable, but kind of on the left is commits grouped by pushes into our repository. On the right, I've limited the UI to only show the Marinette tests. That shows all the Marinette tests. So Marinette, and then hopefully by proxy Selenium, is now part of the Mozilla kind of waterfall. So every push that goes into Gecko now tests Marinette. It tests like the core parts of Marinette and then goes off and tests all the different parts that it needs to. And then in the center there, well, it's to the left of the Marinette part, kind of shows all the different platforms that we're running on. So we've got Linux, we've got Windows, we've got mobile devices. So we always know that Marinette's going to be there, and it's become so core to the way we do things. So how's it used? It's been retrofitted into a number of our test suites. As Malini said, we've got hundreds of thousands of tests, and like we need to test that things are working. Because essentially Firefox OS is a browser on a device, we need to make sure that how people manipulate the DOM is still working properly. How people are rendering CSS is still working properly. Our reference tests are kind of important. And we need to make sure that like JavaScript and all these other little bits and pieces that are core to the way Firefox works still works on the device. Except we can't use the testing frameworks before. We just need to kind of make sure the tests work. And we're also starting to go into new bits, so telephony. It's kind of important for a mobile operating system to be able to make telephone calls. You know, internet is all great and all that, but people like to use phones to make phone calls for some silly reason. And then we've got this interesting part. A mobile device has got multiple parts to it that we need to make sure that we can access. So the browser needs to access these. And then from an automation and testing point of view, we need to be able to instrument them and test them. So there's different parts. There's GPS, there's Bluetooth, there's USB. There's all these different parts of the system, cameras, things like that. A browser needs to be able to speak to the hardware. The hardware goes, well, here's all the inputs that you want, and then we go from there. And we need to test all of this. So I'm going to show you a quick test on the computer. So this is just, it's going to run an emulator. Emulators, just by nature, are kind of slow. What this is going to do is this is going to run a geolocation test. It starts up in emulator. It's going to set a number of different bits of information in the background to the emulator, then check it. It's going to be, yeah, in true emulator style. It's very slow. Runs everything. Hooray, and all our tests pass. But you can see it's set information, and then it's retrieved the information, checked everything's working. Back to slides, please. And then we also need to make sure that the UI is working. People need to make sure that they've got a functioning device, that if they go to make a phone call, if they go to set an alarm, they go to do all these things, those key parts of the system are working as they expect. They're working in a certain manner. But it's not just kind of making sure that Mozilla can make sure that the UI is working properly. OEMs who make the devices and are going to be flashing them for us, they're kind of strict on making sure that things work because it's kind of their name that's on the hardware when it goes out to people. So they want it to be of a certain quality. And for those who've kind of worked with iOS and with Android and have tried to kind of automate the UI and then kind of gone grey or gone bald because you pulled your hair out, we need to make sure that we give third-party developers who want to make apps a nice way to automate the UI if they need to, or if they just need to kind of execute different bits of code as they see fit. We give them that, because if you give them a nice kind of testing infrastructure, you kind of have a nice ecosystem that third-party people want to come. People want to build apps because they can prove that their app is of a high quality. So I'm going to kind of show you a test running on a device. If we can put it on this, please. Right. This is where I hope it works. So this test is kind of, if it wakes up the phone. Dun, 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 dun. The demo gods have struck.
There we go.
No, that's me. Let me show you how quickly the phone resets. While that loads, I'll get everything ready. Sorry for the technical delay. Right. Take two. Oh. What? Okay. Oh, that's why, because I'm... That look like it? Maybe not. Oh yes, all right. So kind of we try reset the phone between tests where possible because some parts we can't kind of clear out. So what it's doing is it's just going to set an alarm a few times and then kind of make sure everything's working. And I've broken it. Yeah, this was working earlier. Oh well.
I swear it totally was working earlier, right before the talk. But
yeah, okay, we'll just kind of skip the technical difficulties and we'll go back to slides. So kind of where we've been, a lot of our testing infrastructure we kind of had to be building on the fly as well. We just kind of started, because as Malini said, we were late to the game. We were invited late to the game. But we've had to play catch up very quickly. So we had Jenkins just running in the cloud, running our unit tests, our web API tests, so kind of the hardware part tests. And they were running them against emulators. Luckily, when we were at this stage, we didn't have hundreds of engineers working on Firefox OS. But then things changed, and we started getting more engineers, and more of the system started being built. And we needed to start running our unit tests, our web API tests, and our UI tests, because kind of we need to make sure that all the functionality is working. Gaia, which is a code name for the UI, needs to be working at a certain level. And we were running these on emulators, and we were running them on Panda boards. For those that don't know, a Panda board is just an Android development board. It allows us to kind of do some neat things. It's essentially just an Nexus S without a screen, and kind of looks like an Arduino or a Raspberry Pi. And then we went from there, and we started actually also testing on real devices. So we've got some devices that our OEM said was going to be of a similar ilk, and we started testing against those. And soon we're going to be testing against the devices that we're going to also be sending out to the public. This is what a rack of Panda boards looks like. It's there's a number in there. This is a unit that was designed by our IT department, and it's a number of Panda boards. They've all got Ethernet. They've all got power. And what happens is, whenever a test is ready, we flash the device. It's got an SD card on it that we can change, because SD cards only have a certain lifespan. We can swap out, it flashes the SD card, then we run our tests, and we go from there. One of the things mentioned earlier is that we also suffer greatly from flaky tests. Mobile is kind of one of those places where you're going to get a lot of flaky tests, and a lot of it also comes down to hardware. So one of the nice things about the Panda setup was we've got a framework called MozPool, and we've got in our pool, we've got lifeguards who kind of check how things are going. If they notice that a certain board has an increase in failures, it starts taking that board out of commission, kind of lets someone know, and then we can just kind of hot swap the device, because this is just in a data center, so our IT department can go there, swap it out, and carry on. The other part of our test infrastructure is making sure that we can do stress tests against the device. Kind of just running and running and running and running tests, because people don't really switch off their phones nowadays. They go to bed with them on, wake up, and it's still running. And that's kind of the major use case that people are going to be using, and we need to make sure that the device doesn't become sluggish over time, it doesn't crash all the time, things like that. We need to kind of do all these really weird and wonderful stress tests. We started doing fuzzing over it with a tool called Orangutan, which was written by Will, who's in our team, which kind of just does gestures on the device at a very low level and then kind of sees what survives. And we started doing performance tests against devices. One of the important things that people want to be able to do is like play games. Most people play games on smartphones these days, so we want to make sure that if you're playing a game that you're kind of getting a high enough frame rate. We want to aim for that 60 frames a second, so that we can kind of make sure that it's not jerky, it's not anything like that. There's no jank, which is kind of where you try scroll and it stops for a bit and then carries on scrolling. We want to make sure that those things aren't there. And these types of tests mean that we can kind of make sure that when we deliver the device to people, to OEMs, and when third-party people want to start using it, they have their confidence in what we've done. And that's it, really. It's been a huge learning experience for our team. We've learned a number of weird and wonderful things along the way, and we've tried to solve a number of problems, and hopefully we've shared it up with you all. Thanks.
Great, thank you, David and Malini. That was fantastic. I really loved that last picture there with the racks. I also learned the danger of calling APIs REST APIs, because sometimes your devices just take a rest. So, yeah. So with that, if you would like to ask a question, there's a mic in the back there and a mic over there. Feel free to grab the mic if you want to ask a question. And in the meantime, we'll grab one off of the moderator here. So first question up. How do you automate recovery for devices that fall off USB or get wedged outright during testing?
Okay, well, it depends on the device. So we have the Panda boards, which we can power cycle. And we don't use USB for them. We communicate over the network. Wedged outright during testing, I don't really understand what that means, but perhaps you do. But for other devices, we have to power cycle them. Like we have some tests using run directly against our phones, and we have to currently manually reboot them. But we have someone working on a solution for that right now, because manually rebooting them is just kind of not scalable at all.
Yeah, we kind of ask our manager to go, because we've got a kind of a big Faraday cage in our Mountain View office, and every so often we just ask our manager to go work in there for the day and just power cycle whenever we need to.
Yeah, so that'll be solved.
You found a use for your manager. Perfect. All right. Looks like we had some questions. So I think you were up first, so ask away.
Sure. You touched on UI performance testing at the end there, but what tools do you use to actually validate the UI performance? Do you have some kind of video recording, or people are watching it?
Yeah, so we have this tool called IDA-Ticker, and what that does is that it's just a camera that's focused on the screen, and it captures it and checks that the data is moving actually at 60 frames per second. So we have two ways of capturing that video data. One is to plug it in a video out cable directly to the phone and send it directly to our computer and analyze the HDMI output directly. And the other way, which is what we're experimenting with right now, is with high-speed cameras. And we're just making sure that each of the frames are changing at the rate at which we expect. Yeah.
Cool, thanks.
So follow on to that. So as you're sort of swiping or moving, one thing is the frame rate, but how do you actually know the animation is happening?
I don't know about the animation, but when it comes to swiping, one of the key things that brought us to doing this type of testing was when we rewrote a lot of the Firefox for Android stuff. When you scrolled, we were getting a lot of checkerboarding happening because the drawing wasn't happening fast enough. So we created a framework. Well, I say we. Will LaChance, who is in our team, he created a framework called IDA-Ticker, and that just kind of watches for these checkerboarding and then kind of works through that. He created Orangutan, which instruments Android and kind of tells it how to scroll and things like that. So it also allowed us to kind of test against other browsers, so we could see how well we checkerboarded. Well, we don't want to checkerboard, but how other browsers were handling the same website.
Great. Second up, I think you were up. And if you want, you can say your name and where you're from and then ask your question. If you just want to ask, that's fine too.
Hi, I'm Daniel from Snap Interactive, and my question goes to security. Like, obviously, Marionette is a really great thing that allows you to drive everything about the phone, but what if someone were able to get access to that and do those kinds of things through your phone that you don't want them to do? How do you kind of prevent something like that from happening?
At the moment, Marionette is only available in engineering builds. So you kind of have to build it in to Firefox OS. We're working with our security team to kind of work out a nice way for developers to be able to have Marionette. So just kind of go in, buy a phone from your local phone company, and then kind of start working with it. Because yeah, security is one of our biggest concerns. Privacy as well, because you know people might be doing internet banking on things like this, and we want to make sure that they feel secure, that they can do all these things, but also that if a developer goes and buys it, they can start working with it. So we've got a number of ideas, especially for desktop, how to solve the desktop problem. The mobile problem at the moment is just don't put Marionette on there, and then we'll kind of, as and when we can solve that problem, it'll start slowly being put back in.
Thank you.
Great, thank you. And another question over here, please.
Yeah, hi, I'm Jonathan from Sauce Labs, and if I recall correctly, you guys said that you, in your sort of WebDriver++ protocol, you speak JSON over TCP rather than HTTP. So I'm wondering whether I, as a potential Firefox OS app developer, can use standard Selenium client libraries that already exist to speak to Marionette, or whether I have to base it off of something you guys have written?
So our Marionette client library is it's 90% the same as the Selenium library. We've got, like, ideally when we get to a certain place, what's going to happen is WebDriver's got an idea of like the commands that it's got, and then it's got a command executor. And what we want to try to do is just switch in the command executor for Firefox only, and then kind of it just knows to speak through that and then works.
Thanks.
It's worth pointing out that the spec mandates HTTP and JSON conformance.
And the spec also says that we have to do HTTP. We've already got a shim that people can use, but my gut feeling is that the Selenium project is probably going to be using straight into it, and then if you're not one of the languages that the Selenium project manages itself, you'll probably go through the shim. So we're still going to have that, and it's just essentially takes the HTTP, maps it down to our TCP connection, and goes from there.
So let me take a question from the moderator, so those that are watching live and remotely also get to ask some questions here. So I can throw this one over to Malini, I guess. Do you prefer to run on automated tests? Do you prefer to run your automated tests on real devices or emulators?
Well, ideally, we'd like to run on devices all the time, but that's also, we haven't solved the infrastructure problem of how do we power cycle these devices, and devices are very finicky. Emulators have been incredibly reliable as a way of testing, so we've been running all of our tests, like anytime you commit code to Mozilla, we run our tests against emulators just because they're easy to put up in VMs. It's like a very easy platform for us to use. And it's actually fairly representative of the environment that you're running in. So for most cases, emulators do just fine, but we do want to build out more device testing. So.
Okay, and last question, and then I'll do some announcements right after this question. So please, from the audience again.
This is Guam. I'm from Android Testing Engineering. So from a mobile OS testing perspective, I think there's a lot of stack between what you're offering to the app developer down to maybe the kernel or the driver level. How do you solve the problem of poking the layers in between? Because from the presentation, a lot of the cases I've seen are mostly kind of like integration level or functional testing. Like how do you poke the levels in between? And also sort of in related to the question you just answered, there are device-specific characteristics or flakiness or problems. When you test mostly on emulator, how do you solve that problem?
for the first question, would you like to take that? I'll take the
Okay.
one. Yeah.
So for the first one, one of the things Malini mentioned during the talk was that we can set context and we can switch between different contexts within the browser. 90% of the time, what app developers are going to be using, well, actually probably app developers are going to use it 99.9%. They're going to be running everything in the content layer, which is kind of just your average web page. For what we're doing, we have frameworks like what we call Moki test and things like that. And what that does is that will speak through JavaScript into the Chrome layer, and then kind of it'll the best use case I can think of is how we test the DOM. A lot of the DOM stuff will be happening. That'll be happening in privileged space, kind of then pushes it out to the content space. And we need to make sure that when it manipulates it in a certain way, that we can then instrument it that way. So we just we can sit in the DOM, like in the Chrome space, the browser Chrome, and then kind of see what it's doing, ask it questions, and then get information back. We have access.
And with that, I'm going to let Malini have 10 seconds, and then you two can chat at lunch. So
Sure.
you get 10 seconds.
So for device-specific flakiness, on the emulator, we don't have we are able to distribute it to other people in our code and in our community, so that they can use it and test and make sure that it works in this environment. If it fails, then it's really up to them to fix those flaky problems. But when it comes to device-specific problems, you have to have the device on hand to resolve these flaky issues. And that's another problem, but that's why we rely on emulators so heavily as well.
All right, thank you. So we're going to break for lunch here. I have two quick announcements. If you wanted to do the topic tables, they're going to be out in the lobby. We have these conference rooms, by the way, the whole conference. There's 4 of them out there. If during any of the other sessions you need to take a break, you need to get some work done, you're free to sit in the 4 conference rooms that are out there. Right now, though, they have some signs posted outside as to what the topics are for each room. So you can grab food and then figure out the topic. If you have any dietary restrictions, you need a kosher meal, something without dairy or something like that, the people from our great food service are here in the back, and you can just ask one of them to help you out, and they'll get you a special meal. And with that, we are going to break until 1:15. Lunch is from 12:15 to 1. And then we're going to come back right at 1:15, so please be in your seat by that time to hear the next talk from Expedia on mobile automation and continuous delivery pipelines. With that, thank you, and have a great break. Hello, welcome back. This is always one of the toughest talks of the day. It's right after lunch. You're going to be a little sleepy. We could try some things. We could maybe have this elevator go up or down. Maybe you'll wake up. The truck could drive out here. If everybody is, as I could squish to the middle again, just to leave the easy access seats for people to go and sit down. And then if you need the caffeine, it's still in the back there. So coffee, juice, soda. You can also just run laps back there if you need to. With that, I'm going to go ahead and kick off the next talk. We're going to do a couple things in the afternoon here. So we have 2 full-length talks here. Actually, we have 3 full-length talks. And we're going to have a series of lightning talks. And the lightning talks are really going to be like lightning. They're going to be very fast. And there's going to be 5 in a row. So with that, I'm going to go ahead and kick off the next talk here. It is going to be Igor Dorovsky and Kostub Gwande are going to go and talk to us from Expedia about mobile automation and the continuous delivery pipeline. And so with that, welcome up, guys.
Thank you. Just to introduce ourselves, I'm Igor and he's Kostub. Oh, sorry, I got that messed up. I was just checking if you guys are awake or already asleep after the lunch. Okay, good. Let's jump right into it. Before we get started, I joined Expedia in 2004, and how many of you have been in a situation where the number of automated tests is 0? How many of you have heard your business or the product team say, you engineering team, you just cannot ship fast enough. You just cannot go quickly enough? How many? Oh, not bad. Okay, all right. So what I'm here to talk about is I heard the same things for many, many years. And we're going to talk about some of the things we've done in the last couple of years to try and address both of those situations. So if you're in that situation, stay awake. It will help. So let's get right into it. So here's a graph of what Expedia has done over the last few years. So the blue bar is the number of hotfixes we used to ship, 2005. And the green bar is the number of releases we used to ship. And the red is the number of what we call business A/B tests, where business can try different functionality on the site and let the customers decide what's right for them, right? So in the web world, that's where everything is going. You ship fast, you try different things, you let the customers decide. Don't assume you know what they want or what they like. And the last is my favorite, the purple one. The Expedia stock price is up twice. I wish the stock price was up 20 times versus the releases were up only 2 times, but unfortunately, that's going to have to wait for a while. So this is the best way to highlight what continuous delivery can do for you, right? It can help you ship faster, more releases, and then ultimately make you rich. So what does the agenda look like? I'm going to talk about test automation, some basics, because we have a wide variety of audience here and online. And so I want to make sure we talk about the basics. We'll show you what the continuous delivery pipeline of tests looks like for Expedia, specifically for our team. We work on the Expedia front-end side. So everything you see on the expedia.com or one of the Expedia sites, it's our team that's shipping that, including mobile. We do mobile web, mobile apps. And so we'll talk about a little bit about the test methodology and some of the unique things we have done in the last few years, as well as, and then Igor's going to talk about the specific tools we use. Almost everything we use is open source. So it's very cheap, free. And then we'll talk about the key benefits that we have gotten as a test organization, right? So specifics on what benefits I have personally seen and measured. All right, so there's a lot of talk in the industry about agile, continuous integration, continuous delivery. Most recently, if you guys are following, there's a lot of talk of DevOps. There's a whole DevOps movement going on. So this is the best slide I found out to explain what continuous delivery really means. So you start, in 2006, Expedia was agile, but we didn't really have a continuous integration system in place. Well, then we fixed that. 2006 to 2009, we had continuous integration in place. Didn't really have continuous delivery in place. So it's been a progression. The last few years, we've been focused on the continuous delivery piece. And my talk is going to be focused on and Igor's going to cover up the automation tools we're using, the test automation piece of continuous delivery. So it's basics. Most people know what a test automation pyramid is. What I'm here to tell you is just one simple thing. If you're serious about continuous delivery, get your test automation pyramid right. It's super critical to getting to continuous delivery, which means lots and lots, thousands, hundreds of thousands of unit tests, a small number of integration tests, and a very small number of UI or end-to-end tests, as we call them. It's super important. I'll show you a quick graph. So just over the last year, the green is obviously the number of unit tests that we have added. Orange is the medium or the integration tests, and the red are the large tests. For a long, long time, Expedia's pyramid was inverted. We were lots of UI automated tests, some integration tests, and very few unit tests. Man, it was so difficult for a tester to catch bugs, only relying on UI automation. It was crazy. So this has been a huge part of helping us get to continuous delivery, is get your test pyramid correct. Measure it and drive it insanely. So let's talk about the continuous delivery pipeline itself. So what does the pipeline look like? Before a developer checks in any piece of code, there are a series of pre-commit tests that they need to run, and Ari and the first talk referred to this. Most of these are unit tests. They run in milliseconds, and you can run hundreds of thousands of them very, very quickly. Once it's checked in a single branch called trunk, again, the Google talk referred to this as well, single branch, all developers are checking in code in one place. We run a couple of tests, sets of tests there. For the mobile team, we use JavaScript unit tests. So there's an open source tool called Jasmine. We use that. There are plenty of other tools. You guys can pick what you want. And then we run a series of trunk smoke tests. So what are these smoke tests? These are basic happy path functionality that a typical Expedia user would do. Search for a flight, book a flight. Search for a hotel, book a hotel, so on and so forth. So we make sure the basic functionality is working even before the build gets promoted to our lab servers. Once it gets promoted to assuming the previous tests pass, it gets promoted to the next stage where we run a much broader set of acceptance tests. These are a little bit more involved. Search for a hotel, change the dates, click on a few things, make sure like all the pry1, pry2 scenarios are working. Great, those are green. Then deploy it to an environment that is very special. This test environment does not have any live dependencies. No live services downstream, no live connections to third parties. One of the most interesting problems Expedia has to solve is we have live connections to hundreds of airlines, global distribution systems, which is where the airline fares get filed. And we have to talk to them in real time because airline availability and prices can change literally in seconds. I'm sure lots of people here have seen price changes all the time, right? And so we are dependent on third-party data in real time. And imagine trying to automate that. One of the hardest problems, I think. So what we do is we mask out all those dependencies and say we're going to focus on the UI only. We're going to stub out or mock out all the dependencies so that whatever we are testing only covers the UI, and we can find things fast, the things that our devs might have broken. So we run those on iPhone, Android, and then we use Chrome as basically a base device. It covers all the other devices that are out there that are slightly older, but they are still in use in usually Asia-Pacific countries and some of the European countries and things like that. So we try to cover as many of our customer base as possible. Keep in mind, none of the tests run unless the previous thing has passed and is green. All right, so some simple rules around the pipeline, right? It has to be green at all times. Okay, there are hundreds of check-ins coming in, not to the scale of Google, but at least we have 400 developers checking in every single day. The changes conflict with each other, things break. So it's important that there's a certain amount of discipline in keeping the pipeline green at all times. Otherwise, you cannot get to continuous delivery. If a build breaks, which can happen, it auto-logs the branch, so no more check-ins can get in. Let's not pollute the code base so that we can figure out which CL has broken the branch. And then what we do is we say, OK, if the build is broken, we have to fix forward in 10 minutes or less, or else the CL is going to get reverted. There is like, it's very, very like low tolerance for people keeping the build broken, right? And the reason why we kept the 10 minutes is we flirted with the idea of 5 minutes, 15 minutes, and all that good stuff. And what we realized is the simplest reason for a build break is when devs miss checking in a file accidentally. And it takes no more than 5 to 10 minutes to get the file back in and call it green. There's a build coach role where we rotate responsibility amongst different team members, developers, testers. We actually even have PMs do this so that they understand why it's important. Where if a build is broken, their job is to get it green in the 10-minute time frame. And what we have found is initially it used to take us 5-6 hours to actually get builds where they need to be. But now we are down to a 10-minute, 15-minute interval. So we have seen some good success there. All right. So let's talk about the overall methodology that we use in testing. And then Igor is going to talk about the specific tools we use to cover each of these. So Expedia is a very agile company. And customer is the most important thing to us. I think there is no test that you can write better than simulating exactly what the user is doing, right? And these BDD tools, and Igor is going to talk about a very specific tool that we use, let you simulate exactly the user actions. And the best part about it is you can have PMs, product managers, business even write them because it's written in English. You don't need any technical degrees. You don't need to be a superstar SET to write the Cucumber scenarios. Your test engineers, your PMs can write them as well. When it comes to, so we use BDD mostly for UI and integration level testing because that's more user scenarios. At the code level, we really strongly encourage our developers to take a TDD approach. Write the test first, then write your code, and your code is not good until the test passes. We have had mixed success with this, so we're still working on getting it better. All right, you have all these great tests in place now, fantastic. What's next? Let's take them, put them in Jenkins, which is our build system that we use. When you include them in Jenkins, we have to make 2 key decisions. What is the speed of the tests that are running, and how often do you want to run them? If they are really, really fast, you can run them very often and as part of every single build. So you get lots of regression coverage. If they are really, really slow, like the large test or the UI or the end-to-end test, well, guess what? You're going to have to figure out whether you want to run them a few times a day or like once a week or whatever. So again, going back to Ari's talk this morning, he talked about the quadrupulation of the problem. This is why we choose to run our large test only 12 times a day, every 2 hours. So they do not run as part of every single build. Just to go back, what that means is what you see here are all the regression test cases that run, except the large tests that can take hours to run. Some of our tests take 3-4 hours to run. You can't put them in the build. You got to run them at a certain frequency. So we run them every 2 hours. All right, so you have these tests. They are in Jenkins. But again, what do you do with live dependencies? That's where you use mocking, stubbing, remove them so that you can focus on testing your code, the stuff that your devs changed. Once you have this, you need to have visibility. People need to know what's going on with your builds, with your tests. So we use some Jenkins plugins. These are called build and test radiators. We're going to show you some examples, and we also have a video of how the process works in real time a little bit later. I have been in this situation way too many times. You have tests, they run, they fail, and people ignore them. They just don't care. Or they just go whatever. I mean, it's the tester's job to go take a look at them or the automation engineer's job. So it's, again, discipline in terms of how quickly you react to the failure and how quickly can you fix it. Again, the video will highlight how we have done it, and hopefully that will be helpful for some of you guys. So over to Igor. He's going to talk about the specific frameworks we are using for mobile and how it's integrated into the whole Jenkins system.
Thank you, Kastub. I enjoyed the speech a lot. I hope you continue until the end. But anyway, my name is Igor. I'm test lead engineer at Expedia for the past year. So was in mobile department second QA when I started, and I had to basically solve what kind of tools we have to use and how we can map them into the test pyramid to fulfill all the problems and solve all the problems we had at that time. So I try to go as fast as I can because we are limited on time. There are other talks in this conference about the specifics of some of these tools, but what I try to focus on how it fits into the continuous delivery process. So I'll start with Jasmine. So Jasmine is a JUnit test framework. We use that to basically fit it in the top of the pyramid, which is the functional BDD kind of, even though it says unit test, I still think it's a BDD approach for testing the JavaScript. So in order to run the JavaScript test in the Jenkins, we use the Jasmine Gem, which is a Ruby library, with the CI reporter to generate JUnit XML reports that helps us to draw graphs in the Jenkins to see how we progress over the time. And the good thing about Jasmine, it complements other UI functional tests, which is our Selenium test. And in order to write the Selenium test, we're using Ruby as the main language and Cucumber on top of it to write our test in English. Because Stu was mentioning it's important that the test has to be written in a language that everybody understands, including project managers, developers, and also QAs, obviously, right? Even product team is looking at the test to see what kind of coverage do we have. Later, I'll show you an example of a Cucumber scenario so you have a better idea for those who never seen that before. We also use Cucumber with Ruby to write our integration level test, which is the API test for mobile department specifically. And we use just regular HTTP library with a JSON parser. And it works very well for us. Again, it's all written in Cucumber in English, but it fits in the middle layer of the pyramid. That's our kind of integration test. And for the lower level pyramid, we use TestNG. Before we had the JUnit, but the problem with JUnit was it was kind of hard to parallelize all the tests, and TestNG solved that problem for us. So we use TestNG as our primarily unit test framework to test our platform, which is a backend kind of platform for the whole Expedia. And as Kastub mentioned earlier, that it's important that the test executes fast, right? So we're not going to be dependent on the live environments, and that's when EasyMock we use as a mocking solution for our unit test, and for the UI test, and as well as the integration test, we use our custom stubbing solution. So that helps to speed our test execution in the continuous integration environment. Okay, so the previous slide was actually mostly focusing on the mobile web and mobile web tools that we use. Here you can see we also do the mobile apps as a part of our team that we have to test both on iOS clients and Android clients. So specifically for the iOS, we use the Frank. It was the first framework that we started looking at last year that was supporting Cucumber. Like I mentioned earlier, for us, the BDD tool Cucumber was the main focus. Plus, we can use Ruby. That means we can reuse a lot of our test methodology that we established before, even for native clients. And that's why Frank fell to that category at that time, and we started using that. The only part that it cannot test with Frank is hybrid apps. It doesn't support the web views in your native applications. So for the Android, we're using Robotium, currently, but we're looking at the Calabash because Calabash is very similar to Frank. They're pretty much identical. The Calabash is basically, that's what we're looking for to transfer our test in the future, migrate all of them from Robotium to Calabash. And we'll start doing that by already converting end-to-end test, functional tests for Android. And because we also have a pipeline for the native apps as well, just like for the mobile web, we try to solve our stubbing solution with a tool called VCR. And it's not a joke, it's like regular VCR. It records live responses into the cassettes, which you can replay later. And this is our stubbing solution. It's open source. You can find it easily. Well, you can Google it. It's a great tool for testing native apps if you need a stubbing solution. Okay, so if you already probably noticed, guys, that we are big fans of open source tools in Expedia because they're simply free, and a lot of people contributing to them. But unfortunately, all of them has an issues. So some of you using the Selenium WebDriver either on iPhone or desktop browser like Chrome, Firefox, and maybe on Android. But because we're mobile, obviously we're dealing with the mobile clients. So specifically for the Android Selenium WebDriver, we found interesting issue. Whenever we try to test HTTPS pages and there is invalid certificate on your live test environment, your driver will basically get stuck. You're going to get blank page, and that's it. It's a failure. So the workaround was basically generate the certificate on the regular Chrome browser and then imported it to the real device. And it worked very well. Another problem with the Android Selenium WebDriver we encountered was the drop-down boxes, or drop-down options, they call them, right? So we couldn't solve the problem because the Selenium driver couldn't handle that. So we use the jQuery as the hacky solution, and it works up to date. So we use a sim launcher. It's a Ruby lightweight server to start our IIS simulator before we start executing Selenium test. And the problem was that that particular framework didn't have the flexibility to rotate the simulator while you do test execution. So one of our engineers in London actually he wrote AppleScript to add that functionality. So whenever we run our Selenium test, we can rotate simulator and see how our responsive design will render our mobile web application in the web view. And so basically, those problems are related, obviously, to the Selenium WebDriver, both on iOS and Android. Now, on the Frank, which we use to test our native app on iOS client, we just couldn't figure out how we're going to collect the logs if the application crashes, right? So what we use a third-party framework, Crashlytics, which is not free, but it's great. It gives you a lot of, and so probably only framework is not free we're using. But it gives you great information and logs. It's free now. Here we go. Awesome. So Crashlytics enables us to get the logs and crash logs, as well as networking data to analyze if the application crashes. And we also use the plist body I put here. Is basically when we are doing, besides debugging, we try to collect analytic data. We use plist body to change the configuration of the application in the runtime. It helps also to do more like I would say analytic logging and testing in that matter. And finally, I've been mentioning Cucumber many times. For those who haven't seen that before, this is the scenario written in Gerhim language in the Cucumber format, which is, if you guys look at the screen, it's very English-oriented, readable. It supports multiple languages. English is not the only language. The power of this is that you write your test in the business logic as your acceptance criteria. And then all the parameterization, all the parameters, you don't have to hard code into your code like we used to do with the unit test frameworks. Everything is here. This is the text file, right? And if you can look at this specific scenario where we try to test the hotel search against multiple countries in the Seattle area and make sure the image is there. If you want to just expand the number of countries you want to test, I mean localization, if you want to change the Seattle to New York, it can be done here. It gives us a flexibility and scalability, meaning that we are flexible in terms of adding, changing tests on the fly without looking at the code. It can be done by non-technical people like project managers, QAs, developers at any time. They call us three amigos, right? And another thing, it's a live document. It replaces the old test cases and old test suites. So we do not, in Expedia Mobile, we do not have any test cases. We do not have test suites. Cucumber, they call them feature files, are replacing those. Can you guys start the video? So right now, this is the live demo of how we execute our mobile web tests in parallel. It's important to have running tests in parallel for the speed of the pipeline, right? You want to get coverage as fast as you can. And this is UI tests, which are slow. They are the largest tests that go end-to-end, and you want to execute them on as many clients as possible. Here in the demo, you can see this both the iPhone simulator and Android simulator running the exactly same test. But what you don't see on this demo that we do in real lab, running against real devices on mobile web. So this is a great example that parallelization saves you tons of time, which you will need if you want to implement the continuous integration into your department, into your company. This is the sweetest part of automation, when you see this working. I think it's a 2-minute video. Once. We just basically kick the both tests. They are not starting all the time at the same time. The Jenkins control that. So for the purpose of the demo, we recorded both back-to-back simulators started at the same time. But they could be like delayed, but it depends on the check-in. They're triggered automatically. OK, so let's go to the next one. OK, Web Build Radiator is a Jenkins plugin that we're using at Expedia to monitor the health of the pipeline at the real time. This is the tool that helps us basically to spot the failure right away and to jump on it and make sure the developers fix it as soon as possible. Because Stu mentioned 10 minutes period, it's pretty fast. That's why visual representation is very important. I'm sure that probably most of you have been in a situation where you're running your test and there's a failure and nobody looked at it for a day at least, right? So these radiators are running on a big screen TVs around the office, and you'll see the video in a few minutes where you're going to see that how it helps to visualize the health of your pipeline. It's really important. And red color is basically a representation of failure, which track attention right away if there is one. So this is we call it Web Test Radiator. This is not plugin, it's just Confluence page where we are basically representing the graphs from different Jenkins job to see overall picture of a product. So this is the mobile website that we're using right now currently for the mobile hotels. And you can see on the left side, the graph is much greener than on the right side. It's because it runs against stop data and mock data. On the right side, the test running against the live services, which is test environment, still live services, which undergo a lot of changes during the day, and that's why it's much more redder. So when you are building a pipeline, it's important to have both and see what's going on with live services and stop data. Okay, let's play the second video. It's self-explanatory. Helps after lunch, right? To wake you up. So yes, this is exactly what we do. Responsive to the failures during the execution. You see what happened. Developer checked in stale code, broke the test. QA look at it, and it's not necessarily QA. Sometimes the project manager, even the director of the whole team comes, so Igor, why the radiator is red. So it's very important that it's actually the whole team participate in the process. And if they spot the failure, they react to this, fix it, and it's green again. And before I give my turn back to Kostyuk, I just want to make two keynotes. What I learned for the past year, what's important in order to be successful in terms of embedded test automation and continuous delivery, is you always have to plan ahead. Always plan your testing, either it's BDD test, functional test, or integration test, at least a week or 2 weeks before you start a sprint. Especially if you're an agile company, it's very important. Besides that, it's very important to understand what kind of test you will put into the pipeline. Not all the tests go there. Be very selective. It cannot be large. For those tests that you think are the one that is a good candidate for the automation for the pipeline, always make sure you consult with developers. Ask a second opinion. Talk to the project manager if it's good for the product. And for those tests that will be like for more like integration environment or any other live environments that will take longer time, like large tests for 2 hours or 3 hours execution, put them there. Make sure you segregate, right? It's very important. And now Kostyuk will wrap it up.
Yep. So just a quick recap of some of the benefits we have seen from doing this. This is just last couple of years. We have increased our Java releases. Content releases can go out every day, right? But Java releases are hardcore changes that can break a lot of things. We have increased that almost 4 times. The typical regression, like I said, you check in a bug. Oftentimes, it takes a day to find the bug, a day to find, fix it and verify it. Well, with this new system, you just saw in a matter of minutes, there was the The code got checked in, something broke, we noticed it, we fixed it, moved on, right? So worst case scenario, when we have massive breaks, maybe 4 hours to fix the whole thing end to end. But a lot of the time, it's been minutes that we can get issues fixed. We run hundreds and hundreds of stub regression runs every day that find all kinds of issues. And when you combine the number of regression you run with how quickly they get fixed, it really enables you to do continuous delivery. Just from my team standpoint, like the testing time we have saved by doing this is in the order of magnitude of 40%. So something that used to take us 5, 6, 7 days to test and ship, we're doing it like 2 days or less. And that's helping us move faster, get more agile. And obviously, the obvious one is the moment you have automation, you can run it on multiple devices in parallel. So we have 4 times the device coverage we have today than what we had a year ago. And as the number of devices in the industry are scaling, you really need a solution like that that you can just keep scaling more and more devices. That's it, guys. Questions?
Great. Thank you. Thank you. Yeah, I learned a lot. All I need to do mobile testing at Expedia is a cucumber, a radiator, and some Velcro to stick my phones on a wall. So thank you. Okay. In all seriousness, if you have questions, please do line up at the mics. I'll take some questions off the moderator here. Let's see. First question up. Did you find automated test in a different language, Ruby, than your application? Oh, wow, this one is hard to parse. It says, did you find automated tests in a different language, Ruby, than your application limits developers' collaboration on tests? Wow.
I'll take that. So we made a very conscious decision here. Last year, when we were picking Selenium, we knew we could run it with either Ruby or Java. And we said we'll go with Ruby, although all our devs are really good at Java. In fact, it was the developers who came and told us, you know, Ruby is a scripting language, works much, much better for automated tests as compared to Java, which can be a lot heavier. So it was in collaboration with devs where we said, OK, what is the right tool to use? And we agreed on using Ruby. Has it limited the collaboration? Absolutely not. We have our devs writing Ruby tests all the time. I just got an email yesterday saying a new dev that joined checked in 75 new tests that are now running in the pipeline. So I think the devs are actually really part of the solution here is collaborate with them and find what tool is right for you.
Great, thank you. All right, so we have 2 live questions. So I think you got here first. You can say your name, your company if you want, and your question, any piece that you'd like.
Hi, I'm Chris McMahon with Wikipedia, the Wikimedia Foundation. I'd like to ask you about enthusiasm for creating feature files in Cucumber. How do you build enthusiasm? Do you have enthusiastic contributors for your scenarios? And how big of a backlog of scenarios and feature files do you keep at any given time?
So I'll answer that question. When I started, I was the only enthusiast. But I have a full support from developers, and I think about that as a living organism, right? You have to infect everybody on the team like a parasite, and make sure that people all get the disease of cucumber, right? And then what happened is a year later, right now, everybody writing this. Let me give you a good example. Project managers write acceptance criteria in the sprint in the cucumber format. Then developers and QA pick this up, massage it out, make it look clean and nice, and put it Ruby logic into page object model, and all tests become live. So in my opinion, it's only a successful tool when everybody's using it. Everybody means everyone on the team. If it's only the QAs, you will fail. Does that answer your question? We will.
The statement was, let's take this offline later.
Absolutely.
Just so it's on the mic. OK. There's one more live. OK, there's live questions sat down. Guess I got their questions answered. We'll go to the moderator here. Does testing mobile web apps on real devices find more bugs than testing on a desktop browser resized with fake user agents?
Actually, it's a good question. Sometimes we have to test in real browsers, and a good example is a Facebook Connect. So Facebook login feature for Expedia, because of the limitation of Android Selenium WebDriver and iOS Selenium WebDriver, we couldn't launch the new window to test that functionality. So we used the Chrome with the iPhone user agent, where we actually did some resizing to test the responsive design, and also were able to launch the new login page for the Facebook. So yes, we try to use a lot of open source tools lately just to solve problems around the driver. So I'll wait for the Appium talk.
Yeah. I think just to quickly add, yes, I think there's a place for both. You want to use Chrome with user agent strings, but you also want to use simulators and also real devices. There's no one size fits all. You'll have to do all three because they find different types of bugs.
I agree. Yeah.
Great, thanks. Yeah, so here's a hot question that's been popping up further and further on the interest list. It says, does testing mobile apps, sorry, actually it just got itself to go down. Was the UI demo run with mocked data? Is your deployment to prod automatic, or is it gated with manual intervention? So how much automation do you have?
Yes.
And are you mocking out your data?
So the reason why we focus the talk on the test automation piece is because we haven't fully flushed out the continuous deployment piece. What I do know is that it used to take us 7 days to do a manual test run with all the different languages. Now it takes 1 day. So there is manual intervention, but it's like significantly lower. And one of the things that we did was we take screenshots as the app runs, and we push them automatically to our localization team, who are the experts in the UI. They look at that, and we get feedback in less than 24 hours. So we are also using automation to speed up the loc verification process.
Yeah, nice. OK, I think we have time for one more question, so we'll take the live question right over here.
Hi, my name is Alex Liu. I work for ITA Software by Google. Thank you for being such a great customer. I see that in Cucumber, you have product manager writing the test definition, well, the test objective in free form at the beginning of the test, and then you have a test engineer come and write the test itself. Over time, with such a large body of tests, how do you manage the test drifting from the definition?
So we have a regression plan, right? And we keep that up to date. Whenever a new feature changes, part of the job of the QA engineer is to go and update the existing tests that are there, and also deprecate tests. We routinely go in and even deprecate tests that are no longer valid. So it's the good thing is you don't have to go to a document and update the test plan now. You're actually updating your live automation, right? So which means that it's going to get run. If it sits there, you have a choice. Either it has to pass, or you have to remove it so that it's no longer applicable to the feature. So it's part of the sprint development process to go and update that.
And we use tagging for that. It helps a lot. We create different profiles.
Yeah, we have tags, right?
Very nice. So thank you, Kostub. Thank you, Igor. And if you guys want to suggest a topic table tomorrow, it sounds like Cucumber is going to be a hot topic. So
sure.
Yeah. So thank you. Thank you.
Thank you.
So now we're going to go ahead and enter into our series of lightning talks. Each one of these is going to be 15 minutes, including Q&A. And so we're going to keep these pretty fast-paced. First one up here is David Roethlisberger, and I'm going to start a rumor that he's related to someone on the Pittsburgh Steelers. So he says he can get everybody free tickets. So with that, he is from YouTube, and he is going to talk about automated set-top box testing, which will be fascinating. Thank you.
Won't need that.
OK.
So it's UView, not YouTube.
Oh, sorry. Oh, UView.
So if we could have my laptop up on the screens, please. OK. So at UView in the UK, we make set-top boxes. And to test our set-top box, we have scripts running on a PC, sending infrared signals, pretending to be a human user, pressing buttons on a remote control. And we check the video output from the set-top box using video capture hardware and image processing to ensure that it's done the right thing. Of course, we have many other types of tests as well, but this is the most interesting one to talk at a conference like this. So today, what I'm going to show you is how you might go about implementing such a system. The command line we're looking at here runs GST launch, which is provided by GStreamer. GStreamer is a set of libraries and utilities for handling audio-visual media. If you use Linux on your desktop, your media player is likely to be Totem, which is built on GStreamer, just to give you one example. So let's run this. GST launch takes as its command line argument a GStreamer pipeline. So these exclamation marks here, GStreamer's equivalent to the shell's pipes. So this pipeline has a video test source element generating a video stream with this test pattern, and its output is piped to this color space converter element, which converts each frame to a format understood by the next element in the pipeline, which is X-image sync. A sync is an element that consumes video, and this particular one renders it to an X11 display. GStreamer ships with a ton of different elements, such as this one. V4L stands for Video for Linux. It's an API for drivers. And V4L2 source supports any device with Video for Linux drivers, such as my laptop's webcam here, or it could also be an external video capture device. We can customize the behavior of individual elements by setting their properties. So if I go back to video test source, I can set its pattern property here to something different, and we can see it's generating a different video pattern. Now here's what gets interesting. I'm going to add this template match element. Template match is a thin wrapper around an open source image processing library called OpenCV. The CV stands for computer vision. OpenCV is originally by Intel. And template match takes a path to an image. And I'll show you what this image looks like. It's this white circle on a black background. And when I run this, we can see that template match is drawing a red border wherever it finds a match in the video stream. Now the CPU overhead of the image processing is introducing a little bit of jitter into the video stream, which causes some timestamping problems for the sync. So I just tell the sync to ignore timing information in the stream itself and just display frames as soon as they arrive, and it's a little bit smoother. Right, so each element can post messages to the GStreamer bus. So I'll ask GST launch to print those messages. And here we can see that template match has posted a message for every frame that it's processed, showing us whether or not it found a match and the X and Y coordinates of that match. So I hope that you can see how all these pieces fit together and how easy it is to develop a video capture image matching system of this type. All these components are open source, so we can really take control of our test infrastructure. We're no longer beholden to proprietary systems. Now, I consult to a company in the UK called UView. UView is a joint venture by the BBC and other major UK broadcasters and ISPs. And UView makes a set-top box. To test the set-top box, we've developed STB Tester, and we've open sourced it. So it's built on these components that I've just demoed. So it supports any video capture hardware with Video for Linux drivers, or indeed any GStreamer source element. And it uses GStreamer's Python bindings. It allows you to write your test scripts in Python, and they look like this. Set-top-box-tester.press sends an infrared signal. Wait for match searches for the specified image and raises an exception if it doesn't find it. So this script navigates to our network and internet settings menu, and we've encapsulated that into a separate Python function so it can be reused across scripts. Then we press down until we find this image, and I'll just ask my editor to display those images in line. So I'll remind you, this is just Python, and those were just string literals. It's my editor that knows how to display the images in line. It's Emacs before anyone asks. So So we press down until the submenu is selected. We press OK, then we press right until this automatic option is selected. Then we press down and we assert that the next button has been highlighted. We press OK, and within 30 seconds, we expect to find this image. So as you can see, it's very simple, it's very readable, it's entirely procedural, and it reads much like a manual test script written in English. So non-programmers on the test team have no trouble understanding this and relating it to their own requirements, test coverage matrices, and so forth. But at the same time, it is Python, so it's very powerful, and you can do anything you can imagine, really. So I'll just show you a couple of quick examples of other stuff we've done. This is a video I recorded earlier of an STB tester script that knows how to navigate through this double carousel of players. So I've told it to find BBC iPlayer, and now that it's found it, I'm told it to find 40D. So again, the red rectangle is showing us where STB tester has found a match for what it's looking for, and now that it's found 40D, I've asked it to find demand 5. So it's looking for this long, thin blue rectangle to identify the current selection. It looks for an image of the unselected player to find where it needs to go, and it figures out what buttons it needs to press to accomplish that. And I'll just play that again while I show you the source code implementing that logic. I won't go through it, but it's just to show you that it's fairly simple. It's barely 2 pages of code, and most of that's doc strings and doc tests, although I have removed error handling. But if you're interested in seeing the full code, I've posted it on stbtester.com as an example. So essentially, your script would just call find player, pass in an image of the unselected player to know what it needs to find, and an image of the selected player to know when it's got there. As another example, this state machine is UView's setup wizard. So each image in this diagram, each node, represents a possible state that the UI can be in, and each edge represents an action that a user can do from that given state. This diagram is generated entirely automatically from some Python code we've written to describe the setup wizard. Each image you see is exactly the same image that STB tester uses to identify that the UI is in that particular state. And each edge, each user action, is a Python function that carries out that action. And you can click on one of them, and it shows you the source code implementing that, and this is all fully hyperlinked, so you can drill down as deep as you like. It's very helpful to, non-programmers can still follow the flow of each of these functions here. So you could write a test script where you explicitly call each of these actions in the order you want them, or you could do something smarter. We do, after all, have this representation of the state machine, so we can randomly generate random walks through it. Or you could have a test script that takes a given path and just tries cutting the power to the set-top box at every possible state just to see what happens. This kind of stuff that's incredibly tedious to do manually, especially for each software release. I'll show you the full state machine there. All done. So if you look at this in a certain light, it almost looks like a wireframey kind of UX design document. And really what we're aiming for is fully machine checkable specifications. And this is all generated from plain text files, so it's version controllable, all that good stuff that we're used to for our code as developers. We can now have for our specifications as well. It's very exciting. Before I quickly take some questions, I'll just point out the stbtester.com has loads of documentation. We've got introductory material, some videos to help you get started. There's mailing list if you have any questions, and we try to do the development of it as openly as possible. So thank you for your time.
Great, thank you, David. All right, we can go ahead and pull up the moderator. If you have questions, you go to either side here. In terms of asking questions, yeah, it was very fascinating the way you did the the sort of image matching and so forth. I'll start off with a question of my own. How complicated does the image logic have to be, or is it just very pixel perfect in terms of matching and looking for elements?
Since we capture video directly from the set-top box, we're not going through cameras or anything like that. We have fairly high fidelity images, but we do have video capture hardware that does H.264 encoding in the hardware, so we do get some artifacts from that. So our image processing algorithm does handle that, and it's got a few knobs that you can tune either globally or for a specific image if you'd like.
Very cool. Yeah, he also reinstilled my faith in Emacs as being cool, the fact that it will embed the images for me. OK, I'll take a question right here off of the moderator. It says, does having images and test scripts cause flaky tests when styles change?
So I wouldn't call it flaky tests. I'd say that the tests start failing predictably if the style changes. So yes is the answer to that question. As you hopefully gathered from some of my examples, most of the actual image matching we actually pull into library functions, which the test scripts call themselves. So very few test scripts actually read like the one full of images that I showed you at the beginning. So it's just a matter of changing the common functions, and or your scripts start working, and you can do things like match any of these images so that your tests continue to work across different software releases if you need to still be testing a version that's in production that's got different images than a development version.
Nice. Clearly, this next question was written by somebody who has done this. It says, how do you manage the image repository without sucking the soul out of some poor test engineer?
Well, again, everyone seems to be fixating on these images. To be honest, the main problem we've had is not with the image repository, it's with flaky video capture hardware. So I guess the answer to this question would be much like the previous one, where the image repository is fairly small compared to the number of tests that use it. And we also have a lot of unit tests of our tests. We've captured a lot of screenshots, and anytime we want to make a change to the image processing algorithm, we run all those unit tests against our collection of previously captured images to make sure that everything continues running properly.
Great. Is this a live question? Yeah. OK, sure. Go ahead. We have time for just one more.
OK, so just wondering if you used your framework to measure performance, let's say, such as latency. If you click on something, how long does it take to go to the other view, such things like that?
OK, so when we're doing the image processing on a full-sized, 720p or whatever full-sized video stream, even with a fairly powerful computer, we can't do the image processing in real time. So what we do generally is we just drop frames if we can't process them. But for testing performance, we flick a switch in the test script, just for we use Python Context Manager to have this apply to just a portion of the script, where we queue up every single frame, and then we can measure things like that, like smoothness of animations or latencies. Latency is a bit difficult because we've got to take into account all the various latencies in the system: the video capture device, the encoder, the infrared emitter, and so on. So we're working on it. We're getting there.
Great. And with that, thank you, David.
Thank you, Tony.
Very insightful. So our next speaker up is Ken Kenya. He is from Google, and he's going to talk about WebDriver for Chrome. And so with that, have fun.
Thank you. All right. So thanks, Tony. So to start off, my name is Ken. Just a little bit of background. I work on the Google Chrome testing team, particularly on just the browser side. So a little bit of background about how kind of Chrome testing is broken up, just real quick. There's the browser team, then there's kind of the mobile team, and then there's the OS team. So I'm primarily on the browser side. Okay, so basically I'm going to be talking today about a tool that we have supported within the Chrome team, which is called Chrome Driver, or also called WebDriver for Chrome. So you can see up here, it's a very simple problem. Many of you are probably familiar with it, maybe even familiar with the tool. So we have in Chrome, just Chrome, over 300 million active users, and this is pretty old data, but that's at least, that still holds true, hopefully. But so we have ever expanding amount of platforms. So of course we just started with Chrome for beta on Windows 2008, expanded to other desktops, now Mac, Linux, and then more recently Chrome OS, branched out into Chrome OS, and then now mobile, Chrome for Android and Chrome for iOS. So the basic question is, as a web app developer, how can we or how can I go about automatically verifying that the critical functionality of my app works across all these different platforms? So this is a pretty broad question that you could look at just in browsers in general. But today, this talk, I'm just going to focus just on Chrome. So within Chrome, how can I verify my functionality, the critical functionality that my app provides across all these different platforms automatically? And so hopefully, during your development process, you've engaged in good unit testing. And maybe if you're a really diligent tester, you've also done some sort of isolated component testing. But at the very end of the day, you want to be able to have some guarantee that what the end user sees and what you go through as an end user is actually correct. And basically, the solution to this problem is Chrome Driver. So a little bit of background. Chrome Driver follows the W3C WebDriver working draft that some of the Mozilla guys talked about a little bit earlier on this morning. So because of that, it's interoperable with all the open source WebDriver client libraries, whether it's Java or Python or Ruby, whatever fits your boat. It is open source. Chrome Driver is open source and maintained by the members of the Chromium project. And Chromium, for those of you who aren't familiar, is just the project that supports Google Chrome and other Chromium-based browsers. So for the rest of this talk, I'm just going to describe a couple things. Number one, how can you use Chrome Driver? What does it actually do? Number two, what kind of work we have done to enable Chrome Driver to work not just on desktop, but also the other Chrome platforms, specifically Android in this talk. And then hopefully I'll give you a little bit of deeper dive about how exactly Chrome Driver works, just for you guys who are curious, or maybe who want to adopt kind of similar technologies underneath, depending on what your frameworks you are using. So to start, WebDriver. So that previous slide doesn't really make a whole lot of sense if you don't know what WebDriver is. So WebDriver is a cross-browser automation API, which is primarily for website testing. That's what it historically was for. Now there's become more use cases, wider audiences using WebDriver. But that was at least one of the main original, and still is the main intention for WebDriver, the WebDriver API. So it's cross-browser. So this API covers, I listed a couple things there. We have browser control, being able to simulate the user input, whether it's mouse or typing, keyboard, etc. And also another category I just put together is web stuff, random web kind of stuff. Like being able to find elements on a page, evaluate script, evaluate JavaScript, manipulate local storage, cookies. So that's basically WebDriver. So WebDriver is cross-browser automation API. And Chrome Driver is essentially the implementation of that protocol for Chrome. Not a very difficult concept. But so just to get you a little bit familiar with those of you who perhaps haven't seen a lot of WebDriver stuff before, here's a sample test written in Python using the open source Python WebDriver library. That first statement, we're just creating an instance of Chrome Driver. We're passing in the path to our Chrome Driver binary executable. We'll talk about that a little bit later. Second statement is simply navigating to our test page, in this case, which is Google. Then we're finding an element on that page with the name Q. We're saving a reference to that element inside this variable search box. We send some keys, which is just typing. We type Chrome Driver. We submit that form. And at this time, WebDriver will then wait if there's any navigation that's occurring because of that typing or because of the form submission. And then we actually do the one actual test part of our test, which is we assert that Chrome Driver is in the title of the page that we have navigated to. And lastly, of course, we just quit. So that's a simple, really simple test that hopefully gives you a feel for what you can do with the API. So now, how can we go about using Chrome Driver? So an important thing here is that Chrome Driver actually for desktop, for Windows, Mac, and Linux has been around for quite some time, over a year. You can easily find that on our public Chrome driver site, code.google.com/p/Chrome driver. Of course, you can just search for it. But recently, in the past couple months, a lot of several members of the Chromium team from Android, also from the browser side, have been working on a new version of Chrome driver, which we just call Chrome driver 2. And pretty creative. But so basically, this is a re-architecture of Chrome driver to to be able to span, like I was talking about at the beginning, more Chrome platforms. Because we want our testers to be able to run these tests against as many Chrome platforms as possible. So with this re-architecture, we're able to support not only desktop, as I have listed at the top, but also Android. And so yeah, I'm happy to announce that we do have alpha support for Chrome on Android, Chrome driver on Android testing with Chrome on Android. And you can get hold of that on our website. I posted a couple links here that you can look at. A couple caveats with the Android alpha. Currently you do need a special configuration. You do need a Mac or Linux host connected via USB to your actual Android device. But essentially, and there's also a couple other things like you need Chrome 27, a couple more details that you can see on the site. And basically, though, really what you need to do is specify the Android package capability when you start your session. And for Chrome OS and for iOS, unfortunately, if you want to use that, you just need to be patient or want to contribute. So you have to wait for that. So how does it work? A little bit background on how it works. So there's mainly 3 components. On the left here, I have the WebDriver client, which is essentially your test. Doesn't have to be a test. Maybe you're writing something else, which uses the WebDriver library, which is available in all those different flavors, different languages that I was talking about earlier. That communicates. These are all processes, at least for Chrome. So that's one process, your WebDriver client process. And that talks to Chrome driver, which is the tool that we're talking about in this talk, which functions as the WebDriver server. And that, of course, communicates over the standard WebDriver protocol that we've been talking about today. And Chrome driver talks to Chrome, controls Chrome via, right now, two main ways, DevTools and extensions. And so this is Chrome driver 2. The old Chrome driver used a different Chrome automation API, which was desktop only. But so now we're just going to talk about Chrome driver 2. So a little bit about DevTools and extensions for those guys who perhaps haven't heard a whole lot about it. So DevTools is the same thing. You can see it easily in Chrome by just right-clicking the page, going left-clicking inspect element. You'll see that kind of debugger view, kind of like that comes up usually at the bottom of the page. And you'll see the DOM tree. You'll be able to see performance metrics. You'll be able to see, you can trace and see the network activity, what's taking, so what resources are taking, how long to load, and kind of that breakdown. So that's essentially, that debugger kind of interface is using basically DevTools underneath. DevTools, of course, is short for developer tools. So we're using that. And the main benefit behind using that is, number one, it's pretty low level. It used to be mostly implemented in WebKit, which is now Blink, or been split into Blink. But it's supported on all the platforms that Chrome runs on, except for iOS currently. You can do, on iOS 6 Plus, you can do DevTools, but it's only officially supported through Safari on OS X. So we can't actually access that right now with Chrome driver on iOS. The second main tool that we use, or API that we use to automate Chrome, is the extensions API that Chrome comes supported with. So, of course, many of you guys are familiar with extensions, the concept of extensions. But they initially were extensions were meant to modify or enhance the functionality of the browser. And we've taken that and we've just, of course, plugged in our own custom extension and be able to control the browser through some of the APIs that are provided there. But however, since extensions are only desktop only, we've relied mostly on developer tools for most of the stuff that we care about. So here's just a nice diagram for you guys who are interested in kind of what overall the implementation really looks like. So there's 3 pieces here. There's the Chrome driver server, and there's the browser. Chrome's multi-process browser, so you have that browser process, and you have those 2 render processes. You can see commands will come in through the HTTP server from our WebDriver client. They'll be delegated to a particular session So perhaps you might have multiple WebDriver clients talking to this one Chrome driver server. So you might have multiple sessions. And these sessions usually control their own instance of the browser. In this case, it might be a little bit misleading, but you can see there's each session has a line to this DevTools server. Usually those are separate browsers. But the sessions will talk to the DevTools server, which then delegates down to particular renderers through the DevTools agent. And hopefully your web app that you're trying to test is running in one of those renderers. And in another one of those renderers, hopefully we have the Chrome driver extension running to be able to do some of the extra stuff we need to do to automate the browser on the desktop. So what's kind of some of the future stuff that we're considering for this tool? Some plans that we hope to start on. So in general, since we have switched to developer tools for the basis of controlling Chrome, that gives us a lot of since a little bit lower level than our old API, it gives us a lot of really cool features like being able to profile, what in JavaScript on your page is taking up so much memory, what kind of memory leaks possibly do you have, some interesting performance measurement stuff, access to like logs of the JavaScript console. Talking more specifically about Android, we're considering supporting the upcoming Chrome-backed WebView. So right now, WebView is, of course, kind of an Android concept. When we are considering, though, supporting when actually Chrome supports or powers that WebView to be able to integrate with that and actually test that. We are considering also running the driver on the device instead of that requiring that host configuration I was talking about earlier. For iOS, it's a little bit tricky, as I mentioned, because of the limitations just in the UI WebView, how we're using the UI WebView in Chrome for iOS. And we're still pretty in early stages of development and kind of planning. So not a whole lot to say there, unfortunately. So that's basically the end of what I wanted to talk about. So if you're interested in using Chrome Driver as a tool, we have ways that you can file bugs. I have that link up there. Also, there's a user forum, public user forum. And of course, since it's all open source, we'd love to have third-party patches, contributions, you name it. But that concludes my talk. Thank you.
Great. Great, thank you, Ken. You've come a long way since writing games based on the Powerpuff Girls, so nice job. That's what happens when they tell me these little tidbits. So it looks like we maybe have time for one question. If there's not a live question, okay, let's go ahead and take one live question, and then we're probably going to just move on to the next talk. So please.
For some time, Firefox has been able to control the I've lost the word, the profile. I think that's Chrome's handling of profile now has parity with Firefox's, and I don't think it's part of WebDriver specification. Is that something that you're talking to Mozilla about and will continue to support, is manipulating profiles in Chrome?
Right. So to start off, we are not currently talking with Mozilla about that. But we are interested in maybe not supporting profiles per se, but there's a distinction in Chrome, I'm not sure about the other browsers, between your user data directory and also your profile. So for Chrome driver, we do in the tool allow you to specify a custom user data directory, which maybe has several profiles already set up, be able to do stuff like that. But we don't have any way like now to dynamically, through the WebDriver API, create new profiles or edit profiles or anything like that. But yeah.
Great. Thank you, Ken.
Okay, thanks.
So our next speaker up is Wojtek Jena. He likes funky jazz, and he has a very action-packed talk. He's probably going to run right to the middle or to the end. So he probably won't have questions, and we'll just go right on into the next talk right after he's done. So here you go. Great. Thank you.
Thanks. Good. So this conference is about automation and testing, right? So I assume you guys are one of those crazy people who try to automate everything, right? Even if it takes more time than doing it manually, we write a script for it because that's what we believe in, right? And that's cool. I mean, Angular team, we are the same. Like, we basically try to automate everything. So from simple things like automatic deployment to the website, to things like, we have CI server, and whenever I push some code to GitHub, it automatically builds Angular, runs all the tests on different browsers, and screams at me if it fails. Or every release has a changelog. That's basically a list of changes, like list of new features, bug fixes, breaking changes. And you know what? We generate even that. Like, we have a convention for Git messages, and then there's a script that basically generates the changelog based on the Git history. Or my favorite example is Angular docs. So let me actually show you the docs. It's if you go to docs.angularjs.org, there is Angular documentation. And this is, for instance, API docs for ng-click, which is a directive in Angular. And down here is an example. Here is a source code for that example. And then there's a live preview or like demo where you can actually play with it and see how it works, right? Cool. I mean, of course, the whole documentation is generated automatically. But the thing I want to show you is this second tab, which says end-to-end test. And that is basically an example for you how you could possibly test such a code, right? Like end-to-end test for that. But what do we do with that? We extract all these tests, and then we run them as a part of the build. Let me show you that. So it looks like something like this. And you can see it's basically going through the whole documentation and checking whether all these examples still works. And this is really awesome, because before we did this, it would be like all the time it would happen, like someone would email me like, hey man, your docs example for HTTP doesn't work. And I'd be like, oh, cool. I even didn't know that there was an example for that, But now with this, like, you don't have to think about it. Like, if you break it, it will scream at you. So we basically try to automate everything. Let me kill this guy. And we do testing a lot. We rely on testing a lot. And therefore, we want to make sure that our testing story is really efficient. And that's pretty much why we did Karma, which is, I would say, a test runner that fits our needs, because we made it for ourselves. And that's what I want to show you now. I want to show you this test runner that we use to test Angular and pretty much to test any JavaScript. So let's do demo. So Karma is an NPM package. So assuming you have Node.js, you can install it through npm install Karma. And then first thing you need in order to start, you need a configuration file, which is basically for Karma to know about your project. Basically, where are the files of the project, what browsers you want to use, which testing framework using, and stuff like that. To make it simple, you can generate this config file by Karma init, and it would ask you a couple of questions like what testing framework you want, use, and which browsers and stuff like that. And it will generate the config file for you. Or if you are using Grunt, do you know, guys, Grunt.js? It's a really awesome task runner for JavaScript. So if you are using Grunt, you can. There's a Grunt plugin for Karma that allows you to configure Karma through Grunt, and you don't need this configuration file at all. All right. For this demo, I'm gonna be using Angular codebase, which already has this config file. So we can start it. I can do Karma start, and what's happening in the background, it starts a browser that I told in the config file that I want to be using. And we can forget about the browser for now. But the important thing is that there is a real browser in the background that Karma will use to actually execute the task. And that's something I want to actually talk about, because you can execute, you can test JavaScript even without browsers. You could do like on Node.js and Rhino. But for us, it was really crucial to use real browsers, because if you know Angular, there's tons of like components and custom directives and stuff, and that's tons of DOM manipulation. And we need the DOM API. We need to test these things. So we need real browser for that. Plus, you know, there are so many inconsistencies between different browsers, and honestly, JavaScript itself as a language, it's not that bad. It's pretty consistent. But the DOM API, that's what's, you know, most of the issues are. And so again, for us, we need real browsers. Plus, third thing, there is a good advantage. Once you're using real browsers, it basically communicates through HTTP and WebSockets. So it means you can use any browser. Like you can test your phone, your tablet, TV, PlayStation, whatever you want. Okay, let's go to source code. And another thing that's happening in the background is that Karma is now watching all the source files of my project. And whenever here is like Cache Factory, some service in Angular. It's not that important what it is. But I'm going to save the file. Just press Command S. And you can see that Karma immediately see that and starts executing all the tests. And you can see it executed over 1,800 of unit tests in like 3 seconds on a real browser. Right? And I mean, 30 seconds is not that bad. But if you have a huge project, it can be more. And our goal is to get this instant feedback so that I can run these tests all the time. Because what I really do during development is like, I want to run these tests on every save. And that's why we have this feature, we call it ddescribe and IIT. You know, on the right side, that's my test. I'm not sure if you recognize the syntax. It's a Jasmine testing framework. So I should mention that Karma is agnostic of testing framework. You can use it with any testing framework you like, pretty much. There's adapter for QUnit, Mocha, Jasmine, and NodeUnit and stuff. We on Angular are using Jasmine. That's why this example is in Jasmine, but you can use anything else. And describe in Jasmine basically means like defining a test suite, you know, list of suites. And it means defining a single test. And what I can do, I can focus these things. So I can put ddescribe, and now when I save, you can see it immediately executes just this suite. So it's even faster, right? Like now it executed only 24 of these 1,800 unit tests, and it was like, I don't know, a few milliseconds. And so the goal is, and the thing why this is important is that it gives you like a new workflow. It's basically like using tests as a development workflow, where you can stay in your text editor, and you don't have to move back and forward between browser and your text editor to see how things works. Because what I can do, let's say in this test, I can do, I don't know, console log, cache one, whatever it is, maybe give me size, right? Okay, it gives me error. Undefined, whatever. OK, so there's no size. So I guess there's info. Right. And the thing is that I just saved the file, and I immediately see in the console the result from the real browser. So I don't have to go to the browser to do these things, you know. And this is really important for the workflow because you can stay in the browser. In the text editor. One more thing that I want to mention is that there's no support from text editor. Like I'm using Sublime. You can use Emacs, Vim, whatever you want, because the only thing that the text editor in this workflow does is saving files. And I got one more thing that I want to show you, and that's debugging. Because what I can do, inside this code, if I want to actually use real debugger, I can do this, and guess what? I can go to the browser that I have somewhere in background, and I have debugger. You know, I can watch variables, I can see call stack, I can step into functions. And this is not feature of Karma, that's just the browser has. Like most of the modern browsers, they have debuggers, so it only allows you to use that. And again, you don't need any support from the text editor to do that. if you happen to using something like WebStorm or some better IDEs, you can even configure it to do this debugging directly from WebStorm, so you can put breakpoints and stuff, and you even don't have to leave your IDE for debugging. All right, I think that's, there is tons of other features, like it can do code coverage, it can pre-process files so that you can develop, like you can use CoffeeScript and it will compile CoffeeScript on the fly. There's a Dart plugin for testing Dart, all kinds of other plugins. But I think the most important feature is the workflow, that you can run tests and instantly see and instantly get the feedback. That's the main thing. So that's what I wanted to show you. If you like it, you can go to GitHub, check it out. It's open source, so send us pull request. And as I said, we're probably running time pretty soon, so I'm not sure if we're gonna have questions, but I'm gonna be here today and whole tomorrow, so find me. I'm more than happy to talk to you guys about pretty much anything.
Thank you, Vojta. Actually, I think we may have time for
cool.
One question. I have to say, I was really happy that you only typed karma start, and you never typed karma end. I was a little worried if that was going to happen because.
Well, yeah. I do Control-C.
Okay, I'm trying to wake everyone up here. Okay. Okay, with that, we can take a live question if someone has a live question, or we can go to the Dory, or we can move ahead. Okay, I got a question here, the number one question. You probably saw this actually in the UI too. It says, why was Karma renamed from Testacular?
Okay, I didn't expect that question at all. I don't think I want to answer this question on the stage. But the good thing is that now typing Karma is way faster than Testacular, because it's especially if you are using regular keyboard layout, it's like really easy to type. So.
Great. All right. Thank you, Vojta.
Actually,
thank you very much.
Can I think I would like to close this with a quick story. I think we have 2 minutes, so I can do that.
30 seconds.
30 seconds?
That's what you got.
I will do it quickly.
Okay.
Because I'm really happy about that thing. There's a project called YouTube on TV. It's basically, if you have PlayStation 3, there's a YouTube app, and it's written in Angular. And a few months ago, we were helping the team to debug some performance issues, and I noticed that they had like 90 or 100 unit tests, and I was like, wow, that's not that many. So I asked them, like, guys, why don't you write more tests? And when they showed me like how painful it was to like add a new test suite in their suite, and how slow it was to run these tests, I was like kind of like, okay, I understand that. And so the next week, I helped them to set up their environment with Karma, and we actually set it up to even run it on real PlayStation. And it was really cool because in like a few days, maybe a week, I got an email from Tyler, one guy from the team, and he was like, Vojta, this shit is awesome. Like, it completely changed our life. We test drive everything now. And believe me or not, but after the week or something, they had over 400 unit tests. So it basically took them about a year to write 100 tests, and then they wrote another 300 tests in just a few days. And the point is that you should spend time figuring out your workflow and your environment. Find the right tools for you. It doesn't have to be Karma. Like, I don't care. Use whatever works for you guys. But it's so much worth it to spend the time, because once you do it, it will save you tons of time. Cool.
So thank you. Thank you.
Thanks.
So next up here we have Patrick Hoogland, who is an avid drummer, which probably comes in quite handy when he's banging his head against this automated video quality measurement system. Yeah. So with that, Patrick.
Thank you. Thank you. Yep. All right, so I'm going to talk about automated video quality tests. That is a problem we ran into with the WebRTC project. So first, how many have heard about WebRTC before? That's a couple. Okay, well, for the rest of you then. WebRTC is a web standard that is being developed right now for video and voice chat built into the browser. So we are implementing this right now in Chrome, and also Firefox and Opera are implementing this web standard here. So WebRTC gives you the possibility to, in a web page with JavaScript, acquire a user's webcam and microphone, with their consent, of course, and send it over the net directly between the participants. So it uses peer-to-peer technology, and all that stuff is built into the standard, so it's real easy to write a video chat application that works regardless of NAT and firewalls and other things that can be in the way. Okay, so the Chrome implementation of this is done in Stockholm and Mountain View and in Kirkland, and I work in the Stockholm office with this project. So we wanted to test this, but to explain what we need to test, I'm going to explain briefly how a WebRTC call works. All right, so this diagram here, as you can see, is a very simplified description. So what happens here is that we can imagine we have two browsers on two different machines somewhere, and then it is up to the web page to implement that application part there that you can see. And implement a signaling solution. And the point of the signaling solution is to first figure out, like, who would you like to call with WebRTC, for instance, and that can be implemented like a contact list or random or whatever. And also the signaling solution exchanges the information that is needed to set up the call, for instance, what codecs do I support, and so on. We're gonna gloss over that part completely and instead focus on number 2, you can see it down there, which is media, when media starts flowing, okay? So given that we set up a call, how do we test it? So one of the goals we set out to do here was to set up a call and measure the video degradation, because obviously when we send video over the internet, we're going to have to compress it, right? And also in WebRTC, there's a ton of built-in algorithms for bandwidth estimation and like adapting the encoding parameters to how much bandwidth you have or how lossy your connection is. Or as I like to see it as a test engineer, a lot of things that can go wrong, a lot of things that can break. So we wanted to measure the video quality that comes out on the other end of the call. And we wanted those measurements to correspond to user perception as much as possible. And what do I mean by that? Well, basically, if a user would think it looks bad, it should get a low score, and if it's artifacts that the user doesn't really notice that much, it shouldn't affect the score too much. We wanted this thing to run continuously. We wanted it to be a reusable tool chain with small tools that have well-defined tasks as much as possible, so it's to make it reusable. And we wanted the implementation work to be a sort of self-contained unit so we can hand it off to an intern. And that is precisely what we did. We handed it off to our intern, Veli Spatsova from Bulgaria, and she implemented it, and it worked great. So that's why I'm here to share with you an overview of what goes into making a tool like this. So we're going to obviously gloss over a lot of details, but hopefully it will give you an idea what we need to do. OK, so when we started this thing, we already had a test which could launch a browser, open 2 tabs, launch a small C++ binary, which is a signaling solution, and have the 2 tabs set up a WebRTC call. So the output video gets fed into a regular video tag, HTML5 video tag. We had some fake webcam drivers on all major platforms, so that we could basically feed a known input video into the webcam and have it look like a webcam to WebRTC. And we also had implementations of the peak signal to noise ratio and structural similarity algorithms, and I'm not going to go into detail what those are, but supposedly together they give a pretty good picture of the video quality. All right, so then the first problem to solve was how do we record what goes into the what's coming out in the video tag on the other side. First, we considered screen scraping solutions where we scrape the pixels on the screen and that kind of thing, but fortunately we were able to avoid that because you would have to make a platform-specific implementation of that. And, you know. Instead, it turns out you can take a canvas tag and tell the canvas tag, hey, canvas tag, capture the pixels that are displaying in that video tag right now. Right? And then we hook that up to a JavaScript timer. that tries to capture at 30 FPS or as fast as it can, really. And then we run into some other problems, like we can't write the frames to disk from the JavaScript environment, so our intern wrote a Python server that we talk to using WebSockets, and then the Python server writes on the disk. It's a bit involved, I know. So after running this, that step, you end up basically with a couple of hundred of image files on the disk, and then we run a small tool to consolidate those into one YOV video, that is raw video. All right, but there are still some problems. Like, we have no idea where the video starts. Like, when we run the test, we don't know where we are starting in the input video because the driver is just going to loop it over and over, right? And since the algorithms I talked about earlier compare frame to frame and give you a score, you need to compare the right frame in the output video with the right frame in the input video. Otherwise, you're going to get the wrong score. And also, even if we solve that synchronization problem with the camera driver, what if we dropped the first 2 frames? Then we would compare frame n in the output video with frame n-2 in the input video, and our score would be very much punished for something a user would not notice. So that's not good. And also, if the JavaScript happens to not capture all the frames, because I sure don't know how to predict how fast JavaScript will run. So the trick is to encode barcodes into the input video, right? So you can see that barcode strip at the top there, it is going to move along with the video. And you see 3 examples of the video here because this is what our test looks like what's going in, what's coming out from the other side, and the canvas that is keeping up capturing the stuff there. So how will that help us? Well, it will make it able for us to encode a unique ID in each frame in the input video and then later find out which frame we actually capture on the other side. So the encoder uses, I'm going to go quickly through this detail. So the encoder uses a library called Zebra Crossing. It can generate barcodes for us. So we generate a bunch of barcodes in rising numbers, like 1 to whatever. Then we use FFmpeg to convert those to YOV, and then we combine the YOVs to a barcode movie. So that's just going to be a very narrow movie with a moving barcode in it. And then we can stitch that together with an input file of our choosing and create a video such as the one we saw over here. Yeah. So our setup ends up being feed that video into the fake webcam, have WebRTC acquire that webcam. Then we also test that our device acquisition code and all that stuff works for all the operating systems. We capture what we get on the receiving side with the video canvas thing I talked about, decode the barcodes, and then we analyze it. So the analysis step is the next slide that I'm going to talk about. First, the barcode decoder. So what does the barcode decoder do? So it takes the YOV movie we produced in the capturing step, splits that into a bunch of PNG files, because that is what Zebra Crossing understands, again, using FFmpeg, run it through Zebra Crossing, and then we get a bunch of numbers. So our tools is going to produce a file we call stats.txt, and that is a mapping for each frame in the output video, what is the corresponding frame in the input video. And that is used in the final analysis step here. So then we have this thing that takes the original video, the capture video, and that mapping, and then it is going to run PSNR and SSCM on each frame using the mapping from stats.txt. And what we end up with is something like this. Okay, so it's a bit hard to see here in the graph, but what you can see in the graph is that first those lines that you see there, that is the distribution of scores. So each frame is scored individually. And then the big thick line in the middle, that is the average for that particular run. So what you can also see, or maybe not, is that we are around 36 decibel peak signal to noise ratio, which I would say is reasonable for internet transmitted video. That big dip on the right there, by the way, is how a regression looks like. And when it goes back up again, that is where the regression was rolled back. And for the structural similarity, similarly, we get consistently, I think, about 0.96 out of 1 in score All right. So when we put the whole thing together, we end up with that. So as you can see, it's a fair amount of stuff in there. This is the parts I mentioned earlier. Like you have your input video that you just need to prepare and encode once, and then when you run your test continuously, you feed the same video into the webcam, and you run the tests, as in our case. And then you do the necessary conversions so that you get a YOV file and you decode the barcodes, and you end up with something you can analyze and produce a score from that. Right, so that concludes my talk. Thank you for my time. For your time.
Thank you, Patrick. So if you have a live question, you can go to the mics. I see somebody up there. And then we can also pull from the Dory. So why don't we go live first, please?
Hi. So a question about the output frames. Does it ever happen that you lose output frames because you couldn't decode the barcode? In other words, that the video quality is so low that you can't decode it?
Yeah, so it hasn't happened very much for us. When it has happened, it has been because WebRTC has been completely broken and it's just rendering black or garbage or whatever. So if the image gets so distorted that not even the barcode library can decode the barcodes, then the image is probably completely broken. So that is the conclusion you can draw from that, really.
Thanks.
Yeah.
Okay. All right, let's pull one from the moderator here. Do you test AV sync issues? If yes, how do you do it?
No, we don't, but so I guess that answers that question. No, but I mean, that is obviously maybe something you can extend the test to. And by the way, that is a tip for all of you here, that all this code that we have written for this is open source and checked into the Chrome repository. So if you want to use it, knock yourself out. So if you want to write something like that, you can probably do it.
Very cool. All right, let's take another one here. Are you able to measure the video quality while streaming at various network conditions?
No, but we would love to be able to do that. I mean, presumably when you have a lot of packet loss or bursty packet loss or a lot of delay or whatever, you would expect the bandwidth estimation algorithms to adjust accordingly. And then you should see probably that, okay, 2% packet loss, well, then we get maybe 34 in PSNR or whatever, and then you can keep your stuff working for all customers. And I think this is something people don't do enough of, verifying that, okay, it looks great on Google's Office network, but it will not work in an ADSL line in India, for instance. So we have plans for that.
Very interesting. We have time for one more live question. I think you got up here first. Is that, or did you toss up? Okay, left. Please, what's your name? Where do you work, and your question?
I'm Narendra. I'm from Amazon. So the question I had was like, why barcodes? You might as well have written numbers in there.
Yeah, absolutely. Well, we had a library for it, like I said, Zebra Cross, and I think barcodes are relatively resistant to normal artifacts when you encode and decode a video. So, I mean, we don't want that to be flaky, and it has turned out to work very well. Yeah.
If they had used numbers, and they would have had to call it Cookie Monster instead of Zebra. So, okay, all right. Thank you, Ken. Or Patrick. Thank you. Thank you, Patrick.
Thank you.
Got ahead of myself. Actually, next up is going to be Manal Mishra from Netflix, and he's going to talk about when bad things happen to good applications. Great.
Thank you. Good afternoon, everyone. I hope you can hear me all right. I'm Manal, and I manage a few of the key platforms in Netflix. To start off, did everybody know that yesterday was Earth Day? So happy Earth Day to everyone. I'm going to use Earth science to kind of introduce my topic. So let's start with what makes Earth a successful life system. One of the most widely accepted theories of plate tectonics. Plate tectonics, for the uninitiated, is basically large-scale movements in the Earth's lithosphere. It is not limited to just the formation of mountain ranges and ocean trenches. but it also postulates that it is very essential for life to succeed on Earth. Some of the tasks that are accomplished by tectonics are replenishment of depleted nutrients, generation of magnetic field, which prevent the violent solar winds from affecting Earth, and stabilizing the temperature of the planet by recycling carbon dioxide. So, what is the similarity between a successful life system and a successful software application? A successful software application needs to adapt and constantly innovate depending on market demand. This means that there is constant change in every layer of the stack. And haven't we all seen that? With the success of the mobile platforms, we know that these platforms need to constantly and rapidly innovate. But with every coin has a flip side. So does this churn. In the case of life-supporting plate tectonics, we have seen catastrophic side effects like volcanoes, landslide, earthquakes, and while we have come to accept these side effects, we have also made tremendous progress in the technologies that are used to determine and track these events with high grade of accuracy. Thankfully, we in the software industry don't have to deal with anything of that magnitude. But software development, the dynamics, go hand in hand with its own side effects that we refer to as bugs. And we have gone and developed a lot of systems that help catch these bugs sooner than later. I'm going to talk about one such system that at Netflix has helped us catch these bugs, which is our endurance system. And I will basically also explain, discuss some case studies which will help me illustrate how bad things that are out of your control can affect a good application. So let's start with what is the motivation behind endurance tests for a consumer application. The user expectation, right? We all as users have began to use mobile applications rather than website because of the magical experience offered by it with greater performance. The performance of application, again, varies from platform to platform and also on the application architecture. We also face unpredictable user behavior where a user behavior might invoke code path that might affect the performance of the application. And finally, for a media application like Netflix, where users spend at least 30 minutes, right? We don't have TV shows which are shorter than that. A simple memory leak can lead to suboptimal experience for our consumers. So, like every other automation team, we went ahead and built a functional automation system. The architecture that you see here is very similar to a lot of the client automation architecture that are available today. However, we built a custom in-house solution basically which could scale to multiple different platforms that our application is available on, and also build reusable parts. So certain platforms use certain parts, but overall, this is the architecture of one such platform using those reusable parts. And of course, with the continuous integration mantra, we put our functional tests behind the continuous integration system on Jenkins. The thing with the custom solution was that it was modular enough that we could basically develop endurance tests on top of the system with minimal effort. And then with the power of Google Spreadsheet, we were able to build a reliable endurance reporting system. obviously, we are a client automation team. We don't want to deal too much with databases, server, and the cloud. So why not use Google Spreadsheet? So what do we measure? We basically split our performance counters into 3 parts. Platform specific, which is memory utilization of the platform itself, CPU utilization metrics that is provided by platform. The second being video playback statistics, where we measure things like the playing video bitrate and audio bitrate, which is again dependent on network conditions and the hardware itself that you're playing back on. The frames rendered, dropped, the buffer size, which is important, and rebuffer counts, which is really important from consumer perspective since it determines the quality of experience. The third piece is, of course, the application metrics, where we measure startup times for the application. In order to give a good consumer experience, you need to have faster startup times. And we also measure certain transition times between pages as the users navigate through them. So CI for endurance. You can see the image right there, which is pulled from the performance metrics that you normally receive from a car. Like a lot of people in the Bay Area where I live, I also drive a hybrid car. And what I've realized is the continuous feedback on my driving performance has helped me become a better driver. So we took this idea and we put it for our application to continuously measure the performance of our application. This also ensured that performance is treated as a feature and not as an afterthought. And for the test team's benefit, we could ensure that our endurance tests are current. But you know what they say about old habits, they die hard. I realized that when I came back from a long vacation and I began driving my car, I easily slipped back into the old bad habits. And I felt that having looked at my performance trend over a period of time, I could easily correlate the mistakes that I was making with the trends and be easily able to remember them. So we decided to build trend charts on top of our continuous integration for the endurance test, where we use simple statistical functions to kind of track progression over build for the different performance counters. And we looked out for the statistical outliers. Using this system, we were able to find several bugs that were introduced by our developers. But to justify the title of this talk, I'm going to talk about 2 such case studies where we found issues using this system that were not introduced by our developers. The first one, last year, Netflix realized that the API service that delivers data to hundreds of different devices needed to be re-architected. The main reason behind that was the fact that one-size-fits-all model could not work with low-power devices. So what the direction that we moved to was giving the control to the devices to be able to tweak the response so that you get just enough response data to render a rich UI for your platform. As I mentioned before, we were tracking the startup times on our platform over different builds. And this chart over here basically shows you the different startup times to the different experience that you might launch into. One is the regular experience, and the other is the kids experience. What we realized is after a point, once we switched to the new version of the API, the startup time to the kids browse screen increased by about 25%. And we were able to look at this build and immediately notify our partner team. And over a period of time, we were able to fix it before it actually affected our end consumers. The next example is even more scary because we got notified of this issue 3 days before our release. This was a release that we were scheduled in December when we were releasing a ton of promotional features for our new original series, House of Cards. It's a great show if you haven't seen it. The other thing that we also do is, like I showed in the application stack itself, like we are dealing with bleeding edge services, we also deal with the bleeding edge ADK from our partners. So like a good consumer of the platform ADK, we were the first one to take the ADK version. The top graph basically shows you the application memory that is provided by the counters in our application. And it kind of remained consistent over the last 6 months. You can see it's kind of remained flat in terms of how much memory it's utilizing. The bottom chart shows you the available native memory, which is the memory provided, which is the counter provided by the system, which tells us how much memory is remaining. And you can see as we switched to the new version of the ADK, you can see the mountain ranges out there where there were times when memory hit rock bottom, and there were times when it remained constant. But while testing this, we found a functional bug which was more worrisome, where the playback would crash every time you change the audio stream, which is a big deal for our customers. And we realized we were able to track this bug back to the ADK. So we reverted back to the previous version of the ADK, notified our partner, and went ahead with our business. 3 days before the release, the partner comes back to us and tells us that the bug has been fixed, and you can go and adopt it. So we said, OK, we'll test it out. Everything worked fine. Functionally, the application looked really good. But what you see out here is that the native memory consistently hit rock bottom. So these are tests. Endurance tests are tests which run for 2 hours over our platform. And most of our functional tests gets done within 30 minutes. So the memory leak over here manifests itself after 1 hour of video playback. And as a Netflix consumer, there are no movies which are less than 1 hour long, right? So we were able to track this down to an ADK bug. Again, we reverted back and shipped the version in time. The key takeaway that we have over here is basically any form of test that you're developing, whether it be functional, integration, or performance test, make sure you're consistently running it and analyze the result that you get out of these tests. With these thoughts, I would like to end the talk with a quote from Robert Allen, which has a bigger meaning in life, but I think it's still appropriate for the test community. Thank you.
Great, thank you, Vinal. Yeah, that's an old adage. If nothing's running, it doesn't use any memory. So that's a good learning.
Yeah.
I think we have time for one question. I don't see any live questions just yet. We'll wait for the Dory. If there's a good Dory question, I'll pick it. Otherwise, we're going to go into a break right after this until 3:45. And then we have 2 very interesting talks, one from academia and one talk that has influenced many of the others here. So let me see this Dory question, or this moderator question here. It says, do you include any testing parts into your product delivered to end users? What statistics do you get from the apps on end users' devices, and how do you deal with it, with that huge, I suppose, amount of it? And if the lawyers are not here, it's OK if you don't answer that.
Yeah, basically, we do a lot of end user testing. We do instrument our client applications with a lot of information that gets logged into our service. We have a huge cloud-based system which basically collects all this data, and we basically process this data in a distributed cloud platform to kind of get an analysis of what our users are going through. Because it's very hard for you to test all the cases, and the best way to test it is by testing it in production.
Great. And with that, thank you. We'll be back in seat at 3:45. So I will see you then. Thank you. Hello. Hello and welcome back. We have two more talks today, very fascinating talks that are coming up. We have this first talk is from academia. We have a couple of talks from academia here. This next speaker is Tao Xie, and he is from North Carolina State University, and we'll be talking about testing for educational gaming and educational gaming for testing. And one nice little fact is he is actually a UW alumnus, so he is a dog, D-A-W-G. So with that, thank you.
Yeah. Thank you, Tony. Good afternoon. Next, I'm going to talk to you about some recent work in collaboration with Microsoft Research, including Nikolai Tillman, Jonathan de Horlex, along with Judith Bishop. The theme would be about the synergy of testing and educational gaming. On the testing side, I will talk to you about the dynamic symbolic executions incorporated in a tool called PAX from Microsoft Research, along with parameters unit testing as a way for you to incorporate behavior checking for your testing. And then with this foundation of technology, we have this gaming as a pick for fun, as a way for you to teach students or teach yourself about different kind of skills, including software testing skills. In the rest of the talk, I will basically give you the background first on the testing, and then we'll move on to educational gaming. Particularly, I will give the background, and then I will give you a little bit brief introduction of writing code in the browser, in your like a favorite browser of your choice. And then I will talk about the gaming type coding tools in the Pick for Fun website, and further discuss how we could leverage such gaming type in educational setting, including teaching and learning, and then conclude the talk. Here's a screen snapshot of the tool, PAX, released by Microsoft Research. It's a publicly available tool. The URL is near the bottom of the slide. Basically, it's a plugin for Visual Studio. Currently, it supports different kind of a .NET language, including C#, Visual Basic, and F#. Here, basically, it's very easy for you to use and install the plugin, and then you could just several mouse clicks for you to generate a set of test inputs as displayed near the button of the Visual Studio windows. Let me give you a little brief overview of the key technology called dynamic symbol execution in PAX, how we could generate test data automatically to achieve high code coverage. On the slides, I have this very simple piece of code as a code under test. As you can see, the inputs would be an integer array. And then inside, we have three conditionals. The first one checking whether the array is a non-pointer, and then the second one checking whether the length is greater than 0. And then the third one is checking whether the first element is equal to a very big number. In that case, we will throw an exception to indicate a potential bug in that particular co-location. Dynamic symbol execution was proposed back in 2005, and these days have been incorporated in different kind of testing tools, including security testing tools, along with PAX. Dynamic symbol execution would start with a default input for the argument, or arbitrarily selected or randomly selected input value. For this case, we could just use a default value as a non-pointer for the integer array. We execute the program being instrumented with additional code to collect runtime information, particularly which path this test execution would traverse, and what constraints on the inputs we need to satisfy in order to traverse that particular path. As we could see, if we execute non-pointer, we would traverse the true branch of the first conditional. At the same time, we collect the constraints required as a path condition as a equal to non-pointer after we finish the execution. Next, we want to generate new test data, right? Because we want to excise different behaviors of the code. How to do that? We pick the already collected path condition and negate part of it. In this case, it's simple because we have only one constraint. We negate it, we have A not equal to non-pointer. We fit this new constraint to a constraint solver or a theorem prover. the constraint solver will give us an input, concrete input value that will satisfy this particular constraint. For this case, it's easy. We could see we just need an empty array to satisfy the constraint. The array is not null. Then we further execute the program with this new input data. Further, we could see now we reach the second condition now. And we take the fourth branch because a.length now is equal to 0, not greater than 0. Similarly, in the next iteration, we negate part of the constraint. In this case, a.length greater than 0. We fit the new constraint to a constraint solver. We get the new concrete input as one array with only one element. That element is equal to 0. Okay? With this new input, we further go through the process we have. In this particular case, we now reach the last condition now. But the first element of the array is not equal to the bit number, it's equal to 0. So we next would negate the last constraints of the past condition. Finally, we fit to the constraint to the constraint solver. We get this big number in order to trigger the exception throwing statement. For this particular simple example, we are done because we actually explored all the paths in this simple program. In reality, many real-world application or software under test wouldn't be that simple. We may have an infinite number of the paths, or at least a huge number of the paths in the code. We need to have some advanced technologies, including those incorporated in PACS, to deal with those complicated situations. In this talk, I'm not going to go into the details about these technologies, but the basic idea of dynamic simple execution is exactly what I described. So far, we focus on crashing or exception throwing situations, right, in the previous example. We know if you want to assure high quality assurance in terms of a functional correctness, only catching these crashing or robustness issues may not be enough. We need to go one step further to write down some strong enough assertions in order to catch these like a functional correctness bugs. To do that, we could leverage parameter unit testing, which is a methodology to help you to engage developers and test generation tool to work together in order to exploit the best out of this test automation. In contrast, conventional unit tests, which do not have parameters, right? When you write unit tests, you don't have parameters. You just write some test method and then you execute the body of the test methods. But in parameter unit testing, a unit test has parameters, like the one I put on the side. As you could see, here, we have two parameters, list and an integer item. The body of this unit test is testing adding an element into a list to see whether the count of the list has been increased by 1. Very simple behavior. How to do that? How to check the behavior? Next, we would put several lines of code, very similar to what you have been doing in traditional unit tests. Basically, you write down the method call that you want to test, and then you write down the assertions that you want to check the behavior. Keep in mind here, the assertions you are putting here need to be general enough to deal with all different kind of argument value coming in. Not just a hard-coded like 10 or 20 or push one element to an empty list, that kind of specific situations. To allow you to write these kind of like general properties as assertions, we have some specific kind of construct called assumptions, which may not exist in conventional unit tests. Basically, you could constrain, in this case, list not equal to non-pointer. Otherwise, as you could see, we would throw exceptions in the body of the unit test. As you could see, for this kind of like a parameter unit test, we basically separate two constraints, two concerns more precisely. First, we want developers to write down what you really want to check, the behavior checking as the sequence of the method calls along with the assertions. Then we allow test generation tools like PACS to generate high quality test data to excise different portions of the code, if possible, violating the assertions that you put down there. So it's a nice way of separating the concerns of these two parts, one being done by human, the other being done by test automation. Okay? Actually, primary unit testing or primary unit tests have been supported by quite different testing frameworks, like including different kind of .NET testing frameworks along with JUnit 4 or beyond for the Java unit testing. The primary unit testing would be fully exploited in terms of the power in practice when you are using primary unit testing in combination with test generation tools like PEX. Okay? For the .NET programs, we have PEX, I mentioned it already. For the Java unit testing, we have some tools such as Agita 1 for allowing you to use test generation for primary unit tests written by developers. So far, so good. Like today, we already listened to quite some talks engaging so many different kind of testing tools, including the one that I just described, PEX. But after the talks, or like in our typical scenario, when we get tutorials at industry context or academic settings, I mean, quite some audience may not have the exact tools installed on their laptop. After the talk, after tutorials, they may not actually spend the effort to install the tool and try out the tool. So that's an issue we have been observing. It's like without actually seeing how things are, what kind of benefit you would get, they may not bother to install different kind of tools in their environment. So that's an issue that we commonly observed in terms of tool adoption. My collaborators at Microsoft Research have the similar observation to how to deal with that. They basically put the tool online, not just like putting the tool online for downloading, actually making the tool usable within a browser. So that's how the Pack for Fun website would come into place. Actually, if you have mobile device or laptop or your desktop, you could actually enter the URL, packforfun.com, try things out to get the sense of what benefits you could get with the power of test generation underlying PEX. Here's a website, the screen snapshot. As you could see, in the middle, you could enter the source code that you want to test under a particular name like puzzle with certain parameters. You could view that piece of code as a parameter unit test. Okay? Then you just click the button near the middle left-hand side, ask PEX. Then PEX would generate test data and send back the test data to the browser being displayed to you near the button of the web page. Okay? So that's a basic functionality of this website. It could allow you to quickly get a sense of what this tool could do for you. I think that kind of experience would be, could be borrowed by many other tool vendors or other tools in terms of giving people some quick overview of what their tools could do for them. But indeed, like there have to be some limitation on the browser version of the tool. For example, the total length of the code and the test might not be too long. You only have one file being copy-paste in that browser text box for the code and the test, single-threaded, no environment interaction, such as you cannot use file I/O, network communication, that kind of things in the code and the test. No non-deterministic behavior. You would try to avoid floating point computation, which cannot be handled well by existing conjoint solver. We also impose this 20 seconds exploration time for test generation when you click the button as PEX. But some of these issues are just specific to the browser version, not to the Visual Studio plugin version. In summary, so far I discussed the dynamic symbol execution, how it works, and how PEX could be used, and how PEX could be migrated to the browser version so that many people just open up their browser and then get a sense of what it could do for you. Okay. In order to make this browser version really usable, to have similar user experiences as they were doing within their typical IDE, for example, Visual Studio, my collaborators at Microsoft Research put a lot of efforts in creating these nice features such as auto code completion. When you just type in, for example, console.w, it would pump up some, suggestions for the methods that you want to put in along with the description of these API methods. Very nice features, just like allow you to feel the similar experiences as in the normal, typical IDE. So basically, for this kind of a browser version of the tool, you could leverage the cloud to do the computation, do the test generation, and you use the browser as the front end for the user to enter the code that would like to test, and then also use the browser to display the test data being generated back to the users. So far, so good. We have PEX, and we have the dynamic signal execution incorporated in PEX. My collaborator at Microsoft Research put this PEX for Fun website so that you could play with it. But think about it. Unless you are really like a geek, otherwise you wouldn't come back to this website like, oh, every now and then you just type in some code and click the button, say, oh, how fun it is, right? You generate strong fall detection capability, like in terms of test data, and then you play it again and again. I think few people would do that, right? Then we think about like how we could leverage this website and the test generation engine to do something more fun and more useful in our work and life. Okay? That's how the coding tools come into the picture as a major game type for PEX for Fun website. So far, for the coding tools game types, particularly for the Ask PEX button, basically you click one time of Ask PEX button that will indicate one iteration of game playing. Okay. About 1 month ago, we had more than 1.1 million of the clicking the button. Okay, so many people around the world are like using this website to do like a different kind of thing, like for learning, particularly for learning, while having some fun, or being used in classroom setting. Let me give you some idea on what a coding tool would be like. The idea is very simple. For a game creator like myself, or actually anyone around the world, you could create a secret implementation on the right-hand side. Okay? Basically, you write a very simple piece of code, and then you also release of the secret implementation. Then the players would need to complete or finish the player implementation so that the player implementation would have the exact same behavior as the secret implementation. Okay? You would say, I cannot see the secret implementation. How could I type in the code to make the behavior the same as the underlying secret implementation? Right? It's mission impossible. Okay? That's how Ask PEX or PEX come into the picture. Okay? PEX would give you feedback to tell you under what inputs you have the same behavior between these two versions. Under what inputs you have different behaviors. Okay? In addition, PEX would be the judge to determine whether these two implementations have the same behavior or not. Okay? Let me use an example to walk you through. On the left-hand side, I already create like a secret implementation, very simple one, recursion function. And on the right-hand side, I release to the player with the player implementation, basically the empty one. You just return X. Okay? Then when the player tries to play this game, first the player would click the button Ask PEX because without any hint, the player has no clues on what direction the player needs to modify the code. Then after the player clicks the button Ask PEX, behind the scene, we actually have this test driver being synthesized. It's more like a primary unit test, right? You have the input argument the same as the signature of the two implementations, but we construct a new branch there saying that if the return value of the secret implementation is not equal to the value of the player implementation, we throw an exception. Okay. As you can see, dynamic signal execution would try to cover all feasible paths, of course, all feasible branches. And if possible, PEX or dynamic signal execution would fire test input to cover that branch. What does it mean? if you could cover that branch, it means that you have at least one test input to cause the behaviors of the two implementations to be different, okay? So that you have a failing test. So in reality, if you click the button for these two implementations, you will see the table displaying 2 passing tests and 1 failing test. Basically, we are saying that if your argument value is 1, then return value is 1 for both implementations. 2, similar thing, return value will be 2 for both implementations. But if you have input value as 3, the second implementation will return 6 instead of 3, which would be returned by the player implementation. Okay? So as you could see, as a player, when you see this kind of a feedback, you try to modify, you try to do some generalization, abstraction, reflect on how would you modify the code implementation so that you could satisfy the constraint of the 3 test inputs. Basically, making the passing test still pass, but making the failing test also pass. Okay. We use this kind of a gaming with some middle school students. We see very interesting behavior there. They may just focus their energy on the failing test without thinking about making the first 2 passing tests also pass. Okay. More like overfitting the constraint solving in their mind. So to summarize these coding do's, basically we provide this kind of fun and engaging experiences by allowing the user, the player, to have this iterative game playing over time by clicking, asking packs over time when they change the player implementations based on the feedback. The feedback is adapted and personalized. Like you play the same game, you may write down different player implementation, make different revisions. Then the feedback you are getting would be different, because dynamic sim execution or PAX would leverage both the player implementation and the SQL implementation to generate specific tests to show the differences or the commonalities of the behavior. It's very difficult to do cheating. Okay, like you may say, oh, because earlier I mentioned that floating point computation would not be good for constraint solver. Let's just put a bunch of floating point computation there to full PAX or full dynamic sim execution. That wouldn't work well. Okay, it's very difficult to defeat that. In theory, you could, but in practice, very difficult to cheat. We have very clear winning criterion. Basically, as long as PAX cannot generate like failing tests, then you win the game. Okay. We had quite some users posting their feedback and their experiences online. I just read through some of the interesting ones. Like I used to love the first-person shooters, and the satisfaction of blowing away a whole team of newbies playing Rainbow Six. But this is far more fun. Okay, the user was referring to PAX for fun, like playing PAX for fun. The second one, apparently, as you could guess, the second one is a professional rather than a student. Like, I'm afraid I have to constrain myself to spend just an hour or so a day on this really exciting stuff, as I'm really stuck with work, okay? We don't want to impact your normal workload there, but on the side, it's good to have some kind of entertaining, while learning, yourself. The third one is talking about the learning and teaching aspect. Like, it really got me excited. The part that got me most is about spreading interest in teaching computer science. I do think that it's really great for teaching and learning. Okay? We had many more different kind of very positive feedback from the users. Recently, 2 years ago, we had this coding do competition at our major software engineering conference, International Conference on Software Engineering 2011. We provided these 30 coding do's for the conference attendees, including students and researchers. As you could see, I zoom in there with one of the coding do is number 10. Basically, the green entries will indicate that user actually solved the coding do, win the coding do. For the red ones will indicate the user makes an attempt but fail. Okay. The number there indicated how many attempts the user made, basically how many times the user clicked that aspect before they actually finally got it for the green one, or the red one, in the end, they still couldn't win the game. Okay. it's very interesting to see for this particular coding tool, it's not that trivial. As you could see, we had one like a user solving again 4 times. That's very good, right? 4 times actually got it. But we could see we even had 147 times and finally got it, right? You could reflect that user is really patient, right? All determined. It's up to you to judge whether you want to hire this person to be your tester or not, right? So you could have different interpretations on that. But as later I will describe more, another very interesting for you to see is that as a teacher who would create this kind of a game for students to try, teacher could actually see every single step the user actually try. For this particular case, we should actually go inside to see for that user with 147, what on earth did this user finally got it, right? Like, what's the turning point? Like, why do you need so many times? Or for the 4th one, like, what exactly the magic happened? Like 4 times you got it, right? It's very interesting to see the process besides just seeing the end result. So to summarize what we talk about coding tools, basically it's given a particular SQL implementation and an empty or incomplete player implementation, we ask users to try to improve the player implementation so that the behavior would match the SQL implementation one. The students need to infer the intended behavior of the SQL implementation that they couldn't see, and then they would iteratively try to generalize that behavior to the code implementation that they are working on. We also have this kind of a social experience to make it more fun and engaging. We had this live feed being on the website. You could see like at this particular moment, who are solving what? Are they successful or are they failing, still try very hard? It would be fun to watch if you don't have much things, many useful tasks at hand, right? Especially when you create some coding tools, you just see, oh, who are solving my tools, right? That's kind of like an interesting live feeds there. We also have this rank list for different users. A user could gain some points by creating coding tools for other people to play. Also gain some points by solving successfully solving certain coding tools. Okay, we have this kind of a rank list of people around the world. Being on this website. We have the leaderboard and along with other nice features for social experiences. We would like to take advantage of these platforms so that we could really gain much in terms of the teaching and learning, rather than just say, oh, we put it there so that anyone who would like to try it out, just try it out, right? To do that, basically, we provide different kind of features. For example, as a teacher, we could create a course by assembling different web pages. Like the course page, we already have different materials on different topics, testing, along with different programming topics. Here is a screen snapshot there. Basically, for the teacher, this is like sample course. We could see that on the right-hand side, we have this kind of like a dashboard of showing the students' progress of solving some exercises in the form of coding tools. And in the real time, the teachers could look into like what kind of problem they are facing. Are they struggling on a particular thing? Or maybe the exercises are not that clear in terms of giving students some requirements. We used coding tools in a graduate software engineering course. Typically, you would think, oh, like this kind of a nice games could be used in intro programming course. Indeed, that would be the case. For example, if you are teaching loop, you could just take certain piece of the loop head out and then ask students to fill in that particular, for example, the upper bound of the loop, this kind of thing. Okay, but at the same time, we actually tried it out at graduate software engineering course in terms of teaching them specification writing, requirements, testing, design patterns, many different kind of topics. Here's just a screen snapshot of a particular exercise that we prepared for training students specification writing. As you know, in testing, in order to write very strong test oracles, you need to write strong properties, right? For the topic of parameter unit testing, to write that unit test with parameters, you need to have strong assertions or properties to really check the behavior that you want to check. So this exercise actually have some natural language descriptions of some properties of a particular API method. And then we ask students to actually translate these natural language descriptions into some formally checkable properties. Okay, so in this particular exercise, as you can see, students may not have much space for guessing because you exactly solving the given exercise. But the nice things about it is that you actually get automatic grading. Okay, both the instructors and the TAs are very happy, right? Because in the end, you just look at, like failing, how many failing, how many passing in terms of green entries and the red entries, you just calculate the scores, right? Rather than really go inside to grade them with tiny details. Here is just one example of how we use coding tools for teaching testing. The code and the test actually is a stack, it's a bounded stack. We create this coding tool by passing in some parameters like the elements, array element capacity, that's the upper bound for the stack, and the element, which could be the element you want to push into the stack, or you want to check whether the stack has this element. But we don't know, we don't tell you exactly how we are going to use that. But the first 2 lines are basically talking about the assumptions we put in. Okay? And then we have the next 4 lines describing the setup of that stack. Okay? Basically, we just put these array elements into a stack so that you could you could allow the test generation tool to generate particular state for you in this particular setting. And then in the end, we put down the assertions we really want the code and the test to be checked. Okay? But we keep the middle empty. As you can imagine, the middle part, the empty part that needs to be filled would be about what method and the test you want to invoke on the stack. In addition, you may also need to add some assumptions to really make sure that the assertion would be passed. Okay? So if you have interest, you could go to the URL to try it out yourself to see the different kind of exercises. How to use Spec for Fun? I already demonstrated some scenarios. As we all know, MOOC has been very popular, massive open online courses. There are at least 2 major challenges there to make things work in MOOCs. First, grading, right? If you have thousands or even millions of students, you cannot afford hiring TAs to grade these student submissions, right? Because typically they are free, okay? In terms of the course. Then here, if you use Spec for Fun, you could create exercises and get in this automatic grading for free as a nice feature on the side. Okay. But indeed, it's an open challenge in terms of like addressing cheating. Right? If like one student just copy paste another student's solution, they're working on the same do. I mean, we really don't have certain control in terms of that. It's an open challenge for many different technologies. It can be used for course assignment in regular course teaching setting, both academic settings or industry setting for training. Okay, we have done that in terms of like the topics from intro to programming or software engineering, including testing topics. We actually could have these competitions, including student competition, professional competition. We have this experience at XC 2011. And finally, as I hinted on earlier, it would be very interesting for you to actually observe one particular player or user's problem-solving process, right? You, as a recruiter or a company's employees, you want to hire some potential employees. You want to see how they are doing, but basically you could create some well-designed coding tools for them to solve. Not only seeing how many attempts they are making, you see the problem-solving process. They kind of simulate what you typically would do using the whiteboard to see how a particular person would do on solving some problem. So it could be used in that way for you to really assess people and improve people. Like, for example, your children, like you want to see how they are doing on programming, on particular problem solving. Okay. So to summarize what we discussed in teaching and learning, basically, if you want to become a teacher to really create a course for students or like employees or friends to play with and see in their problem-solving process, you could sign in with Microsoft account, like a Hotmail account, etc. And then you pick a nickname and send us the nickname, and then we could enable you with a teacher role. And you could, as a teacher, you could create courses. You could monitor the progress of students' problem-solving processes. You could interact with them in different ways. Okay. So in the future, there's a lot of exciting things ahead, like how to provide tutoring support for students if they are facing some difficulties, right? As you will see, the 147 user, trying 147 times. Typically, students would get frustrated after they try a number of times. For this case, we shouldn't just say, oh, you keep trying or you fail, right? We may have some hints on the side, like in the real-world setting, okay? And how to detect plagiarism, I mentioned that already, it's an open problem. For the ranking, so far we use passing or not, right? Whether you have behavioral differences or not. But we really want to have other criteria like co-quality and other kind of a criterion for us to take into account in terms of providing better grading. Support other language generally. More detail in this upcoming paper is available from my homepage. And in conclusion, I talk about two different kind of technologies, but they are correlated to each other, supporting each other, dynamic symbol execution along with PACS and primary unit testing, and PAC for Fun as an educational platform. To conclude that, my email address is there. We welcome collaborations on this exciting period. I would say in 40 or 50 years, you may retire, right? Educating the next generation to do a better job than us, or at least as good as us, is very important. I think that besides just doing test automation, it's a good opportunity for to think about how to make education and learning more fun and more valuable for the next generation. Okay, thank you.
Great, thank you, Tao. Very fascinating. So I had forgotten earlier, I had a few things up here. So for some live questions, I was going to throw this out to a live question. We'll determine the best one here. So this is a little Android-y. So we have the Dory up. Let me go to the Dory, or the moderator here. It's not a door. So first question up says, how does a tool like PACS fit into the software lifecycle?
Okay, so PACS could be used like the other test generation tools, like you finish your code implementation and then you apply PACS to generate test data to exercise different portion of the code. In addition, it actually could fit in TDD, test-driven development. But in this situation, you write primary unit tests first without actually having your code implementation. But in this setting, keep in mind, primary unit test plus PACS would be very powerful to force you to write quite a lot of functionality when you try to pass the test. It's debatable whether there's a good thing or a bad thing in terms of philosophy or TDD, right? But it could allow you to spend more time on writing the code implementation rather than with very minor increments of adding new features.
Very interesting. There's one live question here, so we'll go ahead. Tell us who you are, where you're from, and then your question, please.
I'm Jessica Nickel. I live in New York City, and I work at TargetSpot. I was in education for 10 years before transitioning to QA testing, and I find this really exciting, and I'm just wondering if there are plans to develop a curriculum around this, so that way that teachers can be guided who may not be so technical, but who are interested in incorporating this into their classrooms.
Yes. Yes, actually, there are quite some materials already on the website for you to customize to use in your setting, including like intro programming, along with primary unit testing. We are still putting quite substantial efforts in getting more materials to cover different topics and customize to different levels. Yeah, and we also welcome collaboration in terms of this particular aspect, like developing more course materials so that more people could benefit from this course.
Yeah, great question, by the way. That was a good question in the first one up, so I'll set that there for you. Okay, I think we have one more live question, so please go ahead, who you are, where you're from, and your question, please.
Hi, my name is Mark, University of Malta. So I can see how symbolic execution is really good for generating a bunch of test cases which maximize your coverage. How does PEX handle the Oracle side of things? So once you've generated a test, how can you be sure that the system is behaving properly for that particular test?
Right. So that would fit in what I described as a primary unit test. Of course, you could just apply PEX like any other test generation tool. You don't write anything. You just rely on crashing or not, or throwing uncalled exception or not. That's already there, right? If you want to have higher confidence in terms of behavior that you are checking, you write this kind of a primary unit test with strong enough assertions so that it's not hard-coded for some constants, input value, but more general, okay? So you would get the benefit by additionally doing primary unit testing. Thank you.
Thanks for the question. So up here on the moderator, it says, PEX only identifies unit testing parameters, right? It will not handle functional or integration testing.
Okay. So basically, as you could see, PEX basically with the nicely specified interface, that's the test data the PEX would generate test. You could encode your integration test or functional test inside this primary unit test. But the next question is that could it scale well? That's another question we need to see like what kind of code you are dealing with, whether the code you are testing would have dependency with the environment, maybe you need to do environment isolation, etc., like do mocking, this kind of thing. So you may have to do a lot of these additional techniques typically you would do in your traditional unit testing. Yes.
Very interesting. And we have time for one more question. So is this a live question? We'll take it, please.
Hi, I'm Daniel Wagner-Hall. I'm a Googler. The parameterized testing assumptions and assertions reminded me quite a bit of code contracts, but also felt kind of like the opposite. Like rather than specifying within your code parameters, you're writing the test, which is meant to be kind of auto-verified. I was wondering if you could kind of contrast those approaches a bit.
Okay, very good question. So in code contract, like pre-post condition or design by contract, you write the pre-post condition in the production code, okay? So typically, people would write mostly preconditions, and very few people would write post condition. Why? Because it's very difficult to write post condition because it's very complicated to capture the behavior of that particular piece of code. If you write primary unit test, you also have assumption assertion. Notice here, the assertion there would be specific to the scenario that you constrain with the method sequences in the middle and assumptions that you put in, okay? So that you have a much easier time for you to specify the behavior. But indeed, code contract would have more applicable scope or testing different situations as long as you execute the piece of code. Primary unit test would be just applicable on the scenario that you specified there with whatever test data coming in. So I think that's a trade-off that we are making. The design by contract have been going on for quite a while, but we haven't seen enough practitioners take up in substantially. Hopefully, primary unit tests would allow people to actually get some benefit of these formal methods, but at the same time, they are still following their traditional practice of doing unit testing, writing unit tests. Okay.
Great.
Thank you.
Great. Thank you, Tao.
Great. Thank you.
Right. Thank you. So this next speaker up, I believe, has spoken at more GTACs than anybody else. He probably does not need an introduction, but I will do one. This is Simon Stewart from Facebook, and he is going to talk to us about how Facebook tests Facebook on Android. And so with that, I hand it off to you. Thank you.
Brilliant. Thank you very much for that introduction. Yes, I think I have spoken at more of these than anyone else. This is the one where I snatched the crown from James Whittaker. Sorry, James, if you're watching. Before I begin, I've been having a fantastic day today. The quality of the talks has been amazing. And the thing that I've really noticed has been just the awesome work the stenographers have been doing. Like, when I haven't been paying attention. And the signing down here is phenomenal. just blown away by how well organized this is. So well done, Google. Keep up the good work. Yeah, so how Facebook tests Facebook on Android. If I'd been thinking carefully when I named this presentation, what I would have done is I would have called it How Facebook Bakes Quality into Facebook on Android. Because we don't just test for the sake of testing, right? It isn't something that we sit there and go, you know what? I really fancy doing some pointless testing today. There's nothing I'd rather do. Actually, sometimes I do feel like that, but it's only when it's a really slow day. You know, why are we doing this testing? We're doing it to bake quality into our apps, right? We can't bolt quality onto an application at the very, very last minute. We can't bake security in at the very last minute either. We can't bake performance in at the last minute. These are things that we need to be thinking of all the way through the life cycle of the application. So, yes, how Facebook tests Facebook on Android. So let me take you back to 2012. It was a long, long time ago in a galaxy right here. The Facebook app on Android, it worked, right? It was kind of fun. And it also had really, really, really lousy user experience. You know, here's a quote from Mark here going, "We were never able to get the quality we wanted. Looking back, that's probably one of the biggest, if not the biggest mistake we made." And why was the performance of the application so appalling? Well, actually, it wasn't that bad. But what we were doing is a pattern that's fairly common in the world of mobile applications, and that's to use the web views extensively. Facebook was a web company. We like to be able to release software. We do it twice a day now. We push to our Lives website twice a day. That allows us to iterate on things really quickly. It allows us to make a series of chronic and awful and terrible mistakes, realize that we've done something and fix it the next day. The problem is that you can't do that on a mobile app, right? Someone downloads the app and then they're stuck with it. If you've got a bug in that application, they may never update again, which is a horrific place to be in. So we'd like to retain some flexibility, and the way we did that is we used web views. And the web views on Android and iOS are suboptimal, I think is the way to describe them. You know, there's a number of problems with them, not least of which is they're like no other browser out there, right? The Android one is based on the stock Google, Android browser, which is not Chrome, unless you're on Jelly Bean. And if you're on Jelly Bean, actually, the browser is Chrome and the web view is something completely different. The JavaScript engines tend to behave appallingly. They're very slow, they're tedious. And so what we were doing is we were making use of these web views to allow us to iterate more quickly, and it was just leading to a really poor experience for our users. So we had to stop, we reassessed. What we did is we decided we were going to make mobile a first-class experience. That went the wrong way. I could do the entire talk in reverse, by the way. Start on the final slide, begin with your questions, and then just make it up from there. Hands up if you'd like me to do that. There's one hand, 2 hands, brilliant. Next year, right? I'll be invited back for sure after this. So what we did is we decided we were going to take our engineers and we were going to train them up on mobile. And this graph here has the numbers removed, but there's a total of about 1,400 engineers at Facebook. Not all of them contribute to our mobile code base. But what happened is it was all going along fairly regularly, and then we went, what we need to do, we need to put mobile first. We took our PHP developers, we ran them through training courses, we educated them. We hired people in who were skilled at Android and mobile development, and that's the result. We had this massive uptick in the number of engineers committing code to our mobile code bases. That's a fantastic thing. We're now moving a lot faster. The important thing, though, is that it's engineers contributing to our mobile code base. There are no Android team. What I mean to say is there is no longer an Android team. We tried to do that. We tried to have a group of people who were responsible. We called them the core Android team. And they were going to be awesome, and they were going to somehow keep up with the flood of new features coming into the web. And that didn't work. So what we did is we took a step back, we reassessed again, and now what happens is each of the teams producing a feature, own that feature on every platform it's on. So if you own pictures, you own it on the web, the mobile web, iOS, Android. So that's far easier for people to keep things in sync, right? There's probably people on those teams who are specialized on Android or iOS, but there isn't a group of people who are responsible for desperately trying to ape features from the web in a mobile client. And that allows us to keep parity in place, right? And that means that users get a far better experience. If something appears on the web, chances are it will also appear on the mobile client relatively soon after that. We do have spoons, so there is no Android team. We do have spoons. So what's a developer's day like? Let's say you're on one of these feature teams, right? And you're going to do something. How do we bake quality into the application? I mean, it's done all the way through the process. So let's begin with how we build. That seems to be quite an important thing to do with software. You need to build it. So we use Git at the moment for source control. It's a DVCS, and so what we do is we have a central repo, and that seemed like a good idea. Everyone works on their local machine. There are two branches that we care about day to day. Google, I know, only have one, and that's because none of their tests failed because they got the pre-submit, and it's awesome. We haven't got the pre-submit, so people check in. So there are two branches that people care about. The first one is master. That represents not a villain from Doctor Who, but the most recent version. So you can see who enjoys British sci-fi here. It's the latest version of the code. So master has everything in it that has been committed to the code base so far. It's a linear history. What we also have is a moving tag called stable that represents the last time that we were sure that our unit tests were passing. So there's master and there's stable. You know, that's kind of fun. And all this code is checked out, for Android at least, in a single tree, with effectively 3 or 4 directories up at the top. Java, Java tests, because you never mix test and Java code. It's just not the thing that you do. Third-party libraries, we keep those out of the tree, and resources used for Android. Okay, got my drink of water here. Yes, so it's all one tree. That's kind of fun, because we've got more than one mobile app that we make for Android. Right, there's Instagram in there, there's a Facebook app, there's a Messenger app, there's a camera app. You know, if you download an app for Android from Facebook, it's all been built from that tree. I'll throw that all over my laptop later. So, yes, people know Murphy's Law. So what does it look like when you begin working on a feature? Well, what you do is you you're probably on the stable branch. You create a new branch for your fancy feature. Hackety hack, hackety hack, hackety hack. You git commit, and you create a new feature. While you've been working, there have been N other developers also checking in code. So periodically, you want to grab their work they're doing and rebase. So you're always working on the top of the tree. You go hackety hack, hackety hack, hackety hack. When you're ready, you commit, and then you do a rebase. So what we like to do is, while you're developing locally on a branch of your own, you can have as many branches as you want. You can have your commits all organized anywhere you want. But when we push it into master, we want a logical change to go into our code base. We don't want the individual steps you did. Now, there's a number of reasons for doing that. The first one, a logical change is a lot easier for other people to comprehend. If you want people to understand what you're doing, what you need to do is explain why you're doing it. It helps increase the quality of the code when someone comes and has a look at things. And second of all, if we need to yank your changes, it's a lot easier for us to do that if we can see the one logical change that went in rather than the intermediate steps, particularly if you're like me and you work on like 2 or 3 things at the same time. So we always just squash our commits before we run this command, arc-diff. So how do we write all this code? We use IntelliJ. It's Java, right? So there's 2 choices of IDE, Vi or, no, hang on, IntelliJ or Eclipse. both of them are perfectly reasonable choices, but the way that we've structured our code base means that IntelliJ is actually a really good fit for us. And from a massively biased point of view, I prefer it. And Facebook is small enough that actually, an individual choice and someone advocating can really make a difference there. So, you're using IntelliJ. You want to make sure the code is good. You want to make sure the code is testable. How do you make sure the code is testable? You use dependency injection. So when you're doing object-oriented software, OO software, you've got collaborators, right? The class that you're working on collaborates with a bunch of things. And there are two ways that it can get hold of its collaborators. The first way was popularized by J2EE back in the late 90s, early 2000s, and was service location. You had this big thing, and you went into it in the middle of your method, and you went, thing, give me a database connection. And thing would look at you and go, here's a database connection. And that would be fine. And then sort of, 2003, 2002, early 2000s, this dependency injection phrase started becoming more popular. And that was, the major difference with that is that rather than having the method go, thing, give me one of these, the method signature, or the class under test, somehow accepted its collaborators from the thing that created it. So there's constructor-based dependency injection, where all your collaborators are passed in at construction time. And there's also setter-based dependency injection. There's also magic-based dependency injection, where you annotate things and then Guava or Spring or whatever it is that you like suddenly populates fields that you have no idea how it did it, but it's done it somehow, right? Now, the advantage with dependency injection over service location is it makes your collaborators really, really obvious, right? It encourages you to think about who your class is collaborating with. I remember I was on one project, not at Facebook, and they were using service location, and I ripped out all the singletons, and I added every single thing they depended on to their constructor signature, and 14 arguments later, somebody went, that's a really big signature. It's like, yes, yes it is. Do you think we've got too many roles and responsibilities? I went, I don't know. We should probably slim that signature down somehow. It's like, yes, how are we going to do that? Thinking what we'll do is we'll split the class up and we'll have fewer responsibilities. And what they said to me is they went, we'll pass in a map. So yes, dependency injection, a really, really useful way of ensuring that your code is testable. It makes it really easy to swap out collaborators at test time, and that's vital. So, you've written your code in IntelliJ. That's nice. You've used dependency injection like a good developer should. You probably want to build your code. Now, we use a tool called Buck at Facebook for building our code. Why do we use a tool that nobody else in the world yet uses? There's a number of reasons for it. What we want is, we wanted a tool that had minimal overhead when we added a new library or module to the project. Our original Ant solution had a lot of boilerplate code. It had lots of sub-modules. If you've used Maven, the way that you would do a new module is probably you'd have a top-level library and then you'd have some sort of POM that would point to it, and who knows. We want to keep boilerplate out of our code base. Boilerplate is things that machines should do for us. But we also wanted the build tool to be friendly to the IDEs. We'd structured our code in a way that actually plays really nicely with IntelliJ, and we don't want to lose that. We want really, really fast, clean builds. But we want our incremental builds to be even faster. Because as Ari said, right at the beginning of the day, doing a clean is a bug in your build system. You should never, ever need to do that. So yes, we want faster incremental builds. And what we need to do is we, ahead of time, don't know all the things that people are going to try and build. So we want to support adding ad hoc build steps. So Buck, our build system. It has three really important concepts in the middle of it. The first is a build rule. Now that's a procedure for, you can all read, can't you? Yeah, okay. It's a procedure for producing output files from input files. So you list a series of sources and dependencies, and the build rule runs, and you get the output. You get one output. That's the invariant of the system. You can have at most one output from a build rule. A build file contains a series of these rules. And typically it's called buck in all capitals, which is great unless you're on a case-insensitive file system. So we declare all the rules in that. And if we want to have a dependency between two rules, we use a label to get to the build rule, and we call that a build target. Okay? So it's a string identifier for a build rule. This is what a target looks like. I like to read the / as from the root of the repository, so from the top level, there is a directory called javacom Facebook share. Excellent. : in which there is a buck file, UI, with a build rule called UI. So this gives us a completely declarative path to the thing that we're attempting to build, which is nice. By the way, if you've ever used the Selenium build system, it uses exactly the same syntax as that. It's called Crazy Fun. If you work for Twitter, Pants uses, I think, exactly the same syntax. Is that right? Yes, it is. Brilliant. Good. I think it's because there is a sort of diaspora of ex-Googlers who pine for the amazing build system that Ari talked about. So yeah, what does a build rule look like? It looks like that. This is how we build a library for Android. That called UI, so the one that we had before. We do a recursive glob over the directory structure underneath where this rule is declared. So it's not over the entire tree, it's just over the subtree beneath this. We have a series of dependencies which are declared there, and visibility. So by default, no one else can see a build rule outside of the build file you're declared in. So you can have dependencies within a build file, but if you step outside, you need to make it visible. You can either make it public, anyone can use this thing, or you can limit the visibility to certain subsets of rules. In order to make it nice and easy to have a library that you can depend on in the rest of your code without needing to be aware of how that library is structured, with the Java library, you can also export your dependencies. So you can say, look, if you depend on me, then transitively you get all my dependencies as well, which is a nice way of composing everything. Who knows Python? What language does that look like? It's a leading question. It's Ruby. No, hang on, it's Python. Our build file is Python. We interpret the build file using the Python interpreter. We're moving to Jython because, you know, it would be nice not to have to rely on Python being installed on the local system. But yes, so it's Python. And that allows us to do some really, really nice things. Like, if we're missing the ability to build a certain type of target, you know, if a build rule should exist to build, you know, iOS library, for example, we could add it to the system using a glob of rather unpleasant Python, and then just use an iOS library in the rest of our build rules. And then when we modify buck, we can fix it, and we can bake that into the platform, and it's kind of nice. So we've got this ability to modify the build system on the fly in a Turing-complete language and a completely declarative build system. I'm not sure how I feel about that, but it is awfully convenient. So what we do, you run your builds. We build a directed acyclic graph. I was really pleased when I started working on buck because it allowed me to use some of the computer science that I struggled through all the way through university, and use terms like directed acyclic graph with a straight face. And what we do is we analyze that graph and we build sub-parts of the tree in parallel. So we try and build everything as massively parallel as we can, right? And that enables our builds to be significantly faster. And then because we know that if the inputs to one of the previous steps haven't changed, the output won't have changed, we can skip building that step. We can just use the cached output. And that allows our incremental builds to be nice and fast. How does IntelliJ feel about us monkeying around on a file system like this? Apparently it likes it. We run a command called buck project. And what that will do is it will scan through the entire file system for buck files, and it will generate the IntelliJ configs. So what you do is you go, I haven't got an IntelliJ config buck project, point IntelliJ at it, and suddenly everything works out quite nicely. That will also set up some exports for build rules, for test runners and things like that. So that's nice. And it's fast, guys. This thing is quick. Because if you want people to write tests, if you want them to be using dependency injection, if you want them to be doing all these things that we want to encourage people to do, being slow doesn't help. Again, Ari's slide, the developer who was sleeping going, longer is better. Longer isn't better, shorter is better. Instant is best. Actually, if it could somehow leap forward in time and give you the results before you finish writing the code, that would be better still. But assuming we're constrained by the laws of physics, instant is best. So Buck, by default, spins up as many threads as it can, 1.25 times the number of cores on your machine, as reported by Java. So if you've got hyperthreading enabled on a modern laptop, that means you've got 10 parallel builders running. 4 physical cores, 8 with hyperthreading, times 1.25, 10. And we found that by doing this, we can slash our build times. Our build time, when we were running in single-threaded mode, used to take about, 20 minutes. And we ran things in parallel, and we dropped that down to 4 minutes. That's quite nice. It's an incremental system. So we only rebuild what's necessary. There are going to be some changes that we're going to make in the future. Like, at the moment, we need to scan the file system every time we do a build to figure out what's changed. If we demonized something to watch the file system, as in turned it into a daemon rather than just told it was bad all the time, we could go faster. And the other thing as well is, like, it would be nice to be able to do a distributed build, and if someone's built the thing you need with the same signature of the inputs, you should be able to get the same outputs. You shouldn't need to do a build. So in 2012, what happened was we flipped everyone from using Ant to using Buck. I'm just going to hide that, pull that up to the front. Can we flip to the Mac, please? Excellent. So there are 2 interesting things here. I've checked out the source code for Buck, and we build Buck with Ant because we're insane. You can see the activity monitor from OS X just down here. CPU usage is the thing to look. So what I'm going to do is let's do a clean. Going to just time a clean build of Buck and then running all its tests. So it's doing the compilation. Yeah, excellent. Now it's running the test cases. It's still running the test cases. And it continues to run the test cases. And I'm not going to wait, because it takes about a minute and a bit to do everything that it needs to do. So now what I'll do is I'll use Buck to run every single test in the file system, and to make it a fair comparison, I'll do a Buck clean. This will, because I'm actually in the directory that Buck is installed from, we may see a bit of Ant output as it bootstraps itself. We should be fine. But look at the CPU usage over here. What it's doing now is it's parsing everything. It's testing all the tests. It doesn't do a meme, right? And bam. In the time it took for me to describe what was going on, it's run every single test in the Buck system. And that took significantly less than the minute it would have taken if we were using Ant. So that's pretty cool, right? Can we go back to the slides, please? So at the time we did the switchover, it was quicker to pop up a warning on the Ant build saying, why don't you go and download it? You could download Buck, install it on the system, and do a complete build far more quickly than you could actually do than if you finished your Ant build, which is crazy. And the good news is, Buck is open source. You can go and download it. You can go and have a play with the build system that we use at Facebook. We accept pull requests. Please send pull requests. They'd be lovely. It's pretty nice. If you want to see the documentation, just head over to facebook.github.com and take a look at that URL. It's under the Apache 2 license, so if you're working in a bank, you're worried about having to suddenly make all your source code available because you use a new build tool, relax, it's okay. It is written in Java. I know it's not trendy, but it is a perfectly workmanlike language. And a small amount of Python, which makes the Pythonistas happy. And it works on OS X and Linux. Now, the reason it doesn't work on Windows is because nobody builds on Windows. Well, none of our team currently build on Windows. I'm sure at some point there'll be a need for it. So, I mean, that's a flippant comment, and it was fine. And, of course, we build Buck with Ant. So, yes, we've got this amazingly fast build time, right? And that allows us to test. Testing's good, right? We get our developers to write the tests. At Facebook, there is no SET, no SDET, no TE, no QAE, no test department, no QA department. We just have engineers. Now, some of the engineers have a passion for testing, in the same way that some engineers have a passion for databases, some of them have a passion for security, and some of them have a passion for finding pictures of kittens on the internet and posting it to their timeline. But we get our developers to write tests. Everyone who writes a line of code is expected to also be writing tests for that line of code, which is nice, right? Seems to be working out all right for us so far, and I quite like it, right? I always find that companies that have a test team, the test team tends to be looked down on and not treated with the love and respect that they ought to be, right? I remember, yeah! I love you guys, it's okay. Yeah, I remember sort of getting interviews from people going, oh, he wasn't good enough to be a coder, but he might be okay as a tester. And it's like, no, you've got it all wrong. They're not good enough to be a tester, they might be all right as a coder. And they just go, it wasn't appreciated in the way I thought it would be. Funny that, really. So what kind of tests do we ask people to write? We start with unit tests. Unit tests run using JUnit. Kenbeck works at Facebook. We're not using TestNG. Cedric doesn't work there. Kent does. For those of you who don't know, Kenbeck wrote JUnit. Cedric wrote TestNG. And we encourage people to write unit tests to run locally on the JVM because we appreciate fast. Fast is really important. Like, move fast, break tests. That isn't the Facebook mantra, but it almost is. In order to enable people to move quickly, they're using dependency injection. We can replace collaborators at test time using EasyMock. That's one of the libraries that we use. Mockito is another choice if you're looking to do things, but EasyMock is what we settled on at Facebook. But we're building an Android app. And if you include the Android jar from the Android development kit, and you run a test using it, what tends to happen is anytime you touch anything included in that jar, you get an exception with stub being the only message in that exception. And that's because what they've done is they've provided an ABI-compatible jar with no implementations, because the implementation runs on Dalvik on a device. That makes writing tests incredibly difficult. That's a bad thing, right? We don't like that. So what we do is we use a library called Robolectric. Again, it's open source. And what that does is it provides stub implementations or fake implementations of each of the Android methods, right? So what we can do is we can compile and test and run in the IDE on your desktop for a really fast developer feedback cycle. And that's nice because there's no compilation to Dalvik, no pushing out to the machine, the device or the emulator, and you can get that nice fast cycle time, and we appreciate fast. But unit tests don't cut the mustard, right? You will occasionally want to make sure that all the unit tests function correctly, and the software, when you plug everything together, doesn't fall over. I was on a project once which had slightly over 2,500 tests. The tests ran, it was a .NET project, the tests ran in about 2 seconds. It was amazing. And the app would consistently not start up. And it was because they'd forgotten to write integration tests and larger tests, right? And they were just using mock objects and going, yeah, it'll return null here and throw an exception here for exact same method. And you just, oh. No, guys, you need larger tests. Larger tests, there are a handful of frameworks that you can use. UI Automator, which came in API level 16, so basically Jelly Bean and above. I think it's there in ICS, but Jelly Bean and above it starts becoming useful. We use that quite a lot. We're writing our own test framework to allow you to write tests out of process and off device using UI Automator. We call it Bully because it pushes things around. I may have to come up with a better name before we open source it. Or maybe not, who knows. We also use Roboelectric for the older devices. There are some tests using that. We use Monkey Runner. We use a whole series of tools that come with the Android development kit. And they're all quite nice. But Roboelectric, UI Automator, those are two of the key ones that we use. By the way, we also run things like power tests and on-device tests and things like that. But these are tests that the standard normal developers write rather than crazy ones who really enjoy testing. You built the code, you tested the code. You kind of think it works, right? So you're ready, you're going to push it into master. So you remember way back in the black slide, there was arcdiff, right? What does arcdiff actually do? It kicks off the code review process, right? You'd write a description of what you do, you write a test plan, and if the test plan goes wrong, or the written equivalent, you tend to be told off and told to improve your test plan. And we send it up to a tool called Fabricator, which is like a Swiss Army chainsaw of project management. So it does tasks, it does code reviews, it does browsing of repositories. It allows you to do all sorts of clever, wonderful things. And we like Fabricator at Facebook. This is what a code review looks like. You can see here that the chap has submitted a reasonable test plan. It has been grayed out, but it's in purple. The reviewer has come back and asked him to make some changes. The developer has made some changes. That's what the little icon second from the bottom does. And then the reviewer's gone, this is good. You can check it in. Now, Fabricator has a killer feature. And I don't know if you can tell what it is. It's image macros. In the middle of your code review, you can just type a little line. And it will insert an image into the code review. This is American Obama, which is President Obama playing an electric guitar shaped like a bald eagle while wearing an American hat. I quite like that one. I stare at it endlessly. It's fascinating. And ship it. It's like, it's all done. Just ship it. Land the code. Do something interesting. To land it, we use a command line tool, Arc, short for Arcanist. It's the command line counterpart to Fabricator. And landing does two things. It runs lint, which can be run separately. And we use the Android linter with additional lint rules that we've added. So check for things like null pointer exceptions. So we use @nullable quite a lot from Guava. Optional as well. Like Guava Library, fantastic. If you're not using it, just download it now and use it. It's one of the best things to come out of Google for developers for a long, long time. It's awesome. We also make sure that all the APIs for the versions of Android that we support are all present, and other bits and pieces. And then we do an arcland. What arcland does is it takes your changes in your local branch, rebases them onto master, and then pushes your version of master into the central one. So if you take a look at the history of the project in Git on master, it's a single linear history. We don't have weird branching. It's just a straight down linear history of logical changes. Right, so you've landed your code, you tested it, it's all wonderful, right? No, hang on. We also have a continuous build system. If you haven't got a continuous build system yet, just use one. I don't care what you use, cruise control, Go. We use BuildBot, right? And you can see here that most of the time, things are pretty good. One developer has caused a test to fail, and so we're not going to move the stable branch. But when these tests all go green, then we go excellent. And these are sort of longer running tests. So these are integration tests, end-to-end tests that we don't want a developer to run on a local workstation because there just isn't time in the day. And if you're not breaking the continuous build server periodically, you're probably not working hard enough. That's what one of my friends used to say. I think he's right, actually. I think it's OK to break the build periodically as long as you fix it immediately afterwards, possibly by yanking your change out, reworking it, and resubmitting it. So BuildBot runs all these longer running tests, these power tests, make sure there are no regressions in performance or anything like that. And we're done, right? Oh, crap. Sorry, Nakam, you win the bet. He betted that I wouldn't profane. Does that count as profanity? I don't know. Shit. There we go. Done it properly now. So, yes, it's built. We need to dog food this thing. As I said before, when you get this application on your phone, if it falls over, a user may never download it again. That would be an awful, awful thing to happen. So we dog food extensively. And one of the platforms that we make sure that we dog food on is Gingerbread. Problem is, at Facebook, many of our developers are paid well enough to be able to afford an ICS or Jelly Bean device, right? And we can ask for like a Galaxy Nexus for testing and things like that. But Gingerbread is still incredibly popular. They're still churning out devices with Gingerbread on it. These are the latest numbers from the dashboard that Android have on their website. And you can see Gingerbread is about 45% of the market. So what we do is we make sure that people are voluntarily using Gingerbread as their primary device, and they're dog fooding our application. So they install the beta builds on their device, and they keep on using that. One of the key people using Gingerbread as their day-to-day device is a release manager for Android. He's not always the happiest person. But he often flags up pretty nasty regressions that no one else has caught yet, because they only show up as sort of outer memory exceptions on Gingerbread, where the devices are more constrained. So this is the PHP hammer, by the way. I don't know if you've seen it. It has nothing to do with the talk. I just love the picture. So you've downloaded the beta version of the app. You've side-loaded it. What it does is it periodically, at Facebook at least, contacts the build services and goes, is there a new version of the application? And if there is, it nags people to update it. So it downloads it in the background and then goes, would you like to install it? Would you? Would you? Would you? And you go, yeah, all right. And so once you're on the testing track at Facebook and you're always using the beta build, you're always using the most recent beta build, which prevents sort of old bugs being filed by people. And filing bugs is incredibly easy, because what people do is they take their device and they shake it. Now, we call it a rage shake, because you normally only shake your device when you're going, it's not working! Oh, hello, I can file a bug. Excellent. And that's kind of a really nice feature, right? So we get good instant bug reports from people as they're experiencing it using the latest version of the application, which allows us to do our releases. Our releases. Never thought I'd get there, did you? So you can pick two when you're doing a release. You can have features, quality, or a regular schedule. Wow, that's a kind of tough choice. If there are any project managers in the audience, features, quality, schedule is not 2, that's 3. So we decided that we were going to do time-based releases, which are high quality. That means that occasionally we ship without features that we've been working on, right? Now, the advantage of a time-based release, and our releases are about 4 weeks long. So what we do is we cut a branch, we do stability work for about 3 weeks, we have a release candidate for about a week, where we push it out to the beta testers and anyone in Facebook who volunteers for it. And then we ship to the Play Store. So once a month, there's an update to the Facebook application. And it's really nice having that regularity, because it means if you're working on a feature and you miss this release, you know that you're not going to have to wait forever before the next release, right? It means that you can get this stuff as quickly as possible. And it means, you've got that consistency, that regularity. You also know that your feature isn't going to be blocked as somebody else frantically tries to finish their thing. That's nice. So time-based releases are hugely, hugely valuable to us. And done isn't just, hey, it compiles and the test pass and, nobody's filed a bug with it yet on the release candidates. Done is things like, is the design work all finished? If we see changes going into the release branch around the design of a feature, then we know that the piece hasn't been finished. And if the feature hasn't been finished, we yank it from the release. We either hide it behind a flag and strip it out using Dex, ProGuard even, or we just remove the particular feature and we ask people to keep on working it. Logging. How do we know when we release a feature that it isn't causing a million crashes, right? We get metrics and feedback and information from the versions of Facebook that you're running on your phone. If something goes wrong, we get told about it somehow. Sometimes it depends. And we can look at that data and we can go, oh, crikey, there's been a sudden spike in crashes on this particular kind of device. Let's fix that, right? So we get information from the wild. If you haven't put logging in, we can't get that information. Sometimes there are server-side changes that need to be made. We still use web views in a few places. So if you're pushing a new feature, we need to make sure it works with the old and the new version of the app. And obviously, privacy and legal review are really, really important. Facebook cares about privacy. Like, we're a social network. If people don't trust us with their data, we're dead in the water, right? So we need to really, really be concerned with privacy, and we are. And legal review, just in case. So they're just as important as a code review, and that's what done means. So that's basically how we bake quality into the Facebook application, right? We go all the way through. We run tests consistently. We encourage people to use design patterns for testability. We have defense in depth. So there are unit tests, integration tests, the continuous integration server. We have people dogfooding all the time. We encourage people to use devices that aren't commonly used by people who have got well-paid jobs, but are used widely in the real world, particularly in the smaller markets, the emerging markets. Great. So thank you very much for your time. We've got time for some questions.
Great. Thank you.
Thank you.
Thank you, Simon. That was fantastic. I really like seeing the end-to-end. We have a couple live questions, so how about we go to the left first? Go ahead and state your name, where you're from.
Hi, my name's Christian from Google. Actually work on the Guava team.
Awesome work.
Yeah, well, that's more my other teammates, but...
The JDK5 backport.
Yeah.
Fantastic.
Working on that today.
Ship it.
But, so I wanted to thank you for some really innovative work on build systems, and putting that out to the community is a really awesome thing. So I'm glad to see it. I had a question about Buck, particularly because not all companies have access to all the source code they will ever build. So how do you handle binary dependencies of things that are, third-party libraries?
Yep. There's a rule called pre-built jar, where you can just check in. So we've got third-party dependencies. We don't build Guava from source, for example. Right. We just check in the jars.
Okay, you check in jars.
Yeah, we check in the jars. We have pre-built binary rules, and you can depend on those. The binary rules allow you to also attach source jars and Javadoc jars. And if you do that, when you run Buck project, it will actually hook in the sources so that you can browse into the source code while you're working on the code on your project.
Very sweet. And obviously you have an Eclipse plugin coming soon, right?
We accept pull requests.
All right, there you go.
Okay, looks like we have time for one more question, so we'll go over here.
I'm Dave. I'm from Family Search. So you mentioned that the code's in a single tree. Is that like all of the code at Facebook, or is it just the code for Android? And the other question that kind of goes along with it is, does that mean it's all in one Git repo, and how does that perform?
So at the moment, the Android code is in one repo, the iOS code is in another, and www, the website is in a third repo. I think, Google have demonstrated you can smoosh everything together, and that works pretty well for Google. I mean, we saw all the stats earlier, which were amazing, right? Just totally mind-blowing. So we could do it that way, but at the moment we have separate repos for the various things. But all the Android code lives in one tree. Cool.
Okay, actually, maybe we'll just grab one more, and then I have some announcements about dinner and things like that right after this. So go ahead, last question, please.
Hey, Noah Sussman. I'm an independent consultant, but formerly of Etsy, where I designed the CI system with pre-commit because it works so awesomely for like Google and Mozilla. And so why not? Why no pre-commit? I'm fascinated.
Just because we haven't had the need for it. The other thing as well is sort of we're a relatively small company. Like I know 1,400 engineers sounds like an awful lot, but that's 1,400 engineers spread over the web, the iOS app, the Android app, working on our internal tooling, working on stuff for our data centers, just everything, right? Facebook does more than just the news feed, right? We've got messaging infrastructure, we've got groups, we've got all sorts of fun things, right? So 1,400 engineers isn't actually that many. The team working on Buck there's about 3 consistent contributors, and then there are other people who join the team for a month or 2, and then they roll back out again. So, there's just isn't a huge amount of manpower. And it turns out that if you run all the unit tests before you check in, that catches most of the problems. So there hasn't been a sort of pressing need to have a pre-submit thing. When there is a need, then I think we'll do it. But Yagni is a really good mantra, right? If you've not heard of Yagni, it comes from the Agile community. You ain't gonna need it. So don't write it, don't use it until you actually have a need for it, right? And then put it in. So yeah, that's why we don't do it.
With that, thank you, Simon. Hopefully you'll join us for dinner. And
Thank you very much, guys.
Wow, that was an incredible day. There's a lot to digest, a lot of really fascinating, things we learned about, everything from how to, verify set-top boxes from UView, not you, the other one. We learned, from academia about how to use gaming and gaming-type systems to engage and create the next generation computer scientists and even do some very interesting work. There's just a lot to think about, so hopefully you'll think about it. Hopefully you'll share it, on the stream and everything that we have on G+ and Twitter. We'd love to hear what you thought was interesting as well. For dinner, what we're going to do is everybody's invited to dinner here up in the water tower, but because we're going to go through behind closed doors areas, we're going to have people meet us in the lobby, and then we'll take shifts of moving everybody up to the water tower cafeteria. Please, no photos once you walk through the secure doors. That would not be happy for you to do that. So please don't take any photos, but definitely come and enjoy dinner. And I hope all the speakers are going to join us, and you can go ask them further questions. So with that, start meeting us out in the lobby, and then we'll walk you up. So thank you. Thank you.